Good morning. Welcome to BayCon 2021, the BayNet Radio Conference. We'll start up at 9 o'clock Pacific time, so everybody grab a cup of coffee, sit back and relax and enjoy the program. We'll be back in a little bit. Welcome to the BayNet 2021 radio conference. Everybody grab a cup of coffee, sit back and relax, and we'll start the program at 9 o'clock Pacific time. Thanks for joining. Good morning, everyone. Welcome to BayCon 2021, the BayNet Radio Conference. We'll be starting up at 9 o'clock Pacific time in about 15 minutes. So everybody grab a cup of coffee, sit back and relax and enjoy the program. Thanks for joining. Welcome to BayCon 2021, the BayNet Radio Conference. We'll be starting at 9 o'clock Pacific Standard Time in about 10 minutes. So grab a chair and a cup of coffee and stand by for the show. Welcome to BayCon 2021, the BayNet Radio Conference. I want to invite everybody to pull up a chair, grab a cup of coffee, and settle down for a great day of ham radio information and sharing. And I'd really like to thank everybody for joining us today. We have a really fantastic program, and we're really looking forward to being able to bring this to you. So normally when we do the BayCon events, this is a live event in Silicon Valley, and we have all the local hams participating in the BayNet system, and others come and join us. But of course, this year we can't do that. So we're doing this virtually. So in order to kick things off and make things really work, we really needed a great group of people to really help drive and make this thing happen. So for this year's event, there's a core of folks that really pulled this whole thing together. Hang on one second. Okay. So we should be streaming now. So hopefully we're streaming video now. Great. All right. Good morning, everybody. I'm George, KJ6VU. I'll be your host for the day. And for today's event, this is a virtual event, unlike the normal BayCons, which are live and in person. So for this year's event, since we're doing it virtually, we needed a team of people to pull this together. So I want to start out by thanking those people who really made this happen. So that's John, W6TRF, Marcel, AI6MS. John and Marcel are running the drawing and the auction for today, and you'll hear them throughout the day. So we'll take a break between every one of the presentations, and they'll be able to read off the winners of the prizes as we go through the day. Then I also want to thank Rod, VA3ON, who's in Master Control. Rod's really been at the core of making all this happen and figuring out how to make the video and everything work really smoothly. So that's been really incredibly awesome. And also Vince, VE6LK, who is our master video streamer and has just been indispensable in figuring out how to make the logistics of this whole event work. So I can't thank these guys enough for pulling off the event. So a big round of virtual applause for them. So I'm going to spend a little bit of time for the first 20 minutes here giving you a rundown of today's event. So we'll start out by going through the agenda briefly. You can see we have about 10 presentations that'll happen throughout the course of the day. And these are really a set of fantastic speakers, and I couldn't thank them enough. Without them, of course, we wouldn't have an event. So we have quite a variety of topics, from antennas to test equipment and operating, and all kinds of great topics for you guys. So we hope you enjoy that. So big thanks to all the speakers for today. We're going to plan to end around 5 o'clock California time. And so the schedule here is pretty close to what we'll be sticking to for most of the day. One thing I'd like to remind everybody of course, this is being streamed live on YouTube. And when we go into the various presentation sessions, at the end of each presentation, there's the opportunity for you to ask questions. So during the presentation, feel free to ask questions, and you'll do that by entering your questions in the chat window of the YouTube video stream. So make sure you're looking at the YouTube video chat and ask questions there. Rod in Master Control will take those questions, and he'll be asking our guest speakers those questions when the question time comes at the end of every presentation. So let me start a little bit of background about BayNet. So BayNet is an amateur radio club centered in the Bay Area, in the San Francisco Bay Area. We serve the whole Bay Area from the San Francisco and north to the East Bay and Berkeley and Oakland, down to San Jose and Silicon Valley in the south. So a few fun facts. This is the 12th annual event of the BayCon gathering, although the first virtual one. And of course, since we can't get together in person, one of the big advantages of doing this virtually is that we get to invite a lot of other folks who otherwise couldn't attend because you're in a different area, or maybe this is just not a convenient time. So you'll be able to see a lot of the videos later on YouTube. So BayNet is an open amateur radio club. We service the whole Bay Area. We are not really a traditional club in the sense that we don't have regular in-person meetings. It's in a sense a virtual club anyway. So doing this over Zoom and YouTube is not that terribly unusual maybe for us. The real core of the BayNet club started out as our repeater network. And of course, that still is in a way the heart of the club. We have currently over 480 members. Now, what's a member? We have a mailing list of 480 people who've signed up to be members. So We consider ourselves to be a pretty good sized club. And of course, there's a big core group that are very active in that 480. If you would like to join, all you have to do is sign up on our mailing list, and then you'll be part of the club. So anybody can join. Everybody is welcome. It's an open club, and there's a lot of really smart folks that hang around there, and they're happy to help you out if you have any questions or need a hand with anything. During the week, we run several different nets. We have 2 different Red Cross nets. We have a 2-meter single sideband net. We have a digital mode net, and others. So there's usually some kind of activity on most evenings. And throughout the year, even though we don't have regular monthly meetings, we do a variety of events. And of course, over this last year, that's been difficult. But our big events are Field Day, PacificCon, BayCon, Winter Field Day. We do an antenna shootout once in a while. So we try to do get-togethers when we can. And hopefully in 2021, we'll be able to get back to that. We do have 2 organizations that we work with pretty regularly. So the BayNet system is used regularly on a weekly basis by the American Red Cross. We provide repeater system capability to the Red Cross for their ongoing operations and emergencies. And we also support FEMA Urban Search and Rescue Task Force 3 as needed for any kind of activities. So we're very much a community service oriented educational outfit. We also have another project we've worked on over the last 5 or 6 years called Radio Mala. Radio Mala is a project that was spearheaded, still is spearheaded by Suresh W6KTM. And the idea is to help the country of Nepal build a linked set of repeater systems around the Kathmandu Valley. And currently we have 1 repeater up and running at the University of Tribhuvan in Kathmandu. And we are planning 2 more repeaters to be installed in the area over the next year. So we help in the design of the system and the construction of the equipment, and then it's shipped to Nepal, and the engineering students at the University of Tribhuvan do the installation and maintenance of the systems. And one of the things that we help them with is to get an IRLP node up and running on their repeater. And so you'll hear them periodically checking in to the Red Cross nets on our system all the way from Nepal. So it's really been a great opportunity for us to help. And it's been a really good collaborative relationship. You can check them out on Facebook at hamradio.mala. So a little bit about our repeater system. The BayNet system is 2 repeater sites, 1 in the South Bay and 1 in the East Bay. This gives us really good overlapping coverage. We have both analog and digital repeater systems. For the analog systems, we have a UHF repeater in the East Bay. And in the South Bay, we have 3. We have a 2-meter repeater, a UHF, and a 900 megahertz FM repeater. Those repeaters are linked full time with a full duplex RF link, so that if you go into any one of those 4 repeaters, you come out all of the 4 repeaters. And this is really helpful in an emergency, as you'd imagine, to get greater coverage. And of course, we can turn different repeaters on and off the network as necessary. We also have the ability to gateway out into other repeater networks, both over RF and also voice over IP. We do sponsor a IRLP reflector 9096. So it's another gateway mechanism to connect out of the area. In addition to our analog repeaters, we also sponsor 3 digital repeaters. So we have DMR repeater, we have a D-Star repeater, and a Yaesu Fusion repeater. The DMR repeater, in addition to the repeater itself, is connected to our own talk group 31075, which everybody's welcome to use. And also on the Fusion repeater, WW6BAY-room is available. And we do link both the Fusion room and also the DMR talk group together. Well, today's event is all about learning and sharing and normally getting together. And here we're just getting together, but virtually. But the other reason we do this is the annual fundraiser for BayNet. So in order to run this operation, we have an annual minimum budget of about $2,200 just to pay for the ongoing expenses. This covers repeater site rental, insurance, and other services. In addition to that, we have projects that we do, and the cost of projects varies. Over the last year, for example, we had to repair our D-Star module. We had to put in a new D-Star gateway, some new networking gear. So we have a fundraising target this year of $3,200. And I want to thank everybody for buying tickets to the drawing and also considering bidding on some of our silent auction items. everybody who's interested in sharing this information on the that we're doing in the presentations, it's all free, so you're welcome to it. And if you got a free ticket, you do get a chance to the drawing. So there's no purchasing of tickets required. However, if you do feel generous, if you could afford it, we would certainly appreciate any donations. And you could do donations either as a direct donation, or you can just buy a whole bunch of raffle tickets. And the more tickets you buy, the better your chances of winning. So I'd like to encourage you to buy tickets. John and Marcel will remind you of that almost every hour. So we hope you consider that. So we're well on our way to hit our target. As we started this morning, we were over $2,000 to the good. So we're about 2/3 of the way to our target. And so we hope by the end of the day to hit our target so we can keep the BayNet system up and running and keep making improvements to that. So thank you all for your generous support, and we really sincerely appreciate it. So the drawing will be explained by Marcel and John in more detail, but basically we have 40 items in the drawing. Everybody, even free ticket holders, get a chance to win that. And also we have a silent auction with about 10 items that are up for bid. BayNet is a 501c3 tax-exempt organization. So if you do make a donation, you will also be eligible for some sort of tax write-off between you and your tax accountant. You can figure it out, but we can give you a letter of donation if that's necessary. So please do be generous and consider a donation. So as of yesterday, these are the folks who all bought tickets. And I know since then more have. So if your name's not on the list, I apologize for that, but we had to cut off making the list. So all of these folks went above and beyond and bought tickets or donated. So I want to thank you all very, very much for your kindness and your contributions to keep things going. It's really, really appreciated by the whole Bay Area community. And for those of you outside the area who like the content that we're producing, we hope that you see value in that as well. So we also want to say a big thank you to our sponsors. Our platinum sponsor is Flex Radio this year. This is the first time Flex has been a sponsor of the event. And we'll talk a bit more about what that means going forward for BayNet. They've been super. They've been very generous in helping us figure out how to do some new projects we're excited to talk about later today. They'll be providing some additional giveaways we don't have on the list yet, but we're still working on that list. So we're going to have some really cool stuff. There's also some promotional discounts. If you're interested in buying a Flex radio, you can take advantage of some special BayCon discounts, and we have special BayCon codes for that on the website. Our other sponsors are Digilent, Pactena, and Elecraft. So Digilent makes the Analog Discovery, which is a really fabulous USB connected piece of test equipment, and I highly recommend it. I've bought a couple myself. I think they're really great, and they were very generous and donated two of the Analog Discovery Ultimate packages worth $500 each, and those are up in the silent auction. Pactena has donated antennas, and Elecraft has donated a signal generator. So please support our fabulous sponsors. Thanks for that. So here's the discount codes. You don't have to write them down. You can see it on the website, but all the different radios and amplifiers, Flex is offering a discount for the BayCon event today. Just a couple more things before we wrap up the introduction. In 2021, the BayNet Club has got a big slate of things we'd like to do. We are installing new battery backup systems in the repeater site, both for the analog and the DMR repeater system. We are also working on extending our TCP/IP over the air network between the two sites. We've been running a 3.4 gigahertz point-to-point network for several years. And as you probably know, that spectrum is being reallocated away from the amateur service as a secondary user for cellular. So that's being decommissioned. We have, however, been implementing an NPR70 TCP/IP system, and there's a whole groups.io page if you want to follow along with that and share info with other folks interested in doing TCP/IP networking. We also are working on our D-Star repeater system. We replaced our UHF repeater module already. We're installing have installed a new duplexer. We'll be installing a new gateway. And we also have the DD module on our D-Star repeater that's installed, but it hasn't really gotten much use, and we're hoping to get that going. And lastly, we've been working on a project. David, KI6ZHD, has been leading a project to build a thing called a DV switch. And a DV switch is a Raspberry Pi based IP switch that allows us to bridge the different digital modes. So we'll be able to bridge, for example, between a D-Star repeater and our Fusion repeater or our DMR repeater without you having to do anything. So it's something that is pretty exciting, and we're going to figure out how to make that happen and hopefully be able to deploy that this year. One of the things that people ask a lot is what's going to happen to all the content that we're sharing today. And first off, all the videos that you see presented today will be available on YouTube. So after the event's over in the next few days, all these videos will be posted. So if for whatever reason you can't be with us for the entire day, then you'll be able to check out all those presentations on YouTube on video. And all the slide material will be available as PDFs on the BayNet website. And the audio for several of the sessions will also be in the Ham Radio Workbench podcast audio feed over the next couple of months. You can find out more info there at hamradioworkbench.com. So the last thing I want to touch on is how can you help? So if you're interested in doing something to support the BayNet effort, the organization and our activities, quite frankly, the most important thing any of us could do is be active. So whether it's with BayNet or your local club or your local area, get on the air and do be active. You know, sunspots are kind of at the bottom of the curve, and now we're hopefully starting to crawl out of that. So it's a good time to get your shacks all squared away and working well, so you'll be ready when the sunspots come back. So get active. We always ask for donations. BayNet's free, and if it's not convenient, then we don't need your money. But if you enjoy what we do and you see value in it and you can spare a few bucks, we're always happy to take your money. Thanks for that. Also, volunteer. No organization happens without the volunteers. And for this event itself, it took 5 of us to really put in a huge amount of time and effort to pull it together, in addition to all the great presenters who all spent a lot of time creating their content, many cases videoing their content and editing it and making it presentable. So that's a significant amount of time that could be spent doing other things, but they did it to share their love for the hobby and also to help educate and entertain each other. So volunteer for something. It doesn't have to be making a YouTube video. It could be just helping out at the club meeting or whatever your next event is. So we highly encourage that. And lastly, lead something, take on a role. I really admire our good friend Suresh, who has been the person really driving the whole Radio Mala effort for Nepal. That's a phenomenal effort. That's not just showing up at the club meeting and handing out the coffee. This is really a difficult challenge. The people that put the content together for this event, I mean, there's just a lot of things that take leadership, and you need to step up and do stuff. And if everybody does, then we all have a great time and we all learn and really enjoy our hobby. So I'd like to encourage everybody to consider that. So that's a bit of the background about BayNet and what we'll be doing today. So at this point, what I'd like to do is to hand it over to John and Marcel, and they're going to walk through the details of how the drawing and the silent auction is going to work for today. Have a great time at BayCon 2021.
Thanks so much, George. Hey, thanks everyone for joining us today. Really exciting. My name is Marcel, AI6MS, and I'm joined by my esteemed colleague, who's on mute but would love to introduce himself to everyone, so don't worry.
Thank you. There's 2 knobs, video, and that's all I have is 2 knobs, and I can only do one. I'm John, W6TRF. Thanks, Marcel.
So John, I have to ask you, what time is it?
It is drawing time, Marcel, and folks, you are going to hear that a lot today. We have over 4,000 tickets in the virtual drawing hopper. And so, Marcel, do you want to talk a little bit about it before we pull our first numbers out?
Yeah, absolutely. So I'm going to take a couple minutes and just walk you guys through the drawing and auction that we're doing today. So remember, as George has said, today is a fundraiser. So every single dime from the event goes to funding BayNet's open repeater systems. We'll go into this in a little bit on the next slide. People will ask a lot of questions and details, so we'll get into those. If you have other questions, feel free to drop them into the YouTube chat and we'll try to get to those. We know that the Eventbrite is currently closed for ticket sales because, of course, the event started. So we'll be working to fix that hopefully during this presentation and get that back up again. Let's start right up and just go to baynet.org/prizes. So this is the page that you can go through throughout the day. We'll have everything listed there. So bay-net.org/prizes, and we'll go there right now together and kind of walk you through this process. So when you get there, this is the main page. And there are two main areas here that you can participate. One is the opportunity drawing prize list, and then the other is the silent auction. So we'll go ahead and start with the opportunity drawing prize list. This is the list of all the awesome things that people have donated for the event. So this is all from private individuals and other folks that just wanted to support the club. You can see lots of great DIY kits, some SDR kits, some solar power stuff. We've got random wire antennas from Pactenna. These are really, really cool, great for soda or other portable events. And yeah, just lots of really cool prizes. So we got over 40 prizes. Oh, what's this? A second life lithium iron phosphate battery. You should go put your tickets in for the drawing. That'll be a fun one. Rigmaster, all sorts of great fun stuff. So if you haven't looked at this list, be sure to go click on that and you'll see all the great opportunity drawings we have throughout the day. John, what's your favorite one on the list here? Do you have one that you're really excited about?
Well, I have a Pactenna and I love the Pactennas, but the mystery boxes, for any of you who have been at a BayNet event in the past live, amazing stuff comes out of George's garage, and those mystery boxes are filled with stuff from George's garage. And again, it's really good stuff. So you can't go wrong with a mystery box either. How about you, Marcel?
That's great. Well, I'm excited to see who's going to get the lithium iron phosphate battery pack that I rebuilt. I've spent a lot of fun time on that. You'll be hearing about that shortly, but it's a neat little project. So the other things on the page I want to talk about, I guess we should mention, so drawing tickets, you can purchase those throughout the day. We'll get the Eventbrite up shortly, but that link is right here. So that'll bring you to the Eventbrite page where once it's activated again, you can go ahead and drop in here and get additional tickets. John will be processing that list throughout the day and go through there. Do you want to briefly explain what that looks like, John, or do we want to do that a little later?
Yeah, well, I can tell you that what happens is when you all go to that page and buy more tickets, I immediately get an email and it tells me how many tickets you purchased. And we have a sheet working here where I enter your name and the number of tickets, and we just basically have contiguous numbering. So basically, since in the last 5 minutes before the store closed, which we're working on reopening, we had about 150 tickets purchased, and those are entered. So again, as you purchase them throughout the day, we will be checking for new purchases during the presentations, and then we will increase our little random number wheel to include the new purchases as well, and we'll do our drawings off of that. That's how it should work, Marcel. I'm hoping that's how we rehearsed it. So.
Absolutely. How many tickets do we have total right now? Do you know? So we have about 175 people that have bought tickets, and some of them can buy multiple drawing tickets. So that'll, of course, increase their odds.
Yep, absolutely. We have over 4,000 tickets currently in the virtual hopper. And
exciting. So you can
hope
calculate
to grow
your
that
odds
number
based
quite a
on
bit
that.
more. Yeah, awesome.
Yeah, and just a reminder, anyone that registered for the event does get a free drawing ticket, so that's part of the deal. The opportunity drawing is a great way to support the club, and buying more tickets does get you more opportunities to win. All right, so the next part I want to talk about is the silent auction. This is a cool thing that we did. We've got a bunch of sponsors, including Digilent and Elecraft, Flex Radio, Pactenna, and a bunch of BayNet members that donated additional cool items. So if you scroll down a little bit further on the prizes page, you'll see this live updating auction bid location. So we've got 9 amazing prizes that are listed here, and you can see the max bid for whoever bid there. There's about a minute or two delay on this, so refresh the page if you're really anxious to see if you're still the highest bidder. And these are some great prizes. So this first one, this Digilent Ultimate Analog Discovery 2 bundle, this is really something stellar. So people are really excited about it. It's one of George's favorite tools. And we'll go into some more details briefly here, but this is just where you can see the max bid. So if you're ever wondering what the current bid price is, you can come here and see, and everything right now is being bid on actively. We've had people actively bidding all morning. We'll be shutting off the bids at 4 o'clock Pacific. So 4 o'clock Pacific today is when we'll be ending the bidding for the day. So make sure you get your bids in early. You need to click that submit button before I turn off the form. So make sure that you go take care of that as soon as possible.
Hey, Marcel, if I could add one thing to that. I noticed this morning for those of you out there, if you bid and you receive an error, it means that you bid below what the current bid is. Sometimes, like this morning, I went and bid before I actually looked to see what the high bidder currently was, and I received an error. So if you're having an error, you might want to either visit the page to see what the what the current max bid is and submit the bid again, or just increase your bid until it doesn't get rejected.
Yeah.
So
yeah, and a couple other people in the chat were saying they were having a couple issues with the form. So you need to make sure there's a valid email address in there, and then your actual name and call sign, that'll be private to the event managers, and then the public name that you're using that you're willing to put with the bid. If you want to be anonymous, that's perfectly fine, but if someone else puts anonymous, then you won't know if it was your winning bid or their winning bid. So anything that's in that public name field is what we'll be announcing at the end of the event for the winners.
And please make sure that the email address that you use is not a spoofed one, but one that you actually monitor, because if you should be fortunate and win the item that you bid on, that is the email address that we're going to be contacting you at. And we need to get a reply in order to get you your goods. So please, please make sure we know how to reach you.
Yeah. So the website, again, for a couple folks that are just joining us, it's bay-net.org/prizes. And I'm sure Rod will drop that in the YouTube chat for us as well here shortly. And one other question around how the drawing will work. Since it's fully virtual and it's hard to do it real time, we're going to be drawing one item at a time, and then that'll get assigned to that winner, and we'll reach out to you after the event. If you want to pass on the item because you don't want it, then we'll redraw after the event and reach out to other winners. So do keep an eye on your email over the week or two after the event for sure, because we'll be busy working along there. Okay, and then the last bit I want to just show off here is the silent auction catalog. So if you want to go actually bid on the silent auction or get more details on the items, you can just click on this one. And this opens up a nice Google form. It's got all the details on the bidding. Please do read through the rules. This will kind of give you an idea of how we're running the event, and give you an idea of multiple bids and how we'll be handling those as well. So do take a look at that if you have any concerns or questions. You can always reach out to us over the chat as well. So here, like we said, your email address and your full name and call sign, this will be kept private, but this is so we can help reach out to you and know where you're located. And then your public display name on your bid. So these three fields are required. We need that information in order for the form to submit and in order for you to get your bid in. So please make sure that you fill that out completely. And then you'll see all the items listed down here. So the first one here is this amazing Digilant Ultimate Analog Discovery 2 bundle, which is a $529 MSRP. Really awesome that the folks at Digilant donated 2 of these. So the top 2 winning bids will get this item, 2 items total. So if you're number 2, you won't necessarily know if you're number 2 unless you're watching the bids very closely. So at the end of the day, we'll make sure to let you know who that number 2 was. So then all you do right here is in your answer field, you'll enter your bid amount. Let's say I want to bid $475 because I think that's a great deal still for this amazing kit. And then you can go in and bid for anything else you want here as well. So we've got some QRP Labs transceivers. We've got, a Whisper beacon. We've got this amazing Elecraft programmable signal source. We've had one of these at BayCon last year as well. These are really, really cool little piece of test equipment, great for all sorts of debugging in the field. So yeah, you can enter all your bids here, and at the very, very bottom of the page, you'll have this nice little submit button, and you'll click on that and get a confirmation page to say that your bid is accepted. And a few minutes later, if you go back to the main bay-net.org/prizes page, you'll see your bids update live. So looks like we've got quite a bit of bidding activity going on. So that's great. And remember, all of these proceeds go straight to BayNet and support this great organization. So really looking forward to having everyone contribute. John, anything else you wanted to add to this page?
I think you covered it, Marcel. And if there's things that you've missed or if you're having difficulty, again, please enter it in the YouTube chat. And we're also going to go over this again a little bit at the lunch break if people run into issues or have more questions.
Sounds good. So John, let's go to you real quick and go ahead and show me how this drawing works. And I'll go turn off my screen and people can watch.
So the wonders of, as fate would have it, I have a green screen and I have an app that's a random number generator, which occasionally has a green background as well. So if I hold it at an angle, you'll see that I have an app here, and currently the number says 1408. And I don't know if my video is coming through or not. I see Marcel still.
Yeah, you're good.
You're good. Okay. If I hit the randomize button, you will see that the number there is 3803. So then I would look at my master list of who holds the lucky ticket 3803, and I would read the name out. And I'm not going to read it out this time because I don't want that person feel bad that we practiced with their name. But I'll just throw a first name. There's a David out there, and it was a David that won, and we're going to do that. And again, your tickets will be, the nice thing about this approach is your tickets will be put back in the tub. So you can if you only came with one ticket, you can still win more than once. So there you have it.
That's awesome.
Anything else I need to cover?
I think that's great, John. Let's go ahead and do our first drawing then. So start off the day right. We're going to do prize number 19. This is a beautiful RTL SDR dongle donated by Ray, KF6GPE. Thanks for supporting the club. And this one will get mailed directly to the winner. So John, do you want to show us who the winner is for this awesome item?
Yes. So I'm going to hit the randomize button, and the winner is 3701. 3701. I'm scrolling through my list here. The winner is Larry Groom. Larry Groom.
Congratulations, Larry. There's our first winner for the day for the RTL SDR dongle. Look for an email in the next 24 hours or so after the event, and we'll be in touch for that. We're going to do 2 more items real quick. So prize number 10 is up next. This is a QRP Labs QRP dummy load kit, $20 value. It's great for all your dummy load needs. And John, what does it look like?
And the winning number is 2342. Scroll here. Beautiful thing about a long list, but it does take a while. 2342. 2342 is Frank Dries, Dries. Frank Dries.
Congratulations, Frank. Alrighty, and our last item before we switch over to our presentations, an awesome G5 RV antenna donated by our very own Christian NV2J. Thanks so much for donating this. Great little antenna, awesome for all sorts of uses, home or field day. And John, who is it?
Yep, and I saw Christian on the chat earlier. Thank you, Christian. And the number is 2496. So here, 2496. Let me make sure I've got the 24. A lot of ranges here. Jason Minich, 2496. Jason Minich.
Congratulations, Jason. So there are our first 3 prizes for this bunch. Remember, it's a fundraiser, so go to baynet.org/prizes. That's bay-net.org/prizes throughout the day, and we'll make sure we can get that figured out. So thanks again, everyone, for supporting the event. And George, we'll hand it over to you.
All right. Thanks a whole lot, Marcel and John. That's a great kickoff, and hopefully everybody understands how it all works. And we're working on the registration page on Eventbrite to make sure we can get that set up so we can take more ticket sales. So the first presentation up this morning is a guest speaker who you've already met, and that's Marcel. So Marcel is going to talk to us about second life of a LifePo 4 e-bike battery for ham radio purposes. Go ahead, Marcel.
Hello, welcome to Second Life lithium iron phosphate e-bike battery pack rebuild. My name is Marcel, AI6MS, and let's get started. First off, this is me. I'm Marcel, AI6MS. I was licensed in 2008 as KI6QDJ while I was a student at Cal Poly San Luis Obispo studying for my master's in electrical engineering. These days I'm very involved still with the Cal Poly Amateur Radio Club. I'm a Cupertino Aries and with the Salinas Valley Repeater Group. In my day job, I design batteries and charging systems for consumer electronics products, and in my free time, I love playing with batteries. So my slides and videos are available at my QRZ page. You can reach out to me via Twitter or on my YouTube as well. So hopefully you'll enjoy the presentation. So today we're going to be talking about converting a lithium iron phosphate battery, a used e-bike battery in this case, into a 12-volt amateur radio friendly battery pack. So we'll talk about kind of how I got the batteries, doing a little bit of background and debug on them, how we rewired the pack, some modifications to some of the peripherals and features on it, and then the final testing of the pack and how it performs to some other packs that you might buy new. For some other information and a background info on lithium batteries, I have some other presentations that go into a deep dive into lithium iron phosphate chemistry and why it's such a great choice for amateur radio. And feel free to check those out on my QRZ or YouTube page as well. All right, first off, a little bit of safety. Batteries are inherently dangerous, lithium batteries particularly. So this presentation is not qualifying anyone here to perform those tasks. If you're taking on a battery project, please make sure that you know what you're doing, that you're properly trained, that you have the right personal protective equipment, and yeah, just be careful. So especially with used batteries, just be extra safe because you don't necessarily know their history, and just want to make sure that you're taking the necessary precautions. Okay, with that out of the way, battery use. Reuse is really, really cool. So in the electric vehicle market, batteries and even in consumer electronics, batteries are typically considered end of life when they're around 70 or 80% capacity. So typically, if you look at manufacturer's data sheet for a lithium iron phosphate battery, it'll say like after 300 or 500 cycles, it's got 80% capacity left, and then we don't guarantee it past there. For electric vehicles, for example, like e-bikes or cars, often once those packs hit that sort of capacity limit, they don't perform as well. So you can't accelerate as quickly. They get hotter when you charge them, and they just aren't as exciting for the customer. So typically they want to use them for some sort of what we call second life application. That might be grid storage, or in this case, amateur radio. So in this presentation, we'll be talking about these e-bike batteries that I got my hands on. There's a pile of them here below, these 9 batteries that I picked up, and specifically the lithium iron phosphate ones. So a lot of these e-bike batteries, like these bottom 2 here on the right, those are using standard lithium ion 18650, as lithium ion chemistry. The rest of the ones here are all lithium iron phosphate, which we particularly like for amateur radio. So we'll be focusing on those in today's presentation. All right, so when you get a used pack, or why is a pack no longer being used for its original purpose? Whole bunch of reasons. Pretty commonly, they have a failed BMS or battery management system, where it's just a cheap electronics board in there, and if it failed for some reason, it'll usually fail safe and prevent you from using the pack for anything else. Other common issues are cell over or cell under voltage protection that kicks in. So that's where the pack has a condition where one of those cells went too high or too low in voltage, and then it went into a safety protection state. Under voltage is pretty common, especially if packs are used very heavily or develop a short condition, or if they've been sitting on the shelf for a really, really long time, they might just have depleted. You could also have just simply a blown fuse where someone used the battery too heavily or tried to pull too much current from it and it blew a physical fuse. Or you could have physical damage, which you want to be really careful with, right? So if there's physical damage, that is a pretty big concern and likely not a pack that you'll want to reuse unless you remove the damaged cells from that. So if you get your hands on some used battery packs, it's really up to you to inspect and decide what you're going to do with that. If you're going to reuse it or take it apart or dispose of it, recycle it somehow. The first one is obviously do a voltage check. In this case, top left right here, you can see this pack is normally a 38 volt pack and it's sitting at around 16 volts. So that's a less than happy battery pack, but it still had battery voltage at the terminals. So that's a good sign. It means the battery management system is functioning. You could run a capacity test on the packs as is and see how much capacity they have. Maybe you don't want to spend time on a pack that only has 20% remaining capacity. So there are a bunch of different options there that you could think of for how much work you want to put into it. Other simple ones, you could check the fuse, of course, like we said. In this case, these packs have a nice little removable fuse module here that you could just pull out and take a look at. And then history is also important. So usage or storage conditions could tell you if it's worth reusing this battery. If the battery's been abused and being used at high temperatures and high currents a lot and being stored at high temperatures, it'll likely be much more aged and not have as much capacity remaining or usable life left. So those are things you can test again with the capacity test, or you might have a clue. Like this battery pack right here had a capacity test performed on it back in 2017. So that pack was at least 4 years old. And that's a good data point to know that packs also have a finite, or cells also have a finite shelf life. So that's just something to think about. And then lastly, damage. I mentioned this on the last slide, but it's really important to think about this hard, especially for an e-bike battery that might have been rattling around on the back of a bicycle for a long time. When you open it up and inspect it, it's really important to look closely and just see if there's any physical damage that you can tell. And if you're unsure, better to be safe than sorry and just pass on that pack, get another one. So here's one that we opened up. This is a 38.4 volt, 9 amp hour Prodeco Technologies battery. It has a really nice voltage meter on top, which is kind of cool, and a little tail light in the back as well. And you can see on the inside there's a lot of foam padding, right? So with pouch cells in a e-bike situation, they actually had almost a centimeter of foam on all 4 or all 6 sides of that battery pack, just to make sure that it's well protected on the bicycle. And that's just, shock and vibration conditions from being on a bike, something to keep in mind. Other than that, this pack is very nicely laid out in the inside, right? These are some of the connectors on the front, nice silicone wire. This is the battery pack when it's removed, barcodes and some labels on there with capacity ratings as well. And then the old battery management system attached here to one end actually has some info on it, 5 amp charge, 15 amp discharge, 36 volts, some no-name brand, and yeah, it was actually still working. I wasn't going to use this BMS because it's for a higher voltage, so I took that apart a little bit further, took off the heatsink and took a closer look. It's really interesting to see there was a little bit of water damage on this, which is surprising because it's inside the battery pack, but that just goes to show how usage and storage conditions are not always straightforward. So definitely something you want to think about when you're looking at these packs. All right, so next up is rewiring the pack. So we talked about this pack as a 38.4 volt, 9 amp hour lithium iron phosphate battery. And the actual cell configuration on the inside is 12S2P configuration. So that means there are 12 sets of cells in series, and you can see these red wires are connecting each set of cells in series, and then 2 in parallel. So each of these is actually 2 cells in parallel, and then that connects in series with another 2 cells, which connects in series with another 2 cells, and so on and so forth. So you can see there are rows of 3 here, and there are 4 sets of those. So it's 12 in total that gives you this 38.4 volt nominal pack. So if we do the math on that, that's 24 individual pouch cells, which are normally 3.2 volts for lithium iron phosphate. And for a 12 volt amateur radio use, we want to reconfigure that into a 4S pack. So we want 4 strings in series. And since we have 24 cells, that would be 6 in parallel. So it's a 4S 6P battery pack as shown here. That gets us a 12.8 volt nominal cell voltage or nominal pack voltage once you have this pack fully built up. So first, you need to take it apart. Here are all the old balance leads. You can see each individual cell has a tap on it, a voltage tap that goes back to the battery management system, and just slowly peeling back all the layers to expose the individual cells. Really important to do this carefully. You can see how much Kapton tape is here, just insulating all the terminals. Really critical not to short anything. So here in the top left, as I'm starting to desolder each of the old leads on there, I'm always covering up all the cells underneath, or as I'm removing solder from one, putting electrical tape over it here as well, just to make sure you don't have any shorting conditions. All it takes is one of these wires to short across one of these cells, and it gets a pretty dangerous situation very quickly. So do this carefully and make sure you are very, very meticulous and paying close attention while you're doing this. When I had the cells all disconnected, so all the leads were removed, I didn't actually have to reconfigure the physical pack, which is what's really nice about this conversion. I could just leave them as exactly as it is, and then add a bus bar, add bus bars across it. Since I was doing pairs of 6, right? We said 4S6P. The 6 parallel cells are right next to each other, so we can just run one piece of tinned copper wire across those cells and carefully solder onto all the leads that were already soldered from the previous joint. So it's actually a really nice way to do it. While I had the packs all apart and the cells were just in pairs of 2, I went ahead and checked all the individual cell voltages as well. They'd been sitting for a little bit, and they were all within about 5 or 10 millivolts of each other, which is great. So that shows the pack is actually in pretty good condition. Sometimes you'll find that after you take the cells apart and they sit there, some packs might have much higher self-discharge, and they'll start drooping pretty quickly. If you have the option, you might want to rebuild the pack, take apart the pouches and separate them from each other, and then just pair up the good pairs with each other and create one new pack. So that's just some things to consider if you're building a new pack here. So once we finished rewiring, this is what it looked like. Again, we did a 4S6P, right? So here's our main battery negative, and then we've got the positive of that set tied together with the negative of the next set. And then again, 6 cells tied together there, and then the tail end here all the way up to the positive end. And then you can see each of these individual red balance leads all going back to the battery management system here on the end, with then the negative output that goes to the connectors on the outside of the pack. So this is what it looked like. Run a couple tests here real quick, make sure all the voltages look good, make sure the battery management system kicks in, and that's pretty cool. A quick word on battery management systems. These are absolutely required. I do a little bit more of a deep dive in my other presentation, but high level, you need to have one. These manage over voltage, over current, over temperature protection on the packs and make sure that the cells are never put in an unsafe situation. So absolutely critical that you include one. Since we removed the old 38 volt one, we now want to put in this 12 volt BMS, or they call it a 4S BMS since we're using the 4 series cells. For this build, I used a brand named Dali, so Dali BMS. They make some pretty low cost and very high quality. They're actually nicely potted, rubberized enclosures in aluminum, and they're great. You can get a 20 amp one for just 12 bucks, and they work really well, come with the balance leads and everything. The 60 amp version is just twice that, so $24, and that's a really, really effective way to get a pack built quickly and safely. If you want to take it up one notch, you can get their Smart BMS. I just got one of these and I'm starting to play with it. Comes with a little Bluetooth module. The main unit's a little bit bigger because they have the Bluetooth module, the Bluetooth interface and some other smarts built in. And it's quite a bit more expensive, so it's about $48. So it's again twice the price, and then you're adding another $12 for a Bluetooth module. But it's a fun little tool, and you can show your battery capacity to your friend. I've used other smart BMSs before on my other battery builds. This is my first time buying one of Dali's. Excited to try it out, so those are pretty neat. Key thing here is that you want to size the BMS for the cells you're using. So if your cells are only capable of putting out 10 amps each, and you have, let's say, 6 in series, that means that this pack could put out 60 amps, right? So then you want to make sure that your BMS is at or below 60 amps. You don't want to, or that it cuts off at that stage. You want to make sure that you're never able to pull more than your pack can take. And ideally, if you can set those parameters, you can configure them. So the smart BMSs, the really nice thing there is you could actually oversize it so that you have more FETs and you have lower series resistance. But you can then configure the actual cell voltages, the high and low voltages. You can configure the capacity and lots of other things. So that's been kind of my preferred way to build packs, just because I really like having the control over the battery management system. But most people will probably find that a regular, the $12 BMS will do the job perfectly fine. So yeah, that's kind of my spiel there. There are no-name options out there. You can get way cheaper. You can get $4 or $5 BMSs. I wouldn't recommend it. The couple dollars more that you'll pay for a Dali that's known to be pretty good quality, and a lot of people are using those successfully, I would just go with that. So that's my simple answer. All right, so now for the fun parts. So this battery pack, it being an e-bike battery pack, has some cool features on it. So it sits on the back, on the trunk of the bicycle, and has a little tail light on it. So you can see this little red light with a little button that you click on and off, and it turns on these 5 red LEDs. So I was like, this would be really cool to keep in the pack, just a nice little light source, for running at net control or in your shack, or just as an emergency light for the battery pack. So I wanted to see how we could convert this to 12 volt. So originally it's about a 15 milliamp drive voltage or drive current for the LEDs using a 2 kilo ohm resistor, and that's designed for kind of the 40 volt pack voltage. So that's the board here in the bottom right. That's what it was. You can see it's a pretty hefty resistor. It's about a half or 1 watt resistor, I think, because it's burning about half a watt of power for current limiting, given the amount of voltage drop. So that's pretty significant. But when you run the numbers for 15 volt pack to keep it around 15 milliamps, it's around 333 milliohms or 333 ohms and less than 1/8 of a watt of power dissipation. So you can see here's the modified one with the smaller resistor. Just dropped one in there that I had in the shop, and it works great. Very easy mod. Change out one resistor, make sure the math is right, and then you have these LEDs. They change the brightness a little bit depending on if the battery is fully charged or not fully charged, but we don't care. It's just a simple tail light and a really cool way to just have some light on the pack. So the next cool part is the capacity meter. So the capacity meter sits on the top of the pack and is just a one push button. So you literally take the pack and then there's one push button on the top, and it turns on the lights to show you what the capacity is. So that's really cool. Again, this was designed for the higher voltage, the 12S pack. So I took this on the bench supply and just swept through to see where the voltage set points were, and its operating range was about 27 to 41 volts. So as expected for the higher voltage range, but it just uses a simple LM324 quad op amp. It's actually only using 3 of those op amps to then drive the 3 LED outputs for the red and the 2 green lights. So this one was a little bit trickier. I wanted to figure out how can I adjust this and make sure that it works for the set points that I want for 12 volt for the 4S battery pack. So this took a little bit of reverse engineering. This image on the right is kind of a conglomeration. I took a picture of the front and the back of the PCM of the circuit board and overlaid them so that it effectively was like a layout program, and I was looking at it, and then I wanted to pull the schematic out from it. So I started tracing out all the nodes, writing down all the resistors and their values and where the LEDs were and where everything connected, and was able to pretty much get them all figured out. Writing down the resistors and the tolerances, what voltages I'm seeing at different nodes, the reference Zener that they had for a 2.5 volt reference, and then all the nodes that everything was connected to. So I just started naming the different circuit nodes and then throwing it onto a little schematic. So simple schematic just on a notebook, input voltage, goes and drives the voltage reference, and then you have the main voltage divider that feeds into the comparator. And this is really the key one. You have your 3, 2, and 1 output, which was for your red, green, and green LEDs. So looking at this, I plugged this into a nice little spreadsheet and figured out that R4 is the one that we can tweak and have the values work out the way we want. So looking at it here, in the original 12S state, at 27 volts, all the lights would be off. At 27.7, the first light would come on. 35, the second light would come on. And 41 volts, the third light would come on. And then when I plug in 19.5 volts, those set points scale down very nicely for the same thresholds, but at a 4S voltage, which is great. So we did that here, and then those were the voltage thresholds. And I checked that against the per cell levels, and that was pretty much the same. You can, of course, tweak these if you want to. If you wanted the voltages to, the LED bars to show different voltages or different levels based on a different voltage threshold, you could change it, of course. Spreadsheet's pretty easy to make. It's just a voltage divider. In this case, I said, well, I might as well just use the same thresholds that they had, so the same per cell voltage thresholds, and just scale it down. The nice thing is I happen to have a tin of 39 kilo ohm surface mount resistors sitting in my shop. Of literally randomly had this tin, and as a result I could just use those and put 2 of them in parallel onto the circuit. So nicely stacked them here, just one on top of the other, into the R4 position, and voila, the circuit just works at 4S, and it's really sweet. So now the same pack has just a voltage meter on top of it. A very handy little feature. Go press the button real quick, convince yourself that it's got full voltage, and then go out for a field day or to soda or whatever. So it's a really nice way to just get yourself some confidence in the system. Okay, and then the finishing touches to the pack itself. Top left here, this is doing a test fit, making sure how everything fits in there, how the wires all are going to route in, where I want to put connectors and stuff. This is before I wrapped all the foam back around it. That was pretty critical, but it all fit in there quite nicely. The really neat thing is how I could fit the power pole mount. So it was just like within a millimeter was the right size. I could fit this 2 power pole panel mount from PowerWorks into this spot on the bottom of the battery pack. And it's right next to the original blade connector for the actual e-bike on the back of the bicycle. And that fit perfectly. The other really nice one is I was able to put a 30 amp thermal circuit breaker right where the old fuse mount was. So there was a 10 amp fuse there before, was able to pull that out and then put in a higher current thermal breaker. Same spot with the nut, fit beautifully. So this is from the inside. You can see just running wires here between this is fused on the positive side, and then the BMS is sitting on the negative side. So just a little bit of extra safety. Disconnected all the other ports. There's a charge port on here as well that I didn't end up using. You could plug it up if you wanted to, but it's just not hooked up to anything, and that works out pretty nicely. Of course, we have to hook up the peripherals as well. So we had the voltage meter here. This is on the top of the unit, and then the tail light, the red tail light, of course. Got to have all those blinky lights on here, and have those wired in to the power pole output as well. So those will be downstream of the fuse and downstream of the battery management system as well. So if anything goes wrong with the battery, both of those will stop working, which is exactly what you want, so you don't over discharge the pack. Here's all the foam put back in place, everything taped up nicely. And then, of course, put some stickers on it, because we all have stickers laying around and never know what to do with them other than put them on your laptop. So I thought it was great to just put a bunch of stickers onto the outside of the battery pack. So, Ham Study sticker on the top, and Arc Electronics, a friend of mine, an ARRL sticker, and what else do we have? Some more ARRL stickers, a DX Engineering sticker. There we go. They were also helping out. So it's pretty fun to just put those on there. And then the really important one is all the labels on the bottom. So labels and specifications, this is just really helpful to have, especially if you're building something from scratch. If it's a bespoke little system, you want to make sure that you remember what it is. So a couple months from now, when I pull this out of the garage and say, hey, what was that? How did I build it? What are the specifications for it? Making sure that you have that available. So this one says on the bottom, 22 amp hour, 12.8 volt lithium iron phosphate battery, made by Marcel, December 2020. It's a 4S 6P pack with a 40 amp DALI lithium iron phosphate BMS and a 30 amp thermal circuit breaker. So that's critical. That tells me what's in there, reminds me what kind of BMS I used, what the specifications are. I can go look up that data sheet for that BMS and make sure that I remember how this one worked. And I also put the recommended charge on here, so 14.5 volts at 4 to 6 amps tops, and then the tested capacity that we tested it at the end of 2020 with 22.5 amp hours at a 2 amp discharge. So that's a pretty important thing to put on there. Highly recommend everyone buys a label maker if you don't already have one. It just makes all your projects a little bit more organized and easier to figure out in the future, both for yourself and for anyone else that you might give it to. Okay, and then lastly, we're going to do some charging and testing out. So once you've finished reassembling the pack, fully charging it to the top of charge and allow it to balance completely. So balancing is where you allow the cells to get to the exact same voltage, and the battery management system will do this automatically at the top end of the charge. So it's called top balancing when it's usually above like 80% capacity. And you'll want to let it sit there. So it's the first time you're doing it for that pack, and the pack's been sitting around for a while, and the cells are hooked up like this for the first time. Let it sit at least overnight, maybe a day or two. You can always check the cells individually and just see once they're all stable and comfortable, then you kind of are good to go. I then ran a capacity test. So here's my little West Mountain Radio CBA4 computerized battery analyzer. Great little system, absolutely love that unit, and use that to run capacity tests. So I ran 2 different capacity tests, one at a 2 amp discharge rate, so kind of a lower discharge rate, and then at a 10 amp discharge, so much higher rate. That's more if you're transmitting on a mobile radio or on a HF radio. Those 2 numbers together will give you an idea of kind of the health of the battery and the overall capacity. So the green line here, this is the 2 amp hour discharge, and we got down to about 22.5 amp hours of total capacity. So that's pretty good. It's about 83% of the original capacity of the pack, or the cells, I should say. And then at the 10 amp discharge, you can see obviously the voltage is lower at that point. And then the discharge is a little bit steeper here because it has a little bit more internal resistance. And it ended a little bit less, so around 22 amp hours, about 82% capacity. So all in all, 81, 83% capacity in that range. It's pretty good for a used pack. And this definitely performed exactly as I expected. I was pretty happy that it still had, more than 80% usable capacity left. And that works out pretty well. So if we compare this back to a normal battery, so a normal 20 amp hour off-the-shelf battery would be about $200 or $193. This BioNO one, I actually own this battery as well. That's a pretty common one that you would have. For this pack, I spent $42, and most of that was on a power pole mount because those are expensive from PowerWorks. The thermal breaker was $6 off Amazon. The BMS was $16 off eBay. I think I got it shipped with some other stuff as well. Yeah, that actually works out pretty well. I should put a little plug. After I did this project and started buying some to build more batteries, I found this guy called the Crazy Ham on eBay, and he makes these little 3D printed single power pole panel mounts for about $3.50 if you buy a couple of them from him. Really cool. I just bought some, haven't used them yet, but it's a great little way to support small businesses and also to get a cheaper solution for just getting a single power pole, because you don't usually need both. Depends on it, how you're using it, of course, for your setup. But for like a simple SOTA activation where you just need one port, that might be sufficient. So thinking about lifetime for this pack, so lithium iron phosphate batteries typically have 3,000 to 5,000 cycles of capacity, depending on how they're discharged and how they're used. So if we have about 80% tested capacity remaining, or 83%, I think we said, on this graph, this is just from some website, PowerSonic, they have kind of a remaining capacity versus cycle life. So if our remaining capacity is here around 82% or so, we've got about 2,000 cycles used, right? So if it's got 3,000 to 5,000 cycles total, somewhere about half of it is probably used up. Depends on how aggressively it was used before. But I'd say that's pretty good. So 50% usable life, and you still have 22 amp hours of capacity left right now. So for a battery that was otherwise going to go into the trash or get thrown away, that we can get several more years. And honestly, I don't think I'm going to be using a couple thousand cycles unless I put this into an off-grid solar application. I'll probably be using it a couple cycles a year, maybe a couple cycles a month if I'm actively doing something. So this will last plenty of time, and that's a really cool way to just reuse batteries. So super exciting. I did want to give a big thank you to Joel W6TC for giving me these batteries. He called me up after he saw one of my other presentations and said, "Hey, I've got a bunch of e-bike batteries. Would you like to use them?" I said, "Absolutely. I'd love to play with those and try this out." He also runs a small business, so just like the Crazy Ham guy, if you like supporting small businesses, he runs this company called Western Active. I just replaced my tower climbing utility knife with one from his website. Really cool, bright orange, and attaches to my lanyard, so when I go do my tower climbing, it's a great way to have a nice new knife and replace my like 20-year-old one that was on there before. So hope you enjoy this presentation. All my slides and videos are available at my QRZ page. You can reach out to me, ai6ms@arrl.net. And a little plug just for people wanting to get their licenses or upgrade their licenses. Fully remote amateur radio exams are a thing. You don't have to wait for in-person. During COVID, it's no problem. hamstudy.org/sessions has all the sessions being hosted. There are dozens of ham sessions being held a week, multiple every single day. So there's no excuse to not get your license or get upgraded if you're already licensed. So thanks very much for watching, and I'll look forward to the Q&A.
All right. Thanks so much, Marcel. That was a fantastic presentation. And I didn't even know you can get those LiFePO4 batteries in that form factor. I've seen a lot of cylindrical ones. So normally when I see those flat ones, I think they're lithium ion batteries. So that was really interesting. Hey, Rod, do we have questions for Marcel in the chat?
Oh, do we have questions? The most common one, which is coming from Peter, from a couple of others, is, Marcel, where do you find these battery packs?
Yeah, that's a great question. The problem with second life electronics and anything that you're using multiple times throughout, getting used after their initial use is finding a good source for it, right? In this case, a friend of mine has a friend who runs an e-bike repair shop, and they obviously go through a lot of batteries. So anytime they have a customer that brings back an e-bike that has some issues, they have these batteries, and they're in a state that they have to dispose of them. And then for a business, it's actually very expensive to dispose of damaged lithium-ion batteries, or lithium batteries in general, since they have to ship them as class something 9 or hazmat, ground shipping only, right, with all sorts of special packaging and special permits and 2-day notice to FedEx and that sort of thing. So honestly, if you can come up with a good local business that needs some support, figure it out. The challenge is if you're finding those packs and then you need to dispose of them yourself, you now have effectively commercial batteries that you need to dispose of. So I haven't worked through all the 9 that I received yet, but if any of those need disposal, you'll have to work through your city's household waste and make sure that they don't flag it. I've had friends that have had issues disposing of waste because someone says, no, this is business waste, this is not personal waste. So that's one tip. The other one is Craigslist or FreeCycle or stuff online put out wanted ads as well. I've seen actually quite a few e-bike batteries on Craigslist or other sources like that, and that's a good way to do it. But yeah, the challenge, I think it was one of the other questions too, is around whether or not they're lithium iron phosphate or just regular lithium ion batteries. A lot of times those e-bike batteries are 18650 lithium ion cells, so they're like NCM or some other chemistry that's not lithium iron phosphate. That makes it less usable for amateur radio use unless you do some tricks with charging or with a voltage conversion. So my recommendation there is do your research and look around closely. Those Prodeco Tech batteries are great. The pouch cells are really easy to work with, but your mileage may vary.
So related question to that from Tim, for soda work, what's the weight difference or maybe the weight to density ratio for the flat packs compared to say the round cells common to the bioanodes?
Yeah, great question. So a pouch cell, as the flat packs are called, where they're just put into a silver pouch, generally those have a better gravimetric energy density. So they have, without the extra metal around them, they're generally, as a cell itself, lighter weight overall for the same amount of energy. The trade-off there is, like in this case, you saw that the pack has this massive plastic case all around it, right? And that plastic case and the extra size and spacing there really does add a lot to the overall weight and heft of the pack. So you have to protect those pouch cells so they don't get pierced or something. So it really depends on the pack construction. If you look in the RC world, they often just take the pouch cells and just put one round of heat shrink around it or vinyl heat wrap, and they kind of hedge their bets and say, hey, if it crashes and the thing burns in the field, it's okay. But that's probably not a good suggestion if you're going to be going out and doing, public service events or doing soda work.
Very good. Hey, so another question: how long did this whole project take? So, what sort of safety precautions? What kind of plans did you have in place when you're working on these?
Yeah, that's a great question. I mentioned a lot at the beginning around kind of damage for the packs and, making sure that you know what you're getting into, right? If one of these was damaged or got physical damage to it, there's obviously some hazard. So a number of things. One is a buddy system, right? So my wife always knows when I'm working on batteries, I make it very clear. I leave the doors open. So if there's any noise or sparks or anything like that, working fire alarms, smoke detectors, keep a window open nearby, throw it outside in the backyard instead of having something burn in your house, or work on it in the backyard. And I'm half serious about that, right? Especially if you're working around pouch cells, they're much more fragile and they're easy to pierce. If you're using a metal screwdriver or a knife to cut the little tape away, that can be very, very dangerous. So those are things to think about. Generally, these packs aren't too high voltage. Once you start getting in the 50 volts range, OSHA gets more excited. So that's where you'd want to wear more gloves and insulating gloves. I'd still recommend it because they're just sharp objects. Glasses, absolutely. Safety glasses, always wear them. You don't want anything sparking out or when you're cutting things or desoldering. Always a good idea. Wash your hands early and often. The other one that's commonly used in industry is just a bucket of sand. So keep a bucket of sand around. If a battery does start to go, you'll have sub-seconds sometimes to get out from the time you notice that it actually is going to go. Throw the sand on it. It helps contain the blaze, if you will. It doesn't stop it. It doesn't put it out, but it does help contain it. That's used in industry as well. In my workplace, we just have old milk pails, effectively, of sand or paint cans, and that can help a little bit as well if you don't have time to chuck it out the window. Those would be my general precautions. Yeah.
So another question here. So in terms of the failure modes, how much does a particular cell decrease the whole capacity, or is it just that amount, or is it worse?
Yeah, so I think there was a question from Mark there. I think I'll try to address that in two ways. So one is if you have an individual cell that's decreased, like lower capacity, or is failing sooner than others, in the just degradation state, so not actually failing yet, but it has less capacity or has higher internal resistance, it'll just behave differently in the pack, right? So if you have a bunch of cells in parallel, one of them has a much higher resistance than the other one. Other ones, the lower resistance one will be passing more current, and that's just kind of naturally how it works. That higher resistance one will usually have less capacity, and then as a result, your overall pack capacity will go down for any individual parallel cell that's lower capacity. Now, if you have a failure event, so if that high resistance pack now goes short and fails short, which is a pretty common short or failure mechanism for lithium batteries, where dendrite growth or some other way they pierce the separator between the cathode and anode, you will have a lot of energy going to that short. Ideally, it's just to the point where the self-discharge increases significantly on the pack. But in the worst case, if it's a sustained short, then you have that heat generation. That's when you have thermal runaway and involuntary disassembly, rapid disassembly of the pack. So those are less exciting.
One of my favorite terms.
Yes, rapid disassembly. Yeah.
So to that point, we hear a lot about catastrophic failures of lithium-ion batteries, and that lithium iron phosphate are safer. Could you comment on that?
Yeah, absolutely. I go into a little bit more depth on that in my other presentation on my YouTube if you're interested as well. But high level, they use different electrolyte, they use different chemistry, chemicals inside as well that makes the lithium iron phosphate chemistry generally quite a bit safer to work with. So you very rarely hear, they're a little bit more tolerant to over voltage events. They're a little bit more tolerant to high heat without getting into a dangerous state. Because really you need that combination of an electrolyte that's going to go boom quickly, the high temperature and the volatility of it. The other thing, I should have mentioned this earlier too, is what voltage you're working on the pack when you're taking it apart. I'll charge them full and cycle them to test them, but I will never work on a pack and reassemble the pack when the cells are at max capacity. It's when they're above 90% capacity, that's when your thermal runaway hazards are that greatest. When they're below that, it's actually pretty hard to get a cell to go boom by itself, unless you're really trying. So I would always discharge my packs to some nominal cell voltage, 50% capacity or less. That'd be my big tip as well.
Okay, so one thing that I learned from this presentation is the new term of rapid spontaneous disassembly. So remember that. That's a great presentation. Thanks. We got a lot of great comments in the YouTube chat here. So thanks everybody for asking questions. And at this point, what we're going to do is shift gears a little bit here. And I want to introduce Marcel. So I'm going to punt it back to you live. So Marcel and John, go ahead and take it for the next drawing.
Sounds great, George. Thanks so much. And I hope you guys are enjoying the show so far. Remember, this is a fundraiser. And what does that mean it is? John, what time is it now?
It is drawing time, and I remembered to unmute myself this time, Marcel. So there
Awesome.
we go.
We're all getting better every day. So remember, every dime of today's event does go to funding BayNet's open repeater systems. Do visit the website bay-net.org/prizes, and we'll drop that in the YouTube chat again. You can buy more raffle drawing tickets there. You can get you can bid for the silent auction. You can view all the items that we have for sale or for drawing and for auction. So go check that out. Winners will be contacted by your email, so make sure you're using an email that you can receive. Make sure you triple check spelling. And then just a friendly reminder, the silent auction bidding ends at 4 o'clock Pacific time today. So make sure you get your bids in well before 4 o'clock. Bidding has been very active today. So we've got a lot of good prizes that are going up by the minute. So doing that. All right, so the moment you've all been waiting for, we're going to be raffling off this beauty right here. This is a hand-built, custom Second Life lithium iron phosphate e-bike battery that you just heard about in this presentation.
Signed edition, signed edition.
I could sign it if you really want. I've got a silver Sharpie here somewhere. We could pull that off, John. So John, do the raffle. If you win it, I will happily deliver it to your house, but let's see if
Marcel,
we can rig
you earlier asked me which of the things I was really eyeing. And as much as I love the Pactenas, and again, I'm not shilling George, I love the Pactenas. I want to change what I really want. I want the battery now, especially after the video. Yep. So yeah, good job. So here is the drawing. We'll get my little spinning wheel in the picture, and the lucky winner is number 1353. We'll look that up. 13.
Better not be my ticket.
I know, or mine, right? 1353 is, I want to verify it so we don't have any fights. 1353 is Paul Kostka. Paul Kostka. You are the lucky winner.
Congratulations, Paul.
The Second Life LiFePO battery.
I did do that tongue twister on purpose. Second Life LiFePO battery is usually how people pronounce it, and I love that double entendre there. It's just me. Awesome. Well, congrats, Paul, for winning the Second Life battery. We'll be in touch to get that to you. Thanks everyone else for getting tickets as well. We've got a couple more items in this round, so let's get through those. This is a really fun one from George, an Arduino solar power kit. This is one of 3 today that we'll be raffling off. Solar charge controller, solar panel, and a nice little lithium polymer battery. You'll notice this pouch cell. They come preset for your wonderful joys. $25 value. And John, who's this one going to?
And this one is going to number 2938. 2938. And 2938 is 2938 is Robert Green. Robert Green, you are the winner.
Congratulations, Robert, for winning an Arduino solar power kit. Great job, super exciting. All right, we got another one here, prize number 30, a USB Digimode 3 dongles, isolated digital sound card modem by XGG Comms. And John, what do we got?
We have number 1452. 1452 is Forrest Fleming. Forrest
Fleming. Congratulations, Forrest. All right, we got one more. This is a bonus prize. These prizes were not in the listing, so if you were paying close attention, you're here today. This is a beautiful super elastic signal stick antenna made in Utah by hams for hams. All proceeds go to support ham study and exam tools, so you're doing a great thing. This will be shipped to you personally. And yes, they do glow, and yes, my green screen takes it out, so it's good fun. Who's getting this one, John?
Okay, this is second on my list of ones I want to win. So here we go. And the number is 3396. 3396.
Oh, Rod, you got to slow down the YouTube because it's about 30 seconds delayed. People are getting the answers on YouTube chat before we actually get it out to you.
Oh boy. And the answer is Bruce Forrestal is the winner. Bruce Forrestal.
Congrats, Bruce Forrestal, for winning the first bonus glow-in-the-dark signal stick. So that's all we have for this round of drawing prizes. So remember, it's a fundraiser and everything goes out to support BayNet. So bay-net.org/prizes, and you can go sign up and get more tickets and have fun today.
And we will be processing them as they come in. We kind of have to stop about 5 minutes before we draw, so we have time to make all the entries. But please keep purchasing, and we're getting them in just as quickly as we can.
All right, great. Thanks, Marcel and John. So next up, we have a presentation by Doug Millar, K6JEY, about amateur radio test equipment. And Doug, who's also known as Dr. Zarkov, he is a very active millimeter wave, microwave, and EME operator and builder. And frankly, just about everything that Doug says, I could just listen to him talk all day. So he has a fascinating presentation about amateur radio test equipment. Take it away, Doug.
Hi, I'm Doug, K6JEY, and welcome to JEY Lab.
Technical difficulties. We'll be right with you.
Stand by. So here we go. All right,
Hi,
so Doug's
I'm Doug,
coming up next.
K6JEY, and welcome to JEY Labs, where we have fun in the garage.
Other screen, Vince.
You can see behind me is part of my bench. And
so this is always the fun part about these events. We're always working through these fun challenges with technology, isn't it, George?
You know it's technology is just great, right? Yeah, there is no Memorex here whatsoever.
So by the way, the next two presentations I think will be real interesting because they're both on the theme of test equipment.
There we go. I think we got it this time.
Hi, I'm Doug, K6JEY, and welcome to JEY Labs, where we have fun in the garage. You can see behind me is part of my bench and some of the instruments that I use. Today, we're going to talk about instruments you can use and what you might select for new or used equipment. So we'll start that with a screen share, and here we go. Test gear for hams. Modern choices on a budget, pretty much. So the most fundamental gear that we use is digital multimeters. You want to get one that measures quickly and zeros quickly, signal generator, GPS or 10 megahertz source of some kind, spectrum analyzer, and power meters, and some standards. So we'll go through that and some other things, and hopefully you'll find some things of interest. First of all, you might want to ask yourself, which gear do you use the most and whether it needs to be upgraded, which ones need to be upgraded, and what you might need in the future. You're thinking of expanding what you do, bands that you're on, and so forth. And what kind of gear will you want to keep or get because it's your favorite, something you used when you worked in the industry and always wanted to have, that kind of thing. So that's some of the considerations. But if you write those down and think about it, that'll give you a list to work from when you go to the swap meet or you look on eBay. That should be helpful. So this talk is mostly about new equipment, best bang for the buck, absolutely. And it's listed from the most common gear to the oldest gear, least common. First is multimeters. I did this the other day just for fun. I scraped together a bunch of multimeters, mostly flukes, and tried to see how well they worked and whether they were still in calibration. And I used my 50 ohm handy calibration resistor, and this old fluke 6060A was still in calibration and read to 100th of an ohm. It's amazing. The rest of these all read 50 ohms as well. It shows that if you buy good instruments, it's worth it in the long run. Here's the two multimeters I suggest if you're in the mood to buy something that's really durable. A new one would be the Fluke 115, and an older one would be the Fluke 77. The 115 is a little bit smaller and easier for one-hand operation. It also has a true RMS AC voltage and current readings. The old 77 has been around for decades. You can drive over it with a car and it'll survive. And they're about $50 used each. Get some good test leads. I've used mine since 1980 something, and it still works and it's still in calibration. Highly recommended. Here's one for the benchtop. It's again another Fluke in 8840A. A lot of these were military, and a lot of them weren't. That doesn't necessarily mean that they're bad if they're military. Just try and get one in good shape. Some of them have kicked around quite a bit. Get one that looks nice and it'll probably operate nice. They very rarely need fixing. They read, they're 5.5 digit meters, stay in calibration. They have 4 wire ohms readings, and a null reading, a null compensation and things like that. They're a very good bench meter, maybe all you'd ever need. Here's something you do need if you don't have one, is a clamp-on ammeter. It's a DC AC ammeter. AC is easy to do, DC is a lot harder. This thing will read down to 1 milliamp DC amperes. It costs about 35 bucks. And it means that you can measure DC circuits without breaking the connection and putting an ammeter in series with it. You just clamp the meter on the lead and it gives you the current reading. At 35 bucks, if you're gonna do any kind of troubleshooting at all, this is really a no-brainer. Power meter. Well, I've talked about lots of different power meters, and this is the one that sticks with me. It's a Bird 4410A. Each slug is good for 7 ranges, and you probably only need 2 slugs. And they're not that expensive. And if you add up the cost of the meter and 2 slugs versus 14 slugs and a Bird 43, it's a no-brainer. But this one is 5% of reading accuracy, and the 43 is 5% of full scale. And they pull some tricks to keep the accuracy somewhat in line. But 5% of reading is a very good meter. And there are many more than 2 slugs. There are at least 12.5 slugs, depending on what range you want, so forth. But this is my recommendation for a watt meter. Frequency sources. Well, good old BG7 TBL has come out with quite a few things, and this is one of the good ones. I have, I think, 2 in my lab. Put a GPS antenna on it, and 10 megahertz comes out. You can monitor the digital stream if you want to, but basically, if the lights are right, the thing's working fine. Give it about a half an hour to warm up. GPS oscillators not only have to warm up the TCXO that's inside or the OCXO, but they have to average the GPS signal over about a half an hour. So I would say if you bought one of these fresh out of the box, I'd let it go for half a day or a full day before you did any serious measurement with it. Signal generators. I like this little guy. It's little. It has a serial input output. You can change the frequencies on the front to anything you like, between 1.5 and 1296 megahertz. You can program these 2 buttons to anything. So let's say you're band spreading a 5-band shortwave receiver, and you're going from one end of the dial to the other. On a regular signal generator, you have to go back and forth and back and forth. This one, you can set the buttons to be whatever you like and go back and forth between the buttons and do the band spreading. It makes the job a lot easier. It also has calibrated level outputs of 1 microvolt, 50 microvolts, and minus 33 dBm and 0 dBm. It's not cheap, but it does the job of most of what you do for receiver alignment and maintenance. The only thing's missing is something at 455 kilohertz for IF alignment, but that's fairly easy to come up with. If you want a more complicated and general purpose signal generator, I still have to recommend this, an 8642 A or B. They're listed as 100 kilohertz to 2 gigahertz, but they have an audio generator in here, down on this part, that comes out in this other connector between 0 and 100 kilohertz with a calibrated output and calibrated frequency. So in fact, using the two connections, you can go between 0 and 2 gigahertz. It has an extremely good attenuator. It's very stable. The thing is way over designed. It was an effort to recapture the market after the 8640 became old. And the only thing I'd say about them is that, like a lot of the older gear, as soon as you get it, replace the fan. This one is really simple. Take 2 screws out, pull out a little drawer, take out the old fan, put a new fan, plug it in, put the drawer back in, and 2 screws. Because when the fans go out in these older pieces of gear, it burns up the power supply. I mean, it incinerates the power supply. So putting a new fan in after 30 years is probably a good idea, especially if they've been run a long time. These have been going for $500. They've increased in price, but I'm sure you can find one at a reasonable price. This is a basic piece of gear and worth spending some money on. Or you can go Chinese. BG7 TBL again, he has a 15 gigahertz signal generator and a 4 gigahertz one. Several of the models have little different variations. One of them has an attenuator, but I think you're going to be better off if you go with an external step attenuator of some kind. You're going to need to have enough attenuation to do 110 dB in the step attenuator. But look around on eBay. There's a lot of stuff, depending on the frequency range you want to work with, that may fill the bill. But an external attenuator is necessary. But you're going to spend, this is $168. Some of the models are a little cheaper. And then $50 to $75 for an attenuator. You've got a small, easy to use, compact 12 volts signal generator to bring to the problem, rather than this guy where you have to bring the problem to the generator. So it depends on how you want to decide on your lab. This is not a bad idea. Okay, my favorite subject is spectrum analyzers. There are a whole fleet of these little guys out, and there's some new Chinese analyzers that have a lot of the same parameters. Almost all of them indicate frequency and amplitude really well. And in fact, that's what you want to use an analyzer for most of the time. But the inexpensive ones have a relatively wide filter in them, probably a crystal filter that's 2.5 kilohertz wide. So the closest in you can get is 2.5 kilohertz. And I think the minimum scan width is about 100 kilohertz. Nevertheless, you see really well and well enough at $175. And it's portable. It's battery operated and portable. It goes to the problem rather than the problem to you. It also has an external USB program. You can hook up the cable, light up their free program, and you get a much better display that makes it and puts it in competition with some much more expensive analyzers. There's also a waterfall display. It really is much more than it seems as an analyzer compared to other things. Here's a trick I did last year for the microwave update. I put in a bias T and an LNB, a low noise converter with a WR75 input on it. And I turned my signal generator on about 3 feet away at 10 gigahertz, 10.368. And here's the signal on the analyzer. The LNB down converts the input to 618 megahertz, and the analyzer is tuned to 618 megahertz. So you have a battery operated, handheld, portable 10 gigahertz spectrum analyzer. Look at what Anritsu charges for those. $4,000-5,000 bucks. Okay, so yes, we'll move on. Probably the best bang for the buck on this type of spectrum analyzer is an Anritsu 8212B, MT8212B. These are cell site maintenance boxes. They generally come with lots of add-ons, like this one has a power meter. They have a antenna analyzer, cable default checker, and a VNA, a 2-port VNA. They don't usually take, they may take a 10 megahertz input, and this model has an RS-232 input and output. They're battery operated, the batteries are cheap, portable, they're generally in very good condition, and very versatile. For the money in getting a spectrum analyzer, it's probably the best bang for the buck. They're very durable. Some of the older analyzers, HP and Tektronix and so forth, if they go dead, you really have difficulty in finding anybody to repair them. Here's a close-up of the screen. You can see that the signal is again from the LNB at 10 gigahertz, converted down to 618 megahertz, and it shows the amplitude of the signal. Now that's at this particular scan width. This does not have the problem of close-in inspection. I think the resolution bandwidth is something like 10 hertz or 30 hertz. So you really get a full-featured spectrum analyzer with this, and all the usual indications around the display, several traces, 3 or 4 traces, and you can compare them. All the regular good tricks of a more expensive analyzer. The screen's a little small and it's a little bit old, but for the price and the functionality, this is by far the best deal. However, my favorite deal is the next model up. These are Anritsu 2712Es, 9 kilohertz to 3 gigahertz. They're a current production model. I don't know why they're so cheap. They work extremely well. They generally have a few accessories, but they don't do cable to analyzer stuff, and they don't do VNA stuff. It's really just an analyzer. But it does have a GPS receiver in it that will correct the master oscillator frequency, so that down at the bottom here, when it's operating, it'll say how accurate it is. It'll be parts per billion accuracy. The analyzer is basically SDR. So it checks itself every time you turn it on and calibrates itself every time you turn it on and calibrates the frequency every time you turn it on. But it's a really very sophisticated current production instrument with local area network, USB, all those kinds of interconnections and remote programs. And it's really quite a tour de force that's at a good price. Okay, I did the same thing with this. Let me move this little box. Did the same thing in a different band. I got a 24 gigahertz mixer. It goes from 18 to 26 gigahertz from an HP accessory mixer. Turned on my 24 gigahertz spectrum analyzer that was about 3 feet away. I tuned this RF Explorer signal generator. It's DC to 4 or 5 gigahertz. I tuned it to 4 gigahertz at 8 milliwatts. And I sent that into the LO port of the mixer and ran the output into the spectrum analyzer. So here's my signal generator 3 feet away at 24 gigahertz. So here's a handheld, battery operated, portable, 24 gigahertz spectrum analyzer for less than $2,000. Now you're missing a couple of things. There's no pre-selection in the front, and there's no attenuator. But at these frequencies, attenuators are easy to make. I've also used the same setup for 47 and 79 gigahertz with the external mixers and the same RF Explorer signal generator. Works very nicely and worth the trouble. And yes, it will work on the previous model. This setup at 24 gigahertz will work with this guy. So you're keeping your costs down and enlarging your capability. Oscilloscopes. Okay. You want one with auto set. I know you probably love your Tektronix dearly, but it may not have auto set. And you want one with 256 levels of intensity. A lot of the digital oscilloscopes have just a blue trace that goes across, and there's no intensity levels. Everything's the same intensity. when you get different levels, you get a more analog type display, like this guy. Here's a Rigol DS2102. And you can see the AM modulation waveform is very detailed. That makes a huge difference. And there's all kinds of other things. The math capabilities and the digital storage with the USB. You've got record and playback. These things are now about 5 or 6 years old, and they're about $500. This is the one I would recommend. It's just bang for the buck. It's about the best. Except for this. This is a 100 megahertz single channel oscilloscope, handheld, battery operated. It has a really nice display. This is how it really looks. It reads frequency and voltage. It has auto set, and it has memories for the displays. So you can go over and make a measurement, push memory, and then go back and analyze it. And you can dump it out the USB charging port to a program to annotate it. These are like less than $100. There's not a single 12AX7 in the thing. There's not even any 14-pin DIP ICs in it. And it works well. So this is the second. The DC ammeter and this are my biggest no-brainers. Okay, frequency counter. I'm not going to say too much except good old BG7 TVL has a couple of frequency counters that are good. And again, small, handheld, 12 volts. This reads 13 digits. It has an OCXO in it. You'll never read 13 digits accurately. Probably never read accurately, but it does have that. And it has some math functions of average and peak and that sort of thing. But for $115, 0 to 6 gigahertz, that's a pretty good counter. Miscellaneous. Yes, the LCR meter. Everybody needs an LCR meter. And when I get done telling you, you're probably going to get out your phone and start looking on eBay, and more power to you. This is a DE5000. It's a Chinese remake of a B&K $500 meter, and they're good. They're very good. Mine was only about 4 counts off of absolute, which is amazing. It has a 100th of an ohm resolution resistance, and it has ESR measurements, equivalent series resistance for capacitors. Now, most capacitors need to be checked at 10 kilohertz. Otherwise, you'll get an erroneous reading. So make sure this is set at 10 kilohertz. You get an ESR reading on the capacitor, and you get your little ESR chart out that says the value of the capacitor and the voltage and what the approximate ESR value is. ESR values are not real tight. If you get a box of, you get one of these meters, get a box of capacitors and go through it. The same values and look at what their ESRs are. It's obvious which ones are bad. The other ones are off a little bit, and then there's one that's a clunker. Okay, that's the bad one. What it allows you to do, provided the circuit is discharged, is to do in-circuit capacity checking. You don't have to pull a capacitor out to see whether it's any good. You simply put the leads on it, and it'll tell you whether it's any good. In-circuit capacitor checking. The 100th of an ohm resolution allows you to do short tracing. Let's say you have an instrument with a 5-volt rail in it, and it's shorted out. Somebody shorted out. There's a shorted part someplace. So you put the minus lead on the ground, and you go up and down the rail with the positive lead to where the least resistance is. That's where the short is. In circuit, you don't have to pull anything out except that screwy tantalum capacitor that went kablooey. Okay, I hope that's helpful. At $80 for that amount of help in your troubleshooting, it's a no-brainer, but make sure you get the leads with it. There's a bare meter that's cheap, but the meter with leads is worth it. They take a kind of funny little interface for the leads as well as regular banana plugs. So that's helpful. Okay, nano VNA. Other people are going to talk about VNAs in much more detail. I want to just center on one particular aspect, and that's the load, and double checking the load resistor for your VNA, whichever VNA you have. I took all of the SMA loads I have, I scraped together everything in the lab, up and down, sideways, and I made a list. And these on this side are all your regular teeny tiny SMA loads. And I thought I had one here. They're teeny tiny SMA loads. You probably know what I mean. Well, here it is. One of these guys. I'm sorry, one of these guys is an SMA load. Some of them look like this, some of them look like that. But they're basically 50 ohm resistors and an SMA connector. Well, I measured all of the guys, and one of them was dead. It looked fine. It wasn't burned or anything. It just was dead. That one went out. The best one was 50.017 ohms. It was a Weinschel 1408. Now I have two other Weinschel 140608s in that group, and none of the other two checked this good. So you can't really tell by looking. You've got to measure them, and you just don't want to end up with a clunker for your VNA and not know it. So at least know the variations, and at least for most purposes, 50.2, 50.1 are good enough readings to use that particular load. The DC resistance approximates the SWR in the VNA at lower frequencies, 0 to 30 megahertz, 0 to 100 megahertz. You'll be pretty close. So it's worth your while to look around and see if you can sort out which SMA loads are the best. I have some loads that are above 26.5 gigahertz, up to 26.5 gigahertz and above. And you can see what their resistances were. I thought I'd measure those just for fun. They're all 50.0 something, but the 909 is a 26 gigahertz load. The Anritsus are 40. The 28V50 has an adapter on it. It goes to 65 gigahertz. That's a pretty nice number. And then this one, I'm not sure whether it's got a problem or whether that's an allowable variation, but I put it on a millimeter wave VNA and it checked out really well. So here's 50.017. That's a really good little load. So the bottom line is just check your VNA loads to make sure they're somewhere in the ballpark. If they're not, sort through the ones you have in trays and bins and places till you find one that you think is suitable. Okay, we'll talk a little bit about standards. The easiest standards to have in your laboratory are resistance standards. They don't change much over time. They're easy to find, and people have done some good measuring on them. And here's a smattering, unfortunately, of the standards I have. The first one is a Julie primary standard. What a great piece of gear, except it takes a week to warm up. It's got a double oven in there, and it takes a week of bing, bang, going back and forth between these two green lights until they all go out, and then it's settled down. So you want to do some serious calibration. This is the guy to have. It's a primary frequency resistance standard. Okay, let's go down the trail a little bit. Here's an IET 1 ohm standard. I can't resolve more than 3 or 4 digits at 1 ohm. And here's a Julie research that's currently on eBay. That's 1 ohm at 0.005% accuracy. The cost difference between these two guys is about $1,300. Yeah. So, and behind it is a Russian version of a load that goes into oil bath, and I never use it. It just was a curiosity. Here's one that's a more modern US version of an oil bath, oil immersion resistor, and there's the resistance to 7 digits. The reason I bought it is because it had a current tag on it that said what the resistance was exactly. So that makes it a good standard, and it agrees with the other loads that I have. Let's see, here's my capacity standard. Here's my wonderful 50 ohm standard. Here's another Julie Research 100 ohm standard that's very, very good. Here's a 20 meg ohm standard that, it's okay. Here's an ESI SR1, Sierra Radio 1. They come in all the decades between 1 ohm and 10 meg ohms. And if you look at one and want to get it, look at the bottom side and see if they've recorded the actual resistance on the bottom. Then it's worth some money if you get the actual resistance underneath. I have several of those. Here's a little closer look with the Thomas, I think it's called, and it's a standard resistor. And the ESI, this is a 10K resistor. It says how much current you can pass through it. And it's an SR1 model at that resistance. Here's another picture of the Julie, my 20 meg ohm resistor, and my capacity standard. This is a 2.2033 microfarads. And capacity standards are really hard to get that are any good and small. Somebody on eBay had these capacitors. This company had them made, they didn't use them. He had about a dozen or two at 0.01 or 0.001% accuracy. Man, I snapped it up right away, it was 12 bucks. And at 10 kilohertz, it reads correctly and is nice to have. This 50 ohm fellow was just a random resistor I found on the tray somewhere in the lab and asked if I could take it home. It's been one of my favorite 50 ohm standards. 50 ohms is fairly hard to find, by the way. 40 ohms, okay, but 50 ohms is hard to find. Okay, there's some resistors. There's my, if you notice in the background, I've got a lot of test gear, and then all of a sudden I've got a K3 and a big Ollie key. Well, that's my EME station that I set up on the driveway on the other side of the garage door. Otherwise, it's all test equipment. I just put them all together. Okay, that's standards. Look or keep your eyes out on eBay for good sources, and your aside from your GPS for frequency, finding a good resistance standard will help you out with your multimeters, because the reading that's most likely to change, one of the most likely readings to change fastest is your resistance reading. So this will tell you whether your meters are working right. Okay, the last thing is a Coolertron. Yay! I can't tell you how much help this was when I got it. A little 4.5 inch screen, lights, variable magnification. And here I am pointing at an LNB circuit, and here's what's on the screen. All of a sudden, my soldering got really neat, and I could see what I was doing. I stopped messing stuff up that was little. And for 120 bucks, that's a lot of money for something. And you can gripe about it, but if you get one, you're going to be happy, especially if you wear glasses. You look at the screen, you have your fingers down there, you have some tweezers, buy some teeny tiny tweezers and some little sharp tips, and you can solder stuff you never thought you'd be able to do before. No brainer. The Coolertrons have a 7-inch screen model with lights and so forth like this has, and maybe it's better, but the 4.5 incher like this is an older model, and it's good enough by far. It's certainly better than nothing. And it has a USB output. You can save images, play movies, whatever, the usual stuff. You can do all that stuff. Okay, that's about it. We'll maybe have a question and answer thing, but if you've got questions that don't get answered, my email is there, drzarkoff56@yahoo.com. And you can email me anytime you like with, is this any good? Should I buy this or not? That kind of stuff. And I'd appreciate hearing from you. It's a pleasure to do a talk like this, and I hope the information was useful. Thank you.
Thanks so much, Doug. That was really interesting and informative. So we're going to hop over to do our Q&A session now. So Rod, do you have any questions in the queue for Doug?
I sure do. A couple of questions.
Rod, I have one thing I want to show you real quick.
Oh, please do.
Just to show how far over the top resistors go. This is an ESI 1 megohm variable resistor, and you can teach your kids on how to count to 1,000,000 because it's 10 million ohms in 1/10 of an ohm steps. Why do I have it? Because someday I'm going to take this to school and blow the kids away in their math lesson.
We've found a new favorite. That's awesome.
Yes, yeah. Alison Krauss, absolutely. Okay,
hey,
questions.
Super. Hey, so Vince asks, I've got an El Cheapo Amazon LCR meter, but is that good enough for quick parts identification? And at what threshold do I want to get something better?
Okay, go online and get a Julie Research resistor that's 0.01% or 0.005%. So you can measure things, and then see what it shows up as measuring resistance, and that'll give you a pretty good indication. The DE5000 really comes into its own because it'll test capacitors at 10 kilohertz. Most other cheap testers won't test it more than 1 kilohertz. So your accuracy is going to be off, but it won't be terribly off. So an El Cheapo will be okay. Probably the less you know about it, the better. But if you want to kind of get into, like I found some accurate capacitors, and I use those as kind of indicators of how far off stuff was. So yeah, the DE5000 is really, For the amount of money, it's really good.
Terrific. Okay. And something from Mike S. Is the Wiltron / Enritsu $113 version a useful tool?
Wiltron
S113.
Oh, okay. Sorry, I thought it was a dollar value. Never mind, got to put those glasses on. The S113. Does that ring a bell at all?
No, I don't know anything about it. A lot of things, if they're a little different, if the price is really right, then go for it. But most Anritsu stuff is very good. The specs are good and they're built solidly. Although I've had some trouble with their power meters. People mess them up.
Okay, good. Hey, Mike, if you want a clarification on that, we're happy to resubmit here. Another question. What's your favorite piece of test equipment that you own? And also, what's the favorite piece of test equipment that you don't own?
Oh dear. Well, I'm happy with spectrum analyzers, and I have an HP 8563A that I put an LCD display in it, and I think that's my favorite. The one I wish I owned is I think Agilent came out with a 110 gigahertz to DC to 110 gigahertz spectrum analyzer, and they want $150,000 for it. That's I think I'll keep my house.
What's holding you back?
I'm sure there's a loan
My wife
agreement
won't
you
sell
can
a
get into.
house.
Yeah, there's that. I do have a follow-up question actually on spectrum analyzers. So
Sure.
in the last couple of years, companies like Sigland and Rigel have come out with some relatively inexpensive spectrum analyzers and with optional tracking generators for under $2,000. Have you had a chance to play with any of those?
Yeah, I've had the Rigel, and the Rigel's a good analyzer. You have to be real sure. You don't want to see anything over 1.5 gigahertz, but that's a modern analyzer with all the features in it. But for the price, the Anritsu that I showed with the 7-inch screen on it is by far better. I used one of those; is much better than the Rigel.
Better because of frequency coverage, or is there some
bigger screen, bigger frequency coverage, better math? It's a newer design and it has the automatic calibration in it. You hook up a GPS antenna, and every time you turn it on, it not only calibrates itself internally, but it listens to GPS and calibrates the oscillator. So you're always accurate to, like, I don't know, hertz.
Doug, you had some incredibly positive feedback on here. One thing I want to point out is really more for us here, because George, I think we need to work on our affiliate links. It looks like we've had at least 3 people buy equipment during this talk.
so that happens a lot around here. Especially when I talk to Doug.
You know, now that we're going live, we need to work on those Amazon links. Doug, thank you so much. Incredible stuff, and as always, very dense, very, very useful.
Thank
You're
you.
not referring to some of us on the panel here, are you? Right?
Yeah, really me. But you know, as my brain opens up, I actually learn something every time I listen to Doug.
It's the result of a misspent life, but I'm happy to say that Alan's going to follow up with some information on one of the most difficult pieces of test gear. That's a vector network analyzer, and I'm really excited to hear what he's got to say.
Me too. Looking forward to that. Thank you so much, Doug. Really appreciate all the time putting into the presentation.
Thanks, guys. Nice to be here. Today.
That's really great. Thank you so much. Okay, now we're going to go over to John and to Marcel for another drawing.
Wow.
Well, you know, what time is it, John?
It's drawing time, and it's time that I get back to work. I've been busy putting in bids on eBay for test equipment. So, but I did get all the numbers in. We had some purchases here in the last 10 minutes or so, and our number is now over 4,500 tickets in the big drum. I'm really glad this is a virtual drum because it'd probably be too heavy for you to hold on stage, Marcel. So it's good. It's good. So tell us what is it that's up for drawing now?
That's awesome, John. Yeah, so just a reminder for everyone that's just joining us, this event is a big fundraiser for BayNet. Every dime goes to fund our open repeater systems and support the organization. You can check out the silent auction and buy more drawing tickets at bay-net.org/prizes. That's the link you see here on the screen, and we'll be dropping it into the chat as well. we do have all sorts of fun items available. The Eventbrite link should all be fixed. So if anyone's having issues, just drop it back in. And yes, Barrick, we do sound like the KQED pledge drive. Maybe that's what my brain's been doing when I'm doing these, because I remember those when I was a kid, listening all the time. Anywho, winners will be contacted by your emails to arrange pickup, and our silent auction bidding ends at 4 o'clock. The silent auction is pretty active. We've got a lot of people bidding. We have over 30 bidders already today, and the prices are still a great steal. The Digilant Analog Discovery top bid is only $310, which is a steal for that. Really great piece of test equipment. And that Elecraft XG3 signal source is only at 210. So you're getting a good deal still if you're looking at one of those, or if Doug's presentation inspired you. All right, so let's do another round of drawing here. First up is prize number 37, a beautiful Daiwa CS201 two-position coax switch for all your VHF and HF needs, donated by Mike, K6QFO. What do we got, John?
All right, isn't that cool how the little green, you can see numbers on my wall, amazing. So the winning number is 379. It's someone who registered very early, have to scroll to the top of the page, 379. 379 is, 1 second, 379 is Tom Freitas, F-R-E-I-T-A-S, sorry, Ted Freitas, 379. Okay, and have another one. Oh, Marcel, I cannot.
It helps if I'm not on mute. All right.
There we go. I thought it was me. I thought it was my headphones, because you never screw up. I thought it was my headphones.
I'll blame George. I mapped the hotkeys in Zoom so that I can mute and unmute. Works really well if you remember where they are and which one's which. That's why I need to get myself a Stream Deck. So that's up next on my shopping list. All right. Anywho, so yeah, we've got another Arduino Solar Power Kit, item number 2 of 3, and we'll get there here shortly.
Okay.
What do we got, John?
And the winner of that is number 4053.
4053. Check your tickets. No, don't worry. No one actually has physical tickets this time. So
4053. It's the amazing Mark Smith. I don't have to spell first or last name, but you can capture it as Smitty.
Mark Smith, congrats. You get a beautiful Arduino Solar Power Kit. Anyone else who would like to steal it from him, you can reach out to him on Smitty Halibut on Twitter. He'd be happy to talk to you about the next great project he's going to do with this. All right, and one more here. We've got prize number 23. Everyone needs an HF low-pass filter for their shack, $35 value. And John, who's it going to?
2696. And 2696 is, drum roll. 2696 is Charles Lucas, last name Lucas. Charles Lucas, congratulations.
Cool, congrats, Charles. Oh, we got a couple more here. All right, prize number 33. This is a small mystery coax box. This is the first of 2 of these boxes we're going to be getting out today. They're actually pretty cool. I know, John, you've looked at some of these boxes. What do you say?
I think they're great. Again, like I say, these mystery boxes, the origin of them is George's garage. And for anybody that's been at any of the events in person, George has some amazing stuff in the garage. And occasionally his wife, Carol, sneaks stuff that George doesn't know about into the boxes, I think, because there's really good stuff. And so I would certainly be glad to get one of these mystery boxes.
Yeah, for those that normally join us at BayCon in person, we always have the big free table over on the side. So some of this stuff is here, but it's great quality. So who do we got, John?
Yeah, we have number 1123. 1123. I can feel the anticipation and everybody going, John, can you look it up faster? 1123 goes to Antonis Papatassaris, and I suck at Greek names, but let me spell it. I think everybody knows him. P-A, yes, George, that's why you're George Z. P-A-P-A-T-S-A-R-A-S. Be a lot shorter if he didn't have any vowels in his name.
Nice. Antonis up from the SF Radio Club. So congrats on the mystery coax box. I'm sure you'll appreciate all the goodies in that one. So John, what time does that mean it is now?
Well, if it's been drawing time, it must mean it's now presentation time.
That's right. And if you're just joining us, it does sound like a pledge drive, doesn't it? Man, guys, this is good fun. baynet.org/prizes, and you can check out all the wonderful things we have. It's a big fundraiser for this group. So looking forward to it. Hopefully we're keeping you entertained during this time.
Can we get a commemorative CD of this event, Marcel?
I would love to.
I
think we need some tote bags for next year.
Tote bags, stickers. We need to come up with a logo for the event.
Awesome. Awesome.
We'll pull that out. Anywho, George, back to you.
Okay, great. Thanks a lot, guys. Appreciate that. Okay, next up, we have another presentation on test equipment. And this is with Alan Wilkie, W2AEW. And Alan is an expert at test equipment, and he works in the field professionally. And Alan has a fantastic YouTube channel. So if you haven't seen it, you have to go check out his YouTube channel and subscribe, and you'll just learn a ton. So let's go ahead and hand it over to Alan.
My name is Alan Wilkie, W2AEW. We're going to talk about an introduction to VNAs and the Nano VNA. So why do we want to talk about this? Well, mainly because these ridiculously inexpensive Nano VNAs make VNAs accessible to us hobbyists and hams. First, we'll talk about what a vector network analyzer is, then what it's good for, and then third, we'll take a look at the Nano VNA specifically. So what is a VNA? A VNA, or Vector Network Analyzer, if you look up the definition online, you'll see something like an instrument that measures the magnitude and phase of the reflection and transmission properties of the ports of a device versus frequency. What the heck does that mean? Well, let's break it down and see if we can make it clearer for everybody. So a VNA, it's an instrument that's used to characterize RF devices, and it used to only be used by RF engineers due to the high cost. These two up on top here, this Tektronix unit and this Copper Mountain unit, are probably $5,000 to $10,000 VNAs, and they're considered very inexpensive VNAs. This 4-port device down here, this Keysight PNA-X, can list price for about $250,000. So certainly outside of the price range for most of us hams. So another thing with VNAs is that there's a lot of acronyms and terminology that might be unfamiliar to the ham. So we're going to cover some of that as well. So the first is a DUT. So what is a DUT? A DUT simply stands for device under test. Could be an antenna, could be an amplifier, whatever it is that you're measuring. Any DUT is going to affect the signal that goes through it, as well as the signal that's being applied to it due to reflections and things like that. Now you probably remember that to get maximum power transfer, you want the load impedance to equal the source impedance. Typically learn it as load resistance and source resistance, but when we talk about RF and complex impedance, the more general case is that you want to have a complex conjugate match between the source and the load. I'm not going to get into all this complex math in this presentation, but just suffice it to say that if you want to design efficient matching networks and things like that, you're going to need to be able to measure complex impedance. And that's one of the things that the Nano VNA can do for you. The other thing that's kind of interesting is that we're going to talk about signals instead of voltage and current and things like that. We're going to think in RF terms. We think of signals as waves, that they have a magnitude and they have a phase. And one way to think about phase is that it's just a delay. Okay, so the phase shift is also essentially just a time shift in that waveform. This little moving graphic here is showing the difference between a incident wave and a reflected wave as the load is moved further away from a source, for example. So we can see it may be important to know what the phase is because that will vary depending on the transmission line length between a source and a load. So when we think about waves, may have a wave that's being produced by a source going into a DUT. Any of that signal that goes through the device is called the transmission properties of that device. And any part of that signal that gets reflected off that interface due to an impedance mismatch is called the reflection properties of the device. Now the device reflection and transmission will alter both the magnitude and phase of the source signal. And a VNA measures the magnitude and phase of these reflections and transmission properties of a device. So here's a basic VNA, this green block right here. We have a source that provides an RF signal that goes out through port 1 to a DUT port, and then any signal going through that port goes into port 2, and then any signal being reflected off of that port comes back this way. there are a set of directional couplers, or sometimes a bridge, that will measure and pick off a piece of the signal that's being sent out, that's our reference, as well as the signal that might be coming or being reflected back, and that's called our A receiver. And then any part of the signal that goes through our device will be picked up by the B receiver. So these three receivers, the A, the B, and the R, measure the magnitude and phase of the input signal, the reflected signal, and the transmitted signal. And of course, there's a little compute engine that will then take these magnitude and phase results and compute our responses and display them graphically for us. The transmission properties are based on measurements that are made in the B receiver with respect to measurements made in the R. So it's essentially B over R. And that gives us our gain or loss properties of our device, which is also known as the transmission coefficient, or S21. And we could also use it to measure the insertion phase or group delay through our DUT. The reflection measurements are measurements that are made coming back through port 1 again and picked up on the A receiver. So they're based essentially on measurements that are the A measurement with respect to R, or A over R. And that will give us things like the VSWR, reflection coefficient, or S11, or return loss, or even input impedance of our device. Now, most professional VNAs will have the source and couplers available on both port 1 and port 2, but the Nano VNA is really of this configuration where you only have the source and couplers on one of the ports. So what's a VNA good for? Single port measurements are basically you're making reflection measurements, which are like the SWR of an antenna, or complex impedance, or looking at even the impedance of components like passive components, inductors, capacitors, crystals, etc. And you could also do things like measure feed line length or distance to fault measurements with some additional mathematical transformations. Two-port measurements are the transmission measurements, what happens through a device, such as measuring the filter shape, or maybe loss through coax feed line or something like that, or a delay in a DUT, or even measuring amplifier gain and frequency response, which allows you to measure a multitude of RF devices that we typically use as hams, antennas and filters and duplexers and amplifiers and splitters, attenuators, etc. So what are S parameters? Well, I mentioned them a little bit earlier when we talked about some of the measurements, and some people kind of get confused or scared or intimidated by S parameters, but they don't really have to be. They're fundamentally fairly simple. S stands for scattering parameters. Now I know that doesn't help tell you what they are, but here's what they are. It's actually pretty simple. It's simply a ratio of a measured response to a stimulus, and that's what's indicated by the two numbers. The two numbers refer to port numbers. So the measurement of the response at port X in response to the stimulus that's being applied by port Y. So for example, S11, it's the response measured on port 1 in response to the signal applied by port 1. So in a sense, it's the reflection off of a DUT port. That's the reflection coefficient. Okay, pretty simple. That's S11. S21 is a measure of the B receiver, right? The transmitted properties divided by the reference. Okay, so it's the measure of B in response to the reference signal being applied. So it's essentially just the response through a device, okay, the gain or loss through a device. It's really that simple. So another thing that comes along with VNAs is something called a user calibration. You might say, well, I just bought this VNA. Why do I have to calibrate it? Didn't it come calibrated from the factory? Well, the user calibration actually extends what the factory calibration does. And so why do we actually need it? Number one, we're measuring typically pretty large dynamic range. And so what that means is there are very small, like systematic errors that can't be calibrated out at the factory because they're dependent on how you actually use the device. So we actually have to do them in a user calibration in order to get that good dynamic range and remove those error sources. Also, we need to measure phase. Now remember we said that phase is also a measure of delay. So the factory has no idea what length cables or adapters you're using to connect the VNA to your device under test. So it doesn't know what phase shift you're going to have up to your measurement plane. Okay, so that establishes something called a measurement plane. So oftentimes you need to know the impedance at a particular point, like at the input to my device. So I need to remove the phase shift and delay and things like that in the cables going up to that. So the user calibration allows me to do that. So that's kind of another systematic thing that we remove out. So a factory calibration can account for all of these things, and that's why you need to do one. So when do we need to do a cal? We really need to do a user cal whenever we make a configuration change. A different set of cables, a new adapter, or a different thing that we're measuring, and especially when we change the frequency range that we're making a measurement over. That's when we do the user cal. So again, this user calibration corrects for these systematic errors, such as the source and receiver frequency response. Okay, the matching errors, matching at the device ports to the cables and things like that. We can remove those things as well. So, or even from our source to the port, that type of a thing. So we can remove any of those mismatch errors so they don't become part of our DUT measurement. Also, the directivity of the couplers, crosstalk between the ports. We want to make sure that those errors are not part of our DUT measurement. So the user cal measures those so it can be removed from the measurement results. And then finally, we want to remove the effects of our interconnect to our DUT, so user cables and fixtures. So we establish the measurement plane at our DUT. So all of these things are done through the user calibration. So what are some common VNA display formats? Now, most of the measurements that we make are made versus frequency. The reflection coefficient, or S11, is typically displayed as a log magnitude response. Okay, and typically it's a negative dB value because the reflection itself can't be bigger than the signal that was applied, so that it's always a value that's less than 1. So if we take the log magnitude of that, it's going to be a negative dB value. If you simply remove the negative sign in front of that, then you essentially have the value called return loss. But the VNAs typically will show it as the log mag of S11, which would be a negative value, but just invert that without the sign, and that's return loss. The SWR is typically a linear value like 2 to 1, 1.5 to 1, etc. Complex impedance is most often displayed on a Smith chart. You do have options of displaying real and imaginary components versus frequency, but a Smith chart is a more common way to actually go take a look at that impedance. And then the transmission coefficient, or the gain or loss through a device, is again typically represented by the log magnitude response. I've got 10 dB of gain, 5 dB of loss, etc. And then the insertion delay, the phase, group delay, things like that are typically on a linear scale. And of course, there's a time domain transform measurement that allows you to make measurements versus time, which are typically used to measure the distance to fault or the length of a cable. And it's typically measuring the reflection coefficient, but if you change it to linear, you actually get a sharper peak in the response. It makes it a little bit easier to get a precise measurement of delay or distance. So now that we know what a VNA is, let's now take a more specific look at the nano VNA. And unfortunately, there are several developers and variants of the nano VNA. It's not like buying a device from MFJ or Rig Expert. The nano VNA is kind of an open source project, and there's lots of different manufacturers and variants that are out there. So I'm going to cover some of the more popular ones. The original was also called the nano VNA H. Came out with a little 2.8-inch display, smaller than a credit card. Didn't even have a case on it, just had some plates on the top and bottom. Later on, there were devices with a nice molded case. But that tiny display, for guys like me, I'd much rather have a larger display. So the same developers did a 4-inch version, and it was called the Nano VNA-H4. And that's got a 4-inch display, nice molded case. This is what I'm going to base most of this presentation on. It's the one that I use most often here. It's actually a pretty nice device, and $60, can't beat it. There's also a -F version, a Nano VNA-F. Based somewhat on the same design, but the developer of that kind of went a little bit different direction. He used a metal case. He actually properly named these ports, port 1 and port 2, instead of calling them channel 0 and channel 1. He did some nice other things with the graphics in terms of adding scales to it and stuff. Again, in a nice metal case. But it's about double the price of the H or the H4, but it is a nice unit. The V2 or SAA2 goes up to a higher frequency, up to 3 or 4 gigahertz. The initial versions of that didn't have a case, just had kind of a stacked set of boards and a couple of plates. But then as of about like January, when I'm recording this, January 2021, I still like the H4. It's stable, you get good support, it's easy to get, it's inexpensive, and it works really well for what we want to do as hams. The SAA2 and now is also now available in a 4-inch version with N connectors. It's called the SAA2N, and works pretty well. It's about It weighs several times more than the H4, but actually works pretty well. And then these same folks that developed the V2, the most recent one they've got is the V2 plus 4. The V2 plus 4 kind of shown here is about $130, but up to about 90 dB dynamic range, which is pretty amazing for about $130, $140. So a couple more details on the Nano VNA. All of them are 2-port 1-path, meaning they've got a source only on one port. The H4 goes to 1.5 gig. As I mentioned, like the V2 plus 4 goes up to about 4 gig. They all offer standalone operation with a battery that lasts a couple of hours, but they also all offer the ability to connect up to a PC or sometimes an Android device and use some external software to get some enhanced plots and things like that. NanoVNA.com is a good website resource for all the original versions, and also a link to kind of the very active user group that's there. And then there are separate websites for like the V2 versions, and that can be kind of found here. This nanorfe.com website will get you all the supported information for the V2s. So under the hood of the H and the H4, this is kind of what it looks like from a block diagram schematic standpoint. Channel 0, channel 1, that's effectively port 1, port 2 from a VNA parlance where your DUT gets connected. The RF source is this serial bus controlled RF synthesizer, an SI5351. A bridge is used to separate out the transmitted and reflected signals. To basically, when we have an impedance mismatch, we'll get the essentially reflected signal coming back. We have 3 mixers, very common Gilbert cell SA612 mixers that are used to convert the RF, reflected, reference, and through signals, so essentially our R, A, and B receivers, down to audio signals, which then go into a stereo audio codec that uses some high resolution analog to digital converters to sample the responses from all of these mixers. And of course, there's a microcontroller that controls all of this, collects all these results, computes the results, and puts them out on the LCD display. The user interface is pretty simple. There's a jog wheel in the top that allows you to rock back and forth to things like move markers or move up and down on menus, and then you can push it to either initiate or select items in the menu, things like that. There's also a touch screen that allows you to touch the menu items to select them, as well as touch and slide to move markers back and forth. Fairly simple menu structure to go through. The display menu leads you into being able to select traces and put them on different channels, and then select the format. And then there's markers and stimulus and cal, etc. There are save slots for the calibration and setup so that you can recall them later on. And there's also a USB port for both charging and the PC interface. A couple more details on the calibration. Most of the VNAs are just 101 points per sweep. So what that means is a wide frequency range is going to have a fairly coarse spacing between the calibrated points. But if you calibrate over the frequency range you're measuring, that's fine. But if you later change the frequency range, the VNA will try to interpolate between those calibrated points. But you don't want to calibrate over a gigahertz and then measure over 1 megahertz, because you might not even have 1 point sitting inside that measurement range. So it's always a good idea to calibrate over your frequency range. Now I had a little asterisk here because there are some other versions of firmware available for a lot of the VNAs that will increase the number of points up to even as many as 400 points, or using the external software you can actually get more points as well. So the VNA calibration indications on the screen appear over on the left-hand edge. The capital C indicates that you're calibrated over your current frequency range. You're good to go. The small letter C means that I've got a calibration loaded, but it doesn't match the frequency range you're measuring. And then the number indicates for the current calibration we're using what slot it's stored in. The D, R, and S are for all of the channel 0 calibrations, okay, indicating that they've been applied. And then, or corrections have been applied, and then the T and the X stand for the transmission and crosstalk error corrections being applied for channel 1. These first 3 are needed for all the measurements you're going to make. The second 2 are only needed if you're making transmission measurements. So if you're not making transmission measurements, you can ignore that portion of the calibration process. And this is the process. It's actually pretty simple. Go from the main menu, you hit Cal and then Reset. Once you hit Reset to clear the current calibration, you hit Calibrate, and that will bring up this menu on the side here, prompting you to attach the open to channel 0. You do that, touch open, and then you do the same thing for short and for load. And that, again, this is required for doing all measurements. If you're going to be doing some through measurements, then you want to also then do the isolation and through calibrations by attaching the load to channel 1 and then connecting or channel 0 to channel 1, do a through, hit done, and then you can select what slot you want to save in. Now, if there's something that you're going to do most commonly, you can actually save that result to slot 0, and that's always recalled on power up. So the thing could power up right the way that you want it. Connect all of the CAL standards when possible to the same place where your device under test will connect. By doing that, you can ensure that you've established that measurement plane right at your device interface ports. Now, in those cases where you can't connect exactly to where your device would connect, to be able to remove the phase of those interconnections, you might need to use an adapter or some other length of interconnect out to where your device is. So you can actually use this feature called port extension to essentially slide that measurement plane back and forth to establish it at your particular spot that you need on the DUT. This can be done on the Nano VNA. It's actually called electrical delay instead of port extension. And you can actually do it on the Smith chart, for example. So like if you had an open on the Smith chart, that would normally appear here. But if I change my interconnect length to where that open appears or where my DUT is going to appear, it might rotate around the chart. You would then adjust the electrical delay to slide that point back up to the perfect open location. And again, this is only important when you must have an accurate phase measurement or must establish a measurement plane that is not easily accessible by where you would connect your standards. Now the Nano VNA has got 2 channels, right? Channel 0 and channel 1, and can have up to 4 traces. The channel 0 again is the reflection channel where you're measuring reflection coefficient, SWR, input impedance, etc. Channel 1 is your transmission port where you're measuring the through response of a device, S21, loss and gain, etc. That's kind of selected down through this menu structure. So essentially go to display, select traces, select a particular trace, then tell it what channel you want it to be on. You can have any number of traces up, 1, 2, 3, or 4, and each of those traces can be assigned either to channel 0 or channel 1 for the reflection measurements or through measurements. Common trace formats are typically shown here. You go to display trace, then select format. The channel 0 measurements, you're most often using either log mag for S11 or a Smith chart to look at complex impedance or selecting SWR. For the channel 1 measurements, again, it's typically log mag for the loss and gain measurements. Then you've got phase measurements, which are typically going to be linear, and then the delay measurements are typically linear as well. And there's other additional measurements that are available here as well for more advanced applications typically, but there's a lot of other ways to display the same data. It's all just mathematically related. Setting the source or the stimulus is setting the frequency range you're going to make a measurement over. And you basically pick whichever is easier. If you're measuring over a particular amateur radio band, you might want to set the start and stop frequency. If you're measuring a filter, it might be easier to select the center frequency and the span. Just use whichever one is the most convenient for your application. And you also have the option of measuring at a single frequency without doing a sweep, and that's the CW frequency. There are up to 4 markers available to you. You can either drag them with your finger or a stylus on the display, or use the jog wheel to move them around. And you also have the ability of getting a delta measurement from the last 2 markers you've selected. The selected marker is shown here. The marker values are kind of shown on the lines right after each trace description. So here the yellow trace is channel 0, it's log mag, so that's the log mag of S11. The vertical scale is 10 dB per division, and where the active marker number 2 is, right here, that's minus 8.19 dB. So that's how you see that. So the delta says that this is the delta from marker number 1. So that's the difference between where marker 2 is and where marker 1 is. All the markers track each other on every single trace. So you can have up to 4 traces. So one marker will appear in 4 places. They all track each other as you move around. There are search features to search for like min and max on the traces, for example, and then operations that allow you to do things like set the start and stop frequency based on where markers are. It might be convenient to kind of retune the analyzer. And of course, you can set the units that are used for the Smith chart measurements as well. So the basic process to set up the Nano VNA is to start by configuring the traces, what channels they're going to be on, and what formats they're going to have. And you set up the stimulus to measure for the frequency range you want to measure. The order you do those in really doesn't matter. Okay, once you've done that, then you can set up and do the calibration and save that. Then you connect up your DUT and run your tests, and maybe you put some markers on there and make some measurements and understand what's going on. And you can even make some changes to the traces and formats if you want to kind of look at things different ways. But that's the basic process of using the Nano VNA. So let's look at a couple of quick examples. So here's an example of measuring an antenna. I've got an antenna connected to port 1, which is channel 0, which is the S11 port. Okay. So the frequency range is shown down here. In this case, I've got a start frequency of 7 meg, a stop frequency of 7.3. Okay, so I'm measuring over the 40 meter band. So this blue trace right here, or the cyan trace, is my SWR plot. We can see up here it's on channel 0, so I know it's the reflection port. It's SWR format. The vertical scale is 1 per division, so that means that I'm 1 to 1 down here, 2 to 1, 3 to 1, 4 to 1, etc. The marker I didn't move, so it's sitting right at 7 megahertz. So we can see that, for example, at 7 megahertz, the SWR of my antenna was 4.73. It goes down to about 1 to 1 up here. That's probably about 7.2 something, 7.25 megahertz or so. I've also got the complex impedance shown on the Smith chart. That's on the circular chart here. Okay, there's the values where the marker is right now. And then here's the log magnitude of the reflection coefficient. Okay, that's the yellow trace. It's yellow up here and yellow right there. And of course, the minimum for the S11, the log mag of S11, coincides with the minimum for the SWR. But that's typically what an antenna measurement would look like on the Nano VNA. So if we want to measure something like a filter, in this case, this is a low-pass filter that I designed to put on the back end of a Michigan Mighty Mite homebrew CW transmitter. So I've got the frequency range from 1 meg to 15 megahertz in this case. The insertion loss of that filter is shown by the blue trace here. So that's channel 1, doing the log magnitude of that. So I can see I've got about 0 dB of attenuation in the passband here where my fundamental is. And then we up around 4.5 megahertz or so, it starts coming down. I got the marker here sitting at about 10.5 megahertz. So that we can see that my filter response is down about 47 dB down at where about the third harmonic would be. So I'm getting good third harmonic suppression out of this filter. I've also got the SWR looking into the filter. It's nice, below 2 to 1 up through the passband, so that's good. I've also got the reflection coefficient shown in here as well for the input to the filter. Again, just a mathematical derivation off of the SWR. And of course, I left the complex input impedance on there, but didn't really need it from this particular case. Measuring coax length or distance to fault, this is where we use the time transform function. It's still a measurement on channel 0, but now the x-axis turns into time. And if we tell the Nano VNA what the velocity factor is, any of the marker measurements can actually be converted to distance. So in this case, I had about a 9 meter cable connected to the VNA. Now, of course, if we don't use the time transform and we connect the other end to channel 1, we can actually measure insertion loss of the cable versus frequency, which is S21, similar to the process we used to measure a filter on the previous slide. A little bit of the good, the bad, and the ugly, the limitations and downsides of the Nano VNA. So only 101 trace points. So again, external software helps this one, as does some third-party software. And like I said, the Nano VNA V2 has got 200 points. On the H and the H4, the output is not a sine wave. It's actually a square wave. It's shown right here on the scope. Okay, and it only goes up to 300 megahertz. Above 300 meg up to 900 meg, the VNA uses the third harmonic to make all the measurements, and then above 900 up to 1.5 gig, it uses the fifth harmonic. So this 200 megahertz square wave that's shown right here is the same output that you get if you were measuring at 600 meg. It's the same output that you get at 1 gig. We just are using a different frequency range in making the measurement. So that may, you have to think about, is that going to affect what I'm measuring? Is the device I'm measuring, is that going to care the fact that it's getting hit with a square wave that has this harmonic energy or not? So you have to think a little bit about that. And the output power, the output amplitude of this is not adjustable. So it's about a milliwatt, about 0 dBm at the fundamental. It's about 10 dB lower at the third harmonic, about another 10 to 12 dB lower at the fifth harmonic. So again, is that going to be correct for the device you're measuring? Because you can't really adjust it. And it also means you can't do things like gain compression measurements and things like that on an amplifier. Also, the receive reference level is not adjustable. So if we are measuring an amplifier, I would probably then have to pad down the output so that by the same amount that the amplifier brought it up, so that I would get about the same amplitude going into the VNA to make an accurate measurement. And limited dynamic range compared to professional units, but again, adequate for most of what we're going to do as hams. And also the resolution bandwidth of the measurement is typically not adjustable. Some third-party software and firmware does allow you to make some adjustment to that. But again, there may be some other limitations as well, but those are probably the more common ones that you're going to run across. So in summary, the Nano VNA, I call it the RF tool or toy of the year. Pretty fantastic capability for what you get for about $60. Lots of videos and resources online to learn how to use it. I've got a nice playlist on my YouTube channel that talks about some of the more common measurement applications. So some pretty active user groups, very helpful and very active, that you can go look at and get your questions answered. And again, a good US source for a lot of the versions, but not all, is Arendelle Electronics. That newest version that I mentioned, that V2+4, is not available through Arendelle. It's only available through some of the Chinese distributors. So with that, thank you. I hope you enjoyed and learned a little something about VNAs and the Nano VNA. We'll take your questions here, in addition to giving you a little bit of a shameless plug for my YouTube channel. Thanks again for hanging in, and be happy to take some of your questions now.
Hey, thanks, Alan. That was really a fantastic presentation. I was tracking the questions in the YouTube chat, and there's a lot of great comments about how good this presentation was. And one of the comments was, "This is the reason I showed up to this event," and I was not disappointed. So, so really well done. So, Rod, I think we have a bunch of questions in the hopper for Alan.
Absolutely, Alan. Okay, so let me start at the top, and we'll kind of meander around here. But first, a question: how do the internal, and there's a number of these questions along this theme, how do the internal electronics of the different Nano VNA versions compare, and what should I look for when I'm selecting one?
Okay, it's a good question, and I haven't studied all of them. But the original, like the H and the H4, that's kind of the block diagram and schematic that I showed in the video. And like I said, it works pretty well. And I've used it to characterize crystals and things like that. The downside is it's kind of what I mentioned on the good, bad, and the ugly, is that the output's a square wave, you can't adjust it, and that type of thing. The later versions, like the V2, the V2 Plus, the V2 Plus 4, they have a different set of synthesizers. The output is more sinusoidal. It doesn't use harmonic mixing or harmonics to look at the measurements, so that's good. The output power is adjustable, is good. But I've also read that, and it's noted on the website too, that the output is not continuous. It pulses on and off. So it's not suitable for measuring things like crystals. So you have to kind of decide, do I really want the higher frequency range and better dynamic range, or do I want to be able to measure crystals and maybe spend less money on something like that? So unfortunately, they're not all the same. I know that there were some improvements made in the -F version as well compared to the H, and that's a pretty good unit as well. So, but I think there are details in terms of what the schematic and block diagram levels differences are on some of the user groups and things like that. But that's the picture as I know it.
Okay, so to narrow that down, so based on what you know now, if you could get rid of all your old units, what's the one unit you would buy now?
Okay, if I was going to buy one unit now, it would be a bit of a toss-up. So if I wanted to spend less than $100, I'd go with this guy here, the Nano VNA H4. It's been around a while. It's easy to get. It's about $60 and works really, really well. So I'm but 40, 45, 50 dB dynamic range type things, but it works really well. If I didn't mind spending a little more than $100, you can consider the F, which is a little bit slightly improved version of this, or go up to this guy right here. This is the V4 plus 2. Excuse me, V2 plus 4. Okay, up to 4.4 gigahertz, as much as 90 dB dynamic range at low frequencies. But I can't use this to measure crystals. But I don't do that often. So it depends on what you're going to do. If you're really looking at just measuring, maybe filters or antennas, and you're doing some high frequency work, this would definitely be the one that I go for. The only downside is that this is really only available through the Chinese vendors that are on the website. We can provide the website for you there. And because of the Chinese New Year, they're kind of sold out right now. So you got to wait till they get back to work and start building them again before it's available again.
Okay, so a follow on to that is, so what about the calibration kits that come with these? Are they any good, the ones that come with them, or should I buy a third party, or how can I even test them?
Well, I would say that they're good enough considering the performance of these devices. Okay, as was mentioned in the previous talk, probably the biggest variable is going to be the 50 ohm load, and you can measure those. You could always just get a good quality 50 ohm load instead. The open and short, really don't matter that much. And again, for the level of performance that we're dealing with these guys, that's fine. We're not talking about something that's got 120, 130 dB dynamic range. So the kits that work well that could come with it are good enough, but just double check the 50 ohm load and just get yourself a higher quality 50 ohm load if that's what you need.
Okay, I'm going to ask a silly question that's been asked here as well, is how important is it to actually connect the open cap as opposed to just leaving it disconnected?
Yeah, so that's a good question. And people say, why do I have to do that? It really comes down to something called the electrical length, right? When you're doing these calibrations, remember, we're trying to establish a measurement plane so that the amplitude and phase are all going to be at the same point, whether the 50 ohm load is connected there, the open or the short is connected. So these, even though the open and short seem like they're just silly little things, but they are essentially establishing the same electrical length to that condition, that load condition. So where if you don't put the open on there, you're going to have a slight variation. At HF frequencies, does it matter? No. Okay. If you're measuring up well over a gigahertz, then it might matter a little bit. It all depends on how carefully you need to make those measurements.
So great. I've got my calibration states. Maybe I'm saving those. How much do they drift between uses? Like, should I calibrate it every time I use this?
That's a good question. For the level of accuracy of these devices, if you have got a calibration set to test your 40-meter antenna, and that's all, and you do that, it's not going to drift enough to worry about. If you're using one of these guys and you're working in an antenna at 3 gigahertz, you may want to recalibrate when you turn it back on again. Really, the level of calibration and establishing that reference plane, generally gets more critical as you get higher and higher in frequency. But for HF and even VHF, it's really not as important. And you can do a calibration once at a given reference point, and as long as that reference point is still valid for making measurements later on, you can just reuse it.
Now, the last question I've got for you here is really a group of questions, and I'll try to summarize even some discussion that was in the chat about the difference between where something's manufactured. Is it a knockoff? Who are you supporting when you're buying these? In terms of trying to make sure, I think Ham's trying to make sure that people get credited or at least encouraged even in open source designs. So what are your thoughts on that? Where the money should flow?
So I think for things like the H and H4, there are like Tindy and AliExpress vendors and things like that are good. And even in the States here, like R&L Electronics, they buy them from the same place. So that's where I got, mine was from R&L, and they buy them from kind of a reputable place. The V2 plus 4 is only being sold officially through 3 stores that are on their website. And again, I'll post their website in the chat. And it's funny because this came up when I picked up this guy, which is the SAA2N, which is a kind of a V2 version with N connectors on it. And I bought this through RNL. I found out later that the developers that developed this told me that RNL was purchasing them through a vendor that was not really going through official channels, and they were kind of price dumping these things on the market. So they were being sold, and the original developers weren't really getting credit for it. So, and how can you tell that? Well, other than going through the the sellers that they recommend on their website, the developers recommend on their website, it's really hard to tell. So, so in one case, when I bought this, it didn't necessarily directly support, the original developers, but I think these other two certainly did.
Okay, well, I think I've captured or summarized a number of the questions. Amazing comments, Alan. People that showed up just to see this and turned out staying for the whole day. So that's fantastic.
Great.
Very happy with that. And George, back to you.
Okay, thanks a lot, Rod. Alan, this is really great. Thank you so much for taking the time to not only put together the material, but also join us live today. So really want to thank you for your time and doing that. And I think this is a huge value for so many of the folks watching and who'll have a chance to see it later on. Thanks again.
All right, take care.
Okay, with that, we're going to go ahead and hand it over to John and Marcel for another drawing, and then we'll be back for the last presentation of the morning. Over to you, Marcel.
Sounds great. John, what time is it?
It is drawing time. And boy, my palms are sweaty after seeing those Smith charts and all that stuff. I really think Alan's presentation, as I was mentioning in chat, should be required viewing for a lot of young college students who are about to get overwhelmed with poor presentations. To see Alan's ahead of time might make some sense of it. So
absolutely, 100% agree.
About that.
Being an electrical engineer that studied RF and communications, even seeing these talks now and hearing really good explanations is huge. So for those studying for your extra license, great way to go replay BayCon and look at all the other great videos on his channel. Anywho, right. Just a reminder for those joining us, this event is a big fundraiser for BayNet, so please do check out bay-net.org/prizes, the URL here on your screen. We'll be dropping that in the chat as well. I'm sure Rod or Vince will do that for us. And silent auction bidding ends at 4 o'clock. The silent auction's been doing pretty well. We'll go over that during the lunch break as well. But a lot of people really excited about some of the great prizes there. So we've got 4 more items for the raffle right now. So let's go ahead and jump right in. This is a DIY antenna grab bag mystery box. So we have 4 of these today. It's a little different than the coax mystery box. This one has all sorts of fun Pactenna parts and wire antenna parts. So I'm actually pretty excited. I'm kind of hoping to get one of these myself, but we'll see how that goes. So John, you want to raffle this one off?
Yep. Let's see. And the winner is 2239. And that is, drum roll. We need drum roll music in the future. 20.
I don't have my stream deck yet. Otherwise, we could click the drum roll. I'm sure George could program that in real quick.
2239. We are going to draw again because that was my number. So here we go. We're going to draw again. 3303.
Gee, John, that never happened.
I know, right? 3303. 3303 is Lisa Kidder. Last name is spelled Kidder. Lisa Kidder.
Awesome. Congrats, Lisa. This is an awesome little DIY antenna mystery box. John, I heard there's some really good stuff in there. So hopefully that'll be a fun project. Next up is a Radio Shack black speaker. Yes, Radio Shack. You can't find these anymore in stores because they don't exist. They are very great sounding. Donated by Mike K6 QFO, local ham here in the Bay Area. Thanks, Mike, for supporting the club as well. John, who's getting this one?
All right. You think I'd get this phone thing lined up, but the mirrored thing throws me off every time. And the number is, well, I'll read it because it's green screen, 3779. 3779, and that is 3779 goes to David Kershaw. Last name is Kershaw. David Kershaw.
Cool. Congrats, David. Nice little radio there. And yes, technically Radio Shack does exist, but only as I think as a franchised group these days. There are a couple Radio Shack businesses. People are correcting me here in the chat. So yeah, I know. But my local one is gone. It was replaced with a Kumon study session. It's pretty sad. So, all right, one more here. prize number 41, the Gordon West Extra Class book. It is the last version, but these are very relevant still. I found when I studied for my extra, I read through some of these books. Just really great to have all the material there. Great reference to have. Also donated by Mike K6 QFO. So thanks for helping out. Who's getting this one, John?
All right. I love these books. I haven't got my extra yet, but maybe I'll win this and it'll be faster to get there. 3733. 3733. And that is 3733 is again David Kershaw.
Awesome.
Kershaw. So I think he has a mystery box and a mystery book to go in the mystery box. So
the speaker and the book. Yep. Awesome.
Oh, speaker.
Good job,
sorry.
David. Yep. So when you buy more drawing tickets, you can win more prizes too. All right, last one for this round is the small coax mystery box. This is another mystery box filled with all sorts of fun coax from George's Garage. And let's see what it is, John.
Number 2781. 2781. 2781 is William McNally, last name McNally. William McNally, congratulations.
Awesome, congrats, William. All right, just a reminder, you can go to bay-net.org/prizes, see all the silent auction items and all the drawing items today. There's a link to a new Eventbrite where you can pick up more drawing tickets as well if you like. And don't forget, silent auction bidding ends at 4 o'clock Pacific today. So
and
John,
I was going to add just
please.
one thing for those of you that were deterred by the long lines at the raffle table earlier. It's slowed down a bit. We haven't had as many entries. I know everybody was really watching Alan's presentation, but the line is now shorter. So make your way to Eventbrite and purchase more tickets, and we'll make sure you get entered ASAP. Thank you.
You guys sound like you've done this before.
No, only in rehearsal.
Well, believe me,
we'll do it live.
Reality is going a lot smoother than rehearsal did. So thanks a lot, Marcel and John. All right, the next presentation we have coming up is a live presentation with Mike Walker and myself. So Mike, VA3MW, are you there? Hopefully.
I'm here. I'm waiting for Rod to unvideo me. Here we come.
Excellent. All right. We'll let you out of the green room into the light of day here.
But I can hear you just fine.
Okay, so let me go ahead and set this up as we're getting the video switching figured out. So this presentation is a presentation that Mike and I put together, and we were talking about the idea of station automation and remote station operation and how that's becoming kind of a bigger deal these days. And so we wanted to approach this from the standpoint of projects that you could build and also other gadgetry that you can add to your station to do remote control or even local automation inside your shack. So I'm going to go ahead and start this with a couple of framing slides to give you an idea of what we mean by this. And then we'll go into some examples about the components that you could use to automate your station. So let's start out with a definition here. What is station automation? And really there's a couple different applications. One is remote control. In other words, the idea that your radio is in one location and you're in a different location. And of course, in the traditional sense, that is where your station is perhaps in a different city or in a different country or somewhere really far away. The other thing to think about is even around your own station, you might have your radio in one room and you might be operating from a different room, or even inside your shack. If everything was in one spot, you might want to be able to control stuff at the press of a button as opposed to a bunch of individual actions you might want to take. So some of the things you'd want to be able to do, of course, is work the radio remotely, but you also need to think about the physical world around it. So the ability to turn power supplies on and off, switch antennas, take temperature measurements of your PA, whatever might be useful. And these kind of ideas really make it easier to operate your station in a sense at the press of a button. And there's also applications where you might want to do 10 things at once and simplify that with a single press of a button. The classic example, of course, is antenna sequencing when you're doing things like satellites or EME, where pressing the PTT button requires a bunch of relay operations to turn off preamplifiers, switch from the receiver to the transmitter, then key the transmitter without anything going bad. So that's another example of automation that you could consider doing. So what's really changing, I think, in the world today, as opposed to, let's say, 20, 30 years ago, is there's really a sort of a confluence of really interesting factors that make this not only possible, but make it very practical for a lot more of us than it used to be. So one of the things that's really a kind of a change is the notion of having a radio that's remote controllable. And that started happening really 20 years ago, where you started to see radios with serial ports that allowed us to use computers to control the radio. And now we see the evolution of radios that are really designed more as RF servers. And we see that from multiple vendors these days. And Mike's going to talk a bit more about that idea. The other thing, of course, is the computer in the shack. 20 years ago, the question might have been, do you have a computer in the shack? And these days, it would be very odd not to have a computer in the shack. So the ubiquitous computers everywhere. The availability of microcontrollers and embedded Linux systems like Arduinos and Raspberry Pis, those are much more accessible to us, and the hardware that sits around it is very readily available and very inexpensive. Obviously, the internet plays a role in this as well, because if you're physically remoting stuff, you need some way to communicate across between your control point and your station. So the internet and cellular telephones and even private point-to-point data networks, like putting in your own private point-to-point 5 gig Wi-Fi control channel might be just the thing for you. So a variety of communication channels. And lastly, if you want to build your own hardware, the availability of inexpensive PCB fabrication companies and the availability of free software, so you can design your own boards and have them fabricated. So all these really add up to kind of a golden age of homebrew and the ability to design and construct your own station automation projects. So in this, the rest of this presentation, we're going to talk about a few of the components in more detail. So Mike's going to touch on radio architectures. I'm going to talk about a couple of hardware projects that I worked on. And another topic that's not on the agenda here, Mike's going to talk a bit about an interesting topic, which is the practicality of doing CW keying over the internet and how that's a challenge. And lastly, I'm going to share a little bit about using some commercial control panels like the Elgato Stream Deck to control gear in your shack. So Mike, let me go ahead and hand it over to you. And why don't you go ahead and touch a little bit on the remote radio idea.
Thanks, George. And as I was sitting here thinking while you were talking about that, if we took, the space shuttle and the control console for the space shuttle, and then looked at the control console on SpaceX, we're headed the same way. We love our buttons, but, I thought, geez, I have more monitors in my ham shack than the SpaceX guys had, right? I'm sure you've noticed that, but maybe I have a problem. But anyway, so we talked about this within Ham Radio Workbench a couple of times, but and yes, I do work for Flex, and yes, this is a bit of a commercial, but it's also a bit of reality because I'm a pretty active amateur radio operator as well. I do contesting and remoting. I started back in 2005. Excuse me. I inhaled wrong. The radios we have now were designed to do this from the ground up. They have full HF operation from the core. You don't need a VPN, all these things that we had to do in our early days. We can have two people using the same radio, and I guess it's a simple matter of software, not that I'm pre-announcing anything, but we probably could have 4, 8, or 16 if it was big enough. And we're starting to get rid of the RS-232 port. And that's 60, 70-year-old technology. And while it's really useful and incredibly reliable, it's really single-threaded where only one person can use it. Now we have multiple ways to access a radio to get on the air, whether it's Smart SDR, which is the Windows client for accessing the radio. You can use it on your Mac, your iPhone, your Maestro. You could write your own because the radios coming out of the Flex are designed actually to have, or they're wide open. So if you want access to the audio, the push to talk, I want to change my filters, I want the waterfall, I want the pan adapter to this, you can do it because we use the same tools for the Smart SDR software, but that doesn't prevent somebody from writing it for, I don't know, Linux, Android, Chromebook, or whatever else comes out. Next slide, please. So this is sort of the quick view. Now we have a radio sitting in the bottom right. It's either in front of me, maybe it's at the base of the tower. I tell you what, Cat 6 or 5 cables a lot cheaper than 4 runs of LMR 400 or better. And it's also, just sort of the way we're heading. And I've done that with my remote where I'm getting further and further away. Now I have fortunate to have a cottage, and when I'm at my cottage, I am actually sitting in the main cottage, but all the radio equipment's 500 yards away in a boathouse. So yeah, there are times when I've gone, geez, I wonder what's going on over there. And George touched on it when he said, imagine any button you have now in your ham shack. Like if you saw the picture I posted on the Facebook channel, I have monitor and I got monitors and I've got shelves in between, but those shelves are going to go away because I do not need those in front of me anymore. They can go behind me. So that's going to change as we go through there. We can run digital modes. We can have 2 of us running different digital modes at the same time. And in the Flex design, we actually just share a transmitter. It's not the matter of a main receiver and a sub receiver like we probably have used in most radios. Now we have all these main receivers that can see the entire HF spectrum at the same time, like a web page. Like if multiple people are looking at different pages on a web page, well, now we can do it with the HF radio spectrum. And we don't have this problem with RS-232 conflicts. Like in earlier days, I could either run my logbook, but if I wanted to use N1MM or FLDigi or WSJT, I had to shut that down and do something else. Yes, we could get away with virtual serial port or VSPs, virtual serial port control, and they do work. They're not necessarily plug and play, and if you have a good command of how RS-232 works, you won't have an issue. But in today's world, the list is getting a little shorter. Next slide, please, George. And I think this one's yours.
Yeah, so let's describe a little bit about what a station could look like. So in this case here, this is kind of as Mike and I were talking on the Workbench podcast about coming up with how do you do remote station design and what are the parts that you need. This is kind of a typical illustration. And in fact, this is my station looks like this with a radio, of course, at the, kind of the center of it, a PC, and then a bunch of hardware that sits around it in order to do the right kind of control and monitoring. So what I want to talk about are a couple of projects that I worked on that kind of augment this station. So in this case, the radio and the software that goes with the radio handles the remote radio control itself and the piping of audio. So that's kind of a solved problem. But if you're remote from your station, you don't necessarily want to leave the station on all the time. Or maybe when the station's on, you might want to switch antennas or rotate the antenna or whatever. So you need some external stuff beyond the radio to make that all work right. So in this diagram here, what you can see is a couple of control boxes in the yellow. So what I call the GPIO controller or general purpose IO controller. That was a little project I'll show you in a moment. And then also some antenna relays. In my station, I have a single HF antenna, but I have multiple HF radios, and I want to be able to switch between the different radios at the push of a button if I'm sitting here locally. And for VHF and UHF for 6 and 2 meters, I have multiple antennas. I have horizontal antennas and I have vertical antennas. So I want to be able to switch those antennas on a single radio, as well as being able to turn the power on and off on the station. So let me show you what these projects look like in more detail. What I'm going to show you are some projects that I recently finished and made some prototypes, and I'm using one in my station today, and I sent one to Mike, and he integrated it with some software. So the next talk, by the way, this afternoon, Mike's going to talk about using a software development environment called Node-RED, which is a nice graphical programming environment that lets you do essentially automation software control pretty easily. And after I sent Mike my GPIO controller prototype, he worked on the Node-RED code to make it work. So he's now controlling the box through Node-RED. So be sure to take a look at that talk as well. So this box is really intended to do a variety of things. There is an Arduino microcontroller in it as the brain. There's 8 dry contact relays for digital inputs that are optically isolated. There's 4 DC voltmeters that are referenced to station ground. There's 2 additional differential voltmeters, which means you can measure a voltage without measuring it against the system ground. They're floating, which is very handy, by the way, if you're doing something like measuring the voltage of two 12-volt batteries in series because you need 28 volts for something. You can measure the two batteries because they're not referenced to the real ground. You can also do temperature measurements with a digital temperature sensor. The thing runs on 12 volts. And we communicate with it through two different options, either through RS-485 or through a data radio using simple ASCII control commands. The reason for RS-485 is because unlike RS-232, RS-485 is what's called a multi-drop network. In other words, I can hook up as many devices as I want on the two RS-485 wires. And this is a technique they've been using for 30 years in industrial automation when you want to hook up physical devices in your fabrication plant. So, it's a fairly old technology, but works really, really well over particularly very long distances. Or you can use a little digital data radio to transmit the information. This is a view of the prototype version from the top. So what you can see here is all the connections are brought out to pluggable headers. And then the Arduino is the black circuit board on the left. So this uses an 8-bit Arduino Mega processor. So it's got a lot of memory and a lot of I/O. And you can see the little relays on the left. And then in the middle is the opto isolator and bridge rectifiers that isolate the digital inputs and allow you to put in the inputs either direction, so you don't have to worry about getting them in the right orientation. On the far right, you can see the little blue plug-in module says XB. That's the 2.4 gig data radio. And the little blue board above that is a two-channel differential ADC, analog to digital converter, which you can plug in as a separate module. So also, by the way, one big safety tip is don't use linear regulators on something like this. Use a little switcher. So the tiny little green circuit board in the upper left-hand corner is a 5-volt, 1-amp switching power supply, which allows you to shove 13.8 volts into this, and it'll never get warm. If you put in a traditional 7805 linear regulator, it'll get hot. So go with a switcher. So to control this thing, I came up with a ASCII command protocol that allows you to send a set of ASCII text in the clear. You can plug in a dumb terminal on your PC and just type commands to it, or you can write a program, or you can get a piece of hardware that generates those ASCII sequences and transmit that to the board.
Oh, like Node-RED.
What's that? Or Node-RED.
Like Node-RED, or your Stream Deck.
I have a feeling we're gonna come back to see that in a minute. So here's some companion boards that also work in the same system. So part of this whole concept, by the way, is to be able to build different kinds of controller hardware, but that can all talk on the same network. So in addition to one or more of those little GPIO boards, you could have antenna relays. And so here's inside my shack, I have 3 antenna relay boards. The top one is my 4-to-1 antenna relay board for the HF antenna going to 4 radios. And then below that in the black boxes are UHF and VHF coax relays that are single pole double throw to select 2 antennas to 1 radio. So the nice thing about this approach is whether the antenna switching is at your tower or in your garage or across the country or under the desk, you just have to flick a button. It'll send a command to the boxes and they'll switch state. And I find that just super, super convenient. This is what the inside of the VHF one looks like. When you're doing something like this for HF, when you're doing this for HF, the relays are not, yes, you're laughing at me, Mike. The relays are not critical because it's very low frequency, but at VHF, the relays are super important. So you need to use impedance controlled relays. So these Tohatsu RF relays are really necessary. So if you'd like more information on those projects, we're going to be talking about that in a lot more detail on the Ham Radio Workbench podcast. And we'll probably make those boards available as build projects if people want them. So we've done that in the past with other projects where we put out the circuit board and publish the schematic and the bill of materials, and you can go source the parts yourself and just get the circuit board and build your own antenna relays and other projects. So Mike, why don't you go ahead and talk a little bit about doing remote control with CW?
Thanks, George. I actually wanted to mention RS-485. If you're worried about it or you think that's freaky, it's just RS-232, but it's long haul. It's a bit more to it than that, but in some ski racing stuff I've done, we've used RS-485 to go 7 kilometers. So instead of what the spec is an RS-232, George, 9 feet, something like that.
Yeah.
I think it is actually. It's like 3
It's like
meters.
25 feet or 50 feet. Yeah.
So
Which
and
and it's
only
only
2
point to
wires.
point, which makes it useless. So yeah, this is much better.
So we get this call quite a bit. I want to send CW over the internet, and in the Flex World, you have to have a Maestro. You plug a key in the back of a Maestro. That's an $1,100 solution. So it's probably out of the budget for some people. But if you're a hand sending CW person, it works beautifully. Remote Rig as well has this built in. They use the same technology we use. They probably came up with it first. But I thought about this one day. So, well, how hard can it be? I just need to grab, the dash side or the DIT side, or just level, RTS on the CW or on the RS-232 port and have it toggle the transmitter on and off, and I'll get some audio feedback somehow and be good to go. Well, yeah, sure. Technically, that works beautifully as long as you don't want to send more than about 1 word per minute. And I think it's the next slide. I'll show you why. So I did this, by the way, these graphs I put together yesterday afternoon in Node-RED in about a nanosecond. We'll show you in the next talk how that works. On the bottom middle is the only 2 I really have available is pings. And what I was looking for is jitter. And jitter is the variance in the delay time from here to the other end. It varies quite a bit, actually. And in order to send CW, we need an absolutely perfect incredibly low latency of maybe a couple of milliseconds and no jitter. That means no delay. It always has to get there 3.5 milliseconds from now, 3.5 milliseconds. But on a LAN, that's impossible. Things slow down, they speed up. And on the bottom one graph is ping taken every 1 second or 2.5 seconds to my router. It's in the other room. But even then, look at that. We had a 10 millisecond delay. In fact, it was even longer. Why? Don't know. Could be other traffic on the LAN, some packets got dropped, but this is a great indication of why the LAN is really good for watching Netflix, but really bad at times, and even more so on the the WAN side, the world side, when using it for HF radio, because we get annoyed if it's more than maybe 200. So let's look at the screen, the graph on the top right. I'm pinging the remote router. It's 160 kilometers away, and we can see, I usually see about a 25 to 30 millisecond ping time, but it varies all over the place. And that started at what, 136 yesterday? That's just a minute. And we see how much it varies, and it can be as long as 50 seconds, as low as 25 seconds. So the jitter in that case is about 25 milliseconds of jitter. Now imagine trying to send CW with a key just by toggling the dot and dash, in a logic shifting mode. Not really practical. We look at the radio, which is on the other side of the router, and it even gets a little worse. And those extra delays are because of other traffic flowing through the router. And it's busy doing its thing, and it's juggling some traffic here and there. And our jitter is, let's say, from about 30 milliseconds to 75 milliseconds. And, let's 50 plus milliseconds of jitter. It's just not going to work. So how do we get around it? And we should have probably done a slide in this, and I don't think we did. We actually use WinKeyers that are built in to sending CW, and there is a group, we'll have to make this available, George, that have done a remote WinKeyer implementation to make this work. So there we go.
So with a remote WinKeyer, you can apply that to any radio, right? That doesn't really, it's not unique to any one brand or anything.
Great. There's our 10-minute warning in case you missed it.
Okay. So I want to touch on one other thing before we go to the questions. So one of the things that I showed in the shack diagram is using some common control surfaces. So these are products that are not made for ham radio. These are really made for other computer applications. And there's a whole bunch of products out in the world like this. One of the most famous ones is made by a company called Elgato. They have a product called a Stream Deck, and that comes in various different sizes. Basically, it's a keypad, and you press a button and it does something. And normally these are used to control things like your video editor or your audio software, or things like that, where you want to have a tactile kind of control over the software. But I wanted to apply this to the shack. So here's a picture of what the shack looks like. So up on the screen it's a flex radio showing the spectral display, and then below that's an Elecraft radio, and then there's some other radios, and they're all controllable from this one Stream Deck, actually. So there you see the box in the middle with the lit up buttons. That's the Stream Deck sitting on the desk. And this thing comes in 3 different sizes. There's like small, medium, and large. And they do the exact same thing, just with more buttons. The thing that's quite amazing is the key tops are little tiny backlit LCD displays. So when you program what these buttons do, you can also put a graphic image on the button to represent what the function is. And that could be text or it could be a picture. So it's pretty cool. And the software is very easy to use. So you can create a whole hierarchy of menus. Is the way I set mine up. At the very top level, I have a button that then either can select a bunch of different antenna relays. Remember the box with the antenna relays? All of those relays are controlled from buttons. And it's hard to see in the diagram here, but down in the bottom on the left-hand side, that little row of buttons at the bottom, each one of the antenna buttons has a picture of the antenna itself. So, why not? So when you want the 6-meter loop, there's a little picture of a 6-meter loop, and you just press the button and it makes the relay click. So that's really handy. Then I have other submenus that change various operating conditions for CW or sideband. That's just the way I decided to organize the stuff. So there's the main launching pad, and then it'll control the various devices. So if I kind of go back to the beginning here of the station diagram, what's actually happening, there we go. What's actually happening is you see the Stream Deck on the left-hand side. When you press a button, that launches a little tiny program that sends an ASCII control code out one of the COM ports of the PC. And that goes over that RS-485 cable to all the devices. So the command goes to the 3 antenna relays, and it goes to the GPIO controller. And depending on which device I'm sending the command to with an address, it will accept the command and then do the task, turn on a relay or read a voltage and send it back to the PC software. So this is very, very simple to set up. If anybody wants to do this, I can show you how to program the Stream Deck. It's super easy. And even just the little shell program that sends the control codes is very simple. You can install that in a minute and then control various devices. So in the next talk, when Mike talks about how to use Node-RED, we'll be using a similar approach to that. So those are a bunch of ideas we wanted to run through and give you some thoughts about how you might do some station automation. So with that, Rod, I want to open it up and see if there's any questions.
Yeah, very good. Let's have a look at one from Andrew, who said, anyone deal with a remote controlling, simple, inexpensive version of using FM mobile radios remotely?
Oh yeah, we've been doing that for years. Actually, we've done at repeater sites. We've had remotely controlled base stations at repeater sites. So in our network, we have mostly UHF repeaters, and we do have in some sites 2-meter remote bases. And in the old days, they were crystal controlled, so you'd select the channel with a relay, and then they became like commercial radios, like Centaurs, were programmable, sort of programmable, and again, you'd select them by channel. And nowadays, of course, you'd use a serial programmed radio, but that means you have to use an amateur class radio. So it kind of depends on the quality. For doing it at home, it's pretty straightforward. Since most of the modern ones, like let's say an ICOM 705 for sure, or a older 706, or an ICOM 7100 or 7200, any of those could be easily, well, 7200 is not VHF, but any of those radios with VHF, you could certainly do that with. Mike, do you have any thoughts?
No, I think you touched on it because I know how we did it. But yes, I think if we had to do it today, we would do it a whole lot differently.
Yeah, I think that the missing link to there that's not in what the answer we gave is like, well, what would you put in the middle? And there's not a good commercial off-the-shelf solution to that, partly because most of the VHF, UHF radios are not externally controllable. So I would say today that the 2 practical approaches is you either go with a commercial radio, like we've used things like Motorola CDM 1500 series radios, where you program, let's say, 5 channels in it, and you bring out the mode pins to the back, and you can ground different pins. Will let you remotely select channels. So now you just need a way to ground a pin. And you could do that with some combination of things like what Mike's going to talk about with Node-RED. If you want to control it from your phone remotely, in our repeater control systems that we build, you can do that with DTMF. So you can DTMF control a radio. That's another option. So I mean, there's many ways to approach it. With more modern radios with serial ports, it's a little bit easier if you have a controller that supports that. And a lot of the commercial controllers do.
Yeah, there's also a comment in the chat about using the Kenwood V71, which is quite affordable because of the support for CAT commands. So very good. Hey, what about K7AGE?
Hey, Randy.
About, hey, I need this GPIO box. When is it available?
Oh, great question. So I made a prototype version, built one, sent it to Mike. And then I built another one myself, and a second version with had a few improvements in it. So I think the design's done. And I have a bunch of other projects I got to get out of the way, but I would say in the near future. So if you're interested, shoot me a note and then we'll talk.
Oh, very good. I don't see any other questions in there. Anything jump to mind, Mike?
No, it's been a blast. I've done this for a long time, and it's gotten easier and easier, and more stuff gets ripped out. And I think, Rod, you've seen pictures and pictures. And the Node-RED, I'll show you where I went to version 4 to version 5 of the remote ham shack. And I think I got to thank George, who got me down a lot of this thinking a long time ago when I was doing so much repeater control work. It's just the same but different.
Yeah, a lot of the concepts are very similar. And like I was saying earlier, I think one of the most exciting things about this is there's so many things that you can do now that are relatively inexpensive. I'll throw out another thought, which is out of the ham radio world, there's a lot of controllable devices and internet resources. There's a system or service called If Then Then That, IFTTT, that's kind of a hub that lets you bring together a variety of control points and devices. So you could use that sort of thing for shack automation. The typical radios, amplifiers, a lot of accessories are remotely controllable these days, and pulling it all together actually that's in a way that's where the work is right now. The devices are ready to go, but you need to have that central control point to kind of make it all work together.
Right. Vince put up a question, and sorry, I jumped on you, Rod. I'm going to answer that.
Hey, that's my job.
That's your job.
Hey, question from Patrick about sending CW to a remote flex without using a Maestro.
Yeah, you'll have to look to really do it well. You can use a CW keyboard, and that's probably not what you want to do. So you can look at the remote WinKeyer thing, and if you want me to send that to you, you can fire any one of us an email. Send me an email at work, my call sign VA3MW at flexradio.com, and I'll get you the link for that.
Very good. Hey, question for George from Mark from Smitty. Can you run power over a 475 cable?
I don't know what a 475.
485. It's a typo.
Oh,
yeah.
That was the down rev version of the
485. Yes.
Okay, so let me take a step back and a quick note on what does 485 look like physically. So 485 defines the electrical interface. So in other words, the number of wires and the voltage for signaling. There are two wires. They're cleverly called the A wire and the B wire. And what happens is the sending device puts a voltage across the A and B. It's what's called a differential pair. There's a voltage produced across the two wires. It's not referenced to ground. This is how they get the very long distances and some decent noise immunity. So the 485 wiring is a half duplex system. So only one device should be talking at a time. So let's say, for example, you have the PC and you have a device. So the PC's COM port has to go through a little USB to 485 dongle that you can buy for like $10 on eBay. Now you have the two wire twisted pair, the A and B wires. Then at the device end, like in the case of the GPIO box, just screws into the box because the 485 interface is built into it. So every time you send a character like A from the PC, that ASCII value gets sent across the wire to the destination. And you can have as many devices hanging off that AB wire pair as you like, but only one can talk at a time. Okay, so that's the data part of it. So you need 2 wires, twisted pair. It's not super critical. They're not impedance controlled or anything. So when you go to a factory floor, they'll run 3,000 feet of bell wire to do RS-485. It's very typical. Okay. Now, separately, you can say, well, if I have a remote device and I want to power it, is there a way I can use that in conjunction with 485? There's no industry standard for this. However, the way I designed that little board, you'll see there's an RJ45 jack on it. So there's an 8-pin modular jack. The pins 1 and pin 2 of that modular jack are assigned to be data A and data B. So now I've got 6 pins left over. So what would you do with 6 extra pins? And the answer is put power on it. So I just stole the idea from power over Ethernet. Now, PoE is 48 volts, more or less. And we don't use that in ham radio. So I just use it for 12 volts. So pins 4 and 5 are connected together for the positive side, and pins 7 and 8 are connected together for the negative side. So I'm using 4 of those 6 unused pins for power. So by using 2 wires for power, you get a little bit extra current capacity, a little bit less voltage drop. So that's the way I designed the system, so that the 45 connection could either be literally a twisted pair screwed into a terminal block, or it could be carried over a piece of Cat5 cable. So that way, with one cable drop, you can take data and power from a master to a device at the other end. So that's no industry standard. I use the same pinouts as PoE typically. There's an industry convention, but not a standard for that. By the way, I've seen it reversed. Be careful. But yeah, you can certainly. So the way this device is built, yes, Mark, it'll support both data and power over a single Cat5 cable.
So a couple of questions, I think, directed more to Mike, but to both of you really, is what's been your biggest challenge in setting all this up, the technical challenge? And also, if you had to do it brand new all over again and not have the path that you've been on, what would you do differently?
First one's the internet. Hugely unreliable. Second one is in part 1 is no Wi-Fi, even more unreliable. And as anybody who's ever worked on internet or whatever knows, it's easy to get it to work. It takes some work to get it to work well, and some thought. So that was always the biggest challenge. And my first ever outage when I was away for the winter was the internet went offline, and I called the cable company and I said, "What's wrong with my modem?" And they said, "Oh, we pushed out some new firmware. Just unplug it and plug it back in, and it'll reset and you'll be good to go." And so put a Christmas tree timer on that. That was back in 2005. So the modem would reboot every 24 hours, around 3 in the morning. I still, during the winter, do that even today with a lot of things. I just reboot it just in case it gets hung up. It'll recover. It's saved a couple of road trips. One as recently as yesterday when I was trying to fine tune some rules on the firewall. Do over? I don't know. That's a good question. I'm not sure where that came from, because it's been an education starting from day one. If I had time travel, there's a lot of things I would do over, but it's been a very fun education on to get this working and reliable. And I immediately understood how AMSAT felt when they launched a satellite, or the guy on the Mars rover. You can't just reach out and push the reset button on the motherboard. So I don't think I have a good answer for that, because I've just done it over when it needed it as new technology came out. In the early days, it was Ham Radio Deluxe, a PC8HN, Skype, and a TS480, and that worked. I was a static, terrible radio for what I was doing, but I was on the air in a quiet area, and then it just got better.
So definitely the unintentional consequences of distance, right? Where you make one little change. It was just such a small change, and all of a sudden you've got a 4-hour drive.
Well, every repeater owner knows that story really well.
No
you
kidding.
Get to the bottom of the hill and you go, you know what? The receiver's a little low. I should go back up there and twist the pot 3 hours later. I just throw out just to add to what Mike said to that particular question. What you see in this diagram is me doing it all over. So you're actually looking at it live here. So I think the first thing that that struck me was the new generation of radios that are really radio servers. I think Flex really led the charge there, and they're really kind of in the lead. Spending a lot of time with folks from Elecraft are doing the same thing. So I think you're going to see that more and more. So a lot of the other manufacturers haven't quite gotten there yet. They're good at remote control, but they haven't completely separated the control point from the RF deck, and I think that's kind of the trend. So I think we'll see more and more of that. So I would if I wasn't focused on the cost, let's start with that, then I think some of these nicer high-end radios are really the way to start. If I was very cost conscious, then I would go with a radio that's serial controllable, and there's tons of those radios out there. I think the ICOM 7100 is a fantastic example because you've got every HF band and VHF and UHF to boot, and it's all remotable. So I think there's a lot of great radio options. And then for the rest of
That's why I haven't sold my 7100 yet.
Oh, really?
Yeah.
Yeah, that's good for that purpose. And then I think what you'll start to see is more and more project boards like what we're doing. So, things like these antenna relay boards, the GPIO board, stuff like that. I think, we'll just see more people doing that stuff. The work that, Mike, you're doing with the Node Red guys that we'll see in the next talk, I think is kind of really the big missing link. And so to really pull all this stuff off, what you really need is like what a surprise. You need a lot of people with different expertise who can all contribute a component to the solution. And I think you're going to start to see those kind of things becoming much more common. And I think what's driving a lot of this is you can remote stuff so you want to, but a lot of us are in conditions where we may not be able to put up an HF antenna. We live in an apartment or a retirement community or whatever. And so, you can't put up an antenna. What are you going to do? So there's a lot of reasons that are motivating people to try to figure out how to do this.
You're going to see, I'm doing a talk next week for Hemcation, and I've titled The Death of the RS-232 port. I can't wait.
But not the RS-485 port.
No, 485 is good.
Anything else there, Rod, before we go to the
No,
next?
I think that's just winds it up. I'd like to thank you guys for a great set of Q&A.
All right, great. Thanks a lot, Mike.
Rod.
We'll see you after the drawing break. So I'm going to hand it over to John and Marcel for the next drawing. Well, by the way, we're not really almost had it over. We're not really breaking. We're just going to have an extended period on the drawing, and then we'll come right back into the next talk.
Well, Marcel, I now know what these Robinhood folks guys must have felt like with GameStop last week, the way the Eventbrite link has had to go. So
Yeah.
for those of you that were struggling to make purchases, we appreciate your diligence. And as Vince in the chat has put it, we found a bigger hammer. Hopefully folks are able to purchase as much as they need.
Well, John, my Zoom just died, so it's frozen up. I'll be back in just a minute because my screen share is not working. So that's just how it works. Give me a couple minutes, but you can go ahead and vamp and tell them all about the wonderful drawing.
Yeah, fantastic. So again, appreciate folks getting in and to Eventbrite. If you do see any issues or if you have any issues moving forward, please do put them in the chat. We want to keep that going, and it's a fundraiser, and we're very appreciative of everybody buying tickets. And just as soon as tickets are ordered or purchased, I get email notification, and we're getting you guys added to the list. Marcel, you appear to be back up.
I'm back. Zoom is pretty good at recovering, I have to say. Brought me right back to the same spot. Hopefully you can all see the screen there. So John, let's do our usual. What time is it?
It is drawing time, Marcel. I think everybody in the audience, even though we can't hear you, next time Marcel says that with this slide, you know how to answer.
Scream out loudly.
That's right. That's right.
Make all those friends that are not hearing what's on your headphones go, you're a little bit crazy. Yeah, just a reminder, it is a fundraiser. We're going to do a quick drawing now, and then we'll take a little break and before we start our next talk at 12:45. Remember, you can go to bay.net.org/prizes to check out everything and check out the latest status. We did get all the Eventbrite pages updated, so both the old link and the new link should work now, and there's a donation option if you don't want to buy drawing tickets. So hopefully that'll work out. Anyway, let's go ahead and do another drawing, John, shall we?
We shall. What are we
All right,
giving away
this-
now? Oh,
Yeah, another beautiful Pactena mini random wire antenna. This is also courtesy of George. This is one I'm excited about too. Anyone that does SOTA or remote HF or outdoor HF operations or POTA or something would love to have one of these. So John, who's this one going to?
right. Well, and there is a, I'm blanking on the name of the chat team or the group, but there's a Pactena group. Help me out, Marcel. What is the, it's the same
Discord,
place as Baynet is at, Baynet.
Groups.io.
Groups.io.
Thank you, groups.io. There's a Pactena groups.io page, and anybody who's on that page will know that these things are in short supply, and George is trying to get them cranked out as quickly as he can, but they are in high demand for sure. So here is, let me move my window away so I can see my phone, and the winner is, number 19.
Ooh, that might be me.
Yeah. That was probably the first person to buy tickets. Let me look
I think
here.
it was the second person.
Oh,
Fingers crossed.
and it is indeed Marcel.
Yes. Oh, I'm actually super
Hey,
excited
wait a
for
minute.
that.
Check that ticket.
Yeah. Hey, nobody behind the curtain. We're in different areas. So
Hey, I bought 20 tickets right when George opened it up, so
yeah,
I'm
there he
super
is.
excited
He's-
for that. All right.
tickets 3 through 28 is Marcel. So yeah. So
All right.
whoever's keeping score, do they know how to type Stieber in the or Stieber? I can't even pronounce
Stieber,
it. So
yeah.
Stieber, thank you.
I'll figure
All
it
right.
out.
Here
All
we
right,
go.
second item here, we got another Arduino solar power kit. This is the third one we've got for today. And John, who's it going to?
1204.
1204.
And 1204 is Michael K6QFO.
Awesome.
Last name is spelled Gitschel. Gitschel?
Yeah, Mike
Congratulations, Michael.
K6QFO. He donated a bunch of stuff to the drawing as well. So thanks, Mike. And hopefully this will get you one nice piece back as well. That looks like a fun little project kit. So I'm happy to chat solar with folks anytime. All right, we got one more here for this round, and then we'll go into our little break. So this is prize number 27, another antenna grab bag mystery box. Who knows, this could actually have 2 or 3 Pactenas inside it. So let's go check out, or at least the parts to make one, right?
It definitely
gonna
has
say-
parts that were used to make some of this.
There you
Some
go.
assembly required. All right. And the number is 109. Ooh, another low number.
Oh, that might be you, John.
No,
No? Oh, you're
I
up
was
higher.
asleep at the wheel when it came to registration. So I was, so number 109 is a gentleman named Randy Hall, Hall, Randy Hall, 109.
Congrats, Randy. Awesome. Hopefully that'll let you build up an antenna as well. So thanks for doing that. So we're going to go into a little break time now. We'll be here and we're going to go through some of the auction stuff. So if you'd like to stick around and learn more about that, or if you have any questions, you can ask them in the YouTube chat, and we'll take a look at it as well. And we can try to answer those for the next 15 minutes. George, anything else you want to touch on before we let
No, I think
go
that's
into that?
what we're going to do. If everybody wants to stick around, like you're saying, Marcel, and hear about some of the drawing prizes, that would be great. This would also be a good time for a bio break, and please be back at 12:45 Pacific time for the next talk.
Yeah, sounds great. So we'll take a little bit of time here and just go through all the prizes. Our calling lines are open. Someone was asking earlier, if you reach out on a Ham Shack hotline, 11529 is the extension. You can reach me and we can happily take any questions live. Again, that's Ham Shack hotline, extension 11529. If you don't know what it is, look it up and get on the system. If you have a SIP phone at home, you'd be impressed. So anywho, we'll jump right in. Figured might as well plug it in a little bit, a little ham radio here, right? So let's go and take a look again. So how does this all work? If you're joining us today, bay-net.org/prizes, just going to go there real quick, show you how that works. It'll bring you to this lovely web page. There are 3 different links here and how you can get involved. So the first one, you can pick up more drawing tickets. This should bring you to the latest Eventbrite page. And right here, you can pick up more tickets. You can get more tickets, you can get less tickets. John, how many tickets have people bought, and how many, like, who has the most tickets, or how many do they have? Do you know? What does that look like?
There's several people that have purchased the $100 option, which gives them 150 raffle tickets. Certainly your Costco purchase size price per ticket drops there. So that's been great. We're between 4,500 and 4,600. I think Eventbrite being down a little bit kind of slowed things for a bit because we had pretty good clip. I'm expecting here at the break to have a bunch more names to enter in.
Cool. So yeah, some people were asking in the chat as well. A lot of folks did buy a lot of tickets, so they often have a much higher chance of winning. Of course, if you registered for the event, everyone gets a chance to win. Keep it nice and fair for this opportunity drawing. But if you do want to put in more, you can always up your chances as well. So that's pretty fun. All right, should we take a look at the prize list, or let's jump straight into the silent auction, shall we?
Yeah, I'm curious to see where things are at. I've been bidding on a few things, but I don't think I have anything that I'm winning yet. So
yeah, let's just look through the auction bids real quick, and then we can go. Actually, let's go straight to the bidding form. Let's do that, and then we can show people how to fill this out in case they have any questions, and address any questions. If you want to drop them in the YouTube chat as well, we'll be happy to address those. So we're doing $5 bid increments just to keep it easier, so people don't bid 1 penny up on someone else. Place your bids early and often, right? We will be closing bidding and ticket sales at 4 p.m. Pacific, so make sure that you're ready for that and have your bids in and hit submit before that 4 o'clock hits. We'll be working through all the bids and dealing with any conflicts, but so far it's looking pretty good. Got a lot of folks bidding and putting in their items. We have over 36 bids so far for the various auctions, and that's bidders, I should say. So we have more bids than that. Make sure you have a good email address so we can reach you at. We will be reaching out to coordinate pickup or shipping or delivery of your items. So make sure that works out. So the first items we're most excited about, the Digital and Analog Discovery 2. This one is really fun. John or George, did you have anything you wanted to say about this one?
Yeah, I'm hoping the bidding doesn't go too high so I can get it.
George, that was my thought. I'm going for that one for sure.
You know, actually, I do have a few comments on this thing. So in my workshop, I've got a couple of different conventional oscilloscopes. You know, the usual, Rigol oscilloscope, Tektronix oscilloscope. You know, from years gone by, all that sort of thing. And when I first got an Analog Discovery, I thought, well, that's kind of novel. I mean, I like the idea of how it works. It's very compact. But I found over the last couple of years that I actually use that more than anything else in the workshop. So the reason is because of the software. I mean, the device itself is good and capable, but the software that comes with it for free is really, really good. So I'll give you an example. I am working on a project which is a new repeater controller, and a lot of that project is an audio switching system. So you've got receiver audio coming in, then it goes through a bunch of things like filters, like PL filters, and an audio mixer, and a bunch of gain stages with digital pots to control the gain. And you can jumper in frequency roll off and preemphasis, de-emphasis, that sort of thing. Anyway, so it's an audio problem. And so I use the Analog Discovery and the waveforms software, because the 82 has a 2-channel signal generator built into it and a 2-channel oscilloscope. So I can take one signal generator and shove it into the controller to mimic the receive audio. And then I could probe various stages through the circuit and look at the very end where the audio loops back and comes out to the transmitter output port. So I can look at the gain through the whole thing. And look for distortion or other artifacts. One of the most interesting parts was looking at the performance of a filter. So we built a little PL filter. It's essentially a high pass filter to roll off the PL tone. And so I'm looking at the frequency response. What's the attenuation of the filter, and what's the group delay, or what's the phase delay going through the filter. And I could do all that with the 82 and the software. And I could set up the software with the signal generator panel and the scope panel and all that stuff, and then save it. So when I come back the next day, I just load that, and the same configuration pops up, and I could just continue on. So I just find that's so easy to use. And the other thing I would just say is that if you have a very small space, because a lot of us don't have a big workbench, a lot of us have like a tackle box with a voltmeter in it. This is the perfect piece of a little bit more advanced test equipment. So having an oscilloscope and a signal generator and some of the other functions are super helpful. The thing is so tiny, and everything else uses your PC for the actual visualization of the data. So
Hey, George,
I think you can't beat it.
David's asking us, our friend David's asking, so he sees in the picture some newer stuff. Do you want to, there's the deluxe kit has more than these kits we've been able to auction away other years.
Yeah, that's right. So let me mention a couple of these things. So the actual instrument is the puck down at the bottom that says Analog Discovery 2 on it. To the left is the USB is the BNC adapter. So at the edge of the device is a 2-row, I think it's 15 pins by 2-row 10th inch header. And you can just slip little jumper wires on those posts if you're going to a prototype, or you can take that BNC board, snap it on the end there, and the 2 signal generators and the 2 oscilloscopes ports are presented as BNC connectors. So then you could use the conventional BNC cables or the jumpers that come with it. To the far right is a little prototype board that has that 30-pin header that could just be snapped on to the front of the 82 to prototype your design. That's similar to the big one up at the top, the big white one, which is the conventional prototyping board. Below that are some clips that you can use to like little easy hook kind of clips. And then in the middle there, on the left-hand side, there's a little board with some relays and a few discrete components, and that's used for impedance measurements. And then the little T-shaped board to the right is a breakout that lets you go from the 82 to a set of headers that will plug into a proto board. So if you want to do a small prototype, you can use the one on the right. Or if you want to prototype a much larger circuit, you could use the prototype board on the top, and then you'd use that little T adapter to bring all of the Analog Discovery's inputs and outputs into pins on that big prototyping board.
Yeah, it's super powerful piece of test equipment. I've always been impressed with these. Cal Poly University actually uses the 82 for their electrical engineering students. So they bought a bunch of these and actually send them out to the students when they're doing their remote schoolwork now and remote lab work. It's been a really great way to get a great hands-on experience, a lot of good how-tos online, and really pretty straightforward to use. So really powerful piece of kit. The top bids right now are at $310 and $300 for the top 2 bids on this digital and ultimate Analog Discovery 2 bundle. And these are the fancy bundles. This is like the fully decked out kit that you can't get elsewhere.
So George, if our goal was to not run up the bids, you shouldn't have been so favorable in your discussion of it, man. Yeah, that backfired.
Well, yeah, good point, John. Yeah, I mean, really can't speak highly enough about these things. So, by the way, this was awfully nice of Digilent to do this for us, because I was speaking with Caitlin up there. She's the product manager for the product, and they've been out of stock because of the whole COVID thing, like you're saying, Marcel. They sold out of these things in a heartbeat last year, and their primary market is universities, educational hobbyists, and they couldn't keep them in stock. They had a pretty severe shortage. We actually had a discount coupon through the podcast, which you couldn't even buy them. I mean, with the discount or without the discount, they were just not available, and they're starting to get the inventory back up. And so it was really nice of her to be able to get us these 2 82s, given the scarcity of them.
Awesome.
That's great, George. Well, we got lots of other great items in the silent auction as well. Both QRP Labs transceiver here, $95 value has already been bid up to 100. So thanks for supporting BayNet. Remember, all proceeds do go straight to keeping our repeaters up and going and supporting the organization. The QRP Labs Ultimate S3 beacon transmitter is also doing really well. Top bids at 125 right now, right at the MSRP. So if you're interested in that, we've got quite a few people bidding and upping their value as well and upping their bids. So keep it up and do that. I did want to take a couple minutes here as well, George. This Elecraft XG3 programmable signal source, this is a pretty cool one. I know we had one of these last year as well. Can you tell us a little bit more about that and what I might want to use that for?
Sure. You saw that in Doug's presentation when he was talking about the instrumentation. He recommended this for a signal generator, and you can see it says that the RF signal source output is good from 1.5 to 1400 megahertz, which means this would be a really good signal source for any kind of radio alignment. If you're using any older radios, tube type radios, older radios where you really would have to align the various stages, having a signal source like this is really essential. But even on more modern radios, or if you're building things like QRP kits or other HF kits, this is going to be very useful because you want to generate an on-frequency signal going into the receiver to make sure that it's working and that you could test everything properly. So if you're a kit builder, if you are an old-time radio restorer, that's all really, really useful. If you ever wonder if your radio is working, if the receiver is receiving, then you can certainly use this to test virtually any kind of radio. Don't transmit into it. That's not recommended, but but for testing the receiver, that would certainly be useful.
And a big thanks to Elecraft, right, for donating this to us. Is that?
Yeah, Elecraft's been a really great sponsor for us over the last few years, and we really do appreciate everything that they do and let us be able to give away a great product like this.
Yeah, absolutely. Thanks, George, for telling us all about that. I really wanted one of these last year too. It's a pretty exciting one. So definitely check that out. Or of course, you can always pick one up directly from Elecraft too if you don't happen to be the top bidder. Right now, it's only at 210. We do have quite a few people bidding on that item, so it's a very popular item on the auction. Remember, auction will close at 4 o'clock Pacific, so make sure that you get all your bids in and hit submit before that time. So I think we've got about 2 more minutes left before we're going to switch over to the main presentation. So do just want to remind everyone, you can always go to bay-net.org/prizes and check out all these prizes. We have all the drawing prizes. We're not quite halfway through all the drawings. We've got a little bit heavy loaded at the end of the day. So, and a couple extra bonus prizes in there as well that aren't listed. So do stick around and get excited for those. Again, the bidding closes at 4 o'clock and the ticket sales will close at 4. That you're always welcome to donate anytime after that and anytime at baynet.org/donate as well to support the organization. So the rest of the afternoon, I'm pretty excited about the rest of the speakers here. George, did you want to mention anything else for what we're looking up to here?
No, I think we're pretty good. I can go ahead and introduce the next speaker if you're all set, Marcel.
I'm good. Vince, is he back? And we're ready to get rolling for the afternoon.
Okay, so next up is a talk by Mike Walker. So of course, Mike and I were just talking about remote station operation and automation. And one of the things that is really missing in that world is the centralized control system, if you will. So that's why I've been working on these build projects to do the hardware part of it. But we also need the connected system. We need a way for us to remotely control our stations through a Raspberry Pi or a PC or something. And so one of the approaches to that is developing software using a language called Node-RED. And so Mike's been working on a project to do just that. And we're going to hear all about it. So go ahead and take it, Mike.
All right. I think I'm going to need share control when we get to that. So thanks. Some of this, if you listen to the previous discussion, we sort of talked on that. But there we go. Start my video. We're back. And we'll pull up the presentation on this screen. And that all working for everybody?
Yes.
Perfect. Thanks, Vince. So Node-RED, I'm going to go through a bit of it that introduce you to Node-RED. And what is Node-RED? I call it a programming language for people that don't program like me. We've all wanted to program. We've all got every book on our bookshelf, intro to Java, intro to C#, intro to C. But we were okay with basic, and at least that's what worked for me. And I'm just waiting to make sure this comes up correctly. And that's not correct. Let me redo the sharing.
We're seeing your desktop, Mike.
Good stuff. Let me stop and start over. Thanks, Rod. It should be screen 3. There we go. And we'll see if that comes back. So we talked a little bit in the earlier talk about remoting, and so we're going to skim over that as well. But this is what my first control panel, or actually it was the third one, looked like. The first time I did it, I did it like a repeater site where it was all beautiful and, it was rack mounted and everything. And then it was really hard to work on as we moved on. And then the next time it started to be a mess. And so I got around to doing this, and this is right beside all the radios. And we have this mess of stuff, and I'll come up to that later. And why do we want a remote? Well, in the HF world, And even the repeater world, we're remote repeaters because they're high, they're clear, and they give us better range. In the HF world, we do it to get away from HF noise. And some other reasons is none of us are getting any younger. Maybe we have friends that are shut-ins, or you're going to be a shut-in, or you're moving into an apartment, but your buddy's got some real estate. And so we're seeing now that groups of hams are getting together to build a ham shack that they can use remotely. And so we're going to get to the point where how we keep making this easier. These are some key things to consider. I mentioned earlier, the internet is the tool that makes it conceivable today. In the earlier days of remoting, people had UHF links or gigabit links or microwave links to their radios. A lot of Californians had that, right, George, because it was easy for them to see the hilltop from the valley. Here in Ontario, that doesn't work. You could see the building. Well, that's not going to be any more HF quieter. And we have things to consider, like controlling our antennas, controlling our rotor, turning on and off the power, rebooting things, and just recovering so we don't have to get in the car. So these are some of the devices that I've used in my earlier days. I still use that Camtronic web switch. It's a web-based switch, so I can put it on my LAN, and I can still get to it if everything fails. If I can get to my network in the house, I can go manually turn some buttons on and off. And this is sort of my fail-safe switch. It controls some of the core power, the DC 5-volt control power for the Raspberry Pis. I use several. The power for the PC, because I highly recommend running a remote PC with the radio equipment you're using. And I can spend a whole hour on why to do that. But the reason is I only have to configure, well, there's a couple. I only have to configure one PC for remote operation, maybe for my logbook, my digital programs, or whatever. And today's world, with the things of like AnyDesk and TeamViewer or whatever, it makes it easy to get into or control that, was it Chrome Remote Desktop, etc. So that's incredibly important. And as we mentioned earlier, it's easier to get a network going. It's hard to do it right. And, port forwarding, you can actually get around most of that today. This is one of the items I've seen many people use for rotor control. It's the K3NG rotor controller. It's open sourced. You can use Pis or Arduinos or stuff to turn your rotor. There's a whole infrastructure built around these. And there's off-the-shelf remote control devices from Remote Rig and just about any rotor control box today. You can buy an add-on kit from Easy Rotor Control, Idiom Press, a whole bunch of different others. So here's a shot of some of the Remote Rig control box on the right. And essentially it just mimics the brake and the left and right buttons that we have on most of our rotor controls. Spent a lot of time on this one. What about Lightning? There's no app today that takes the coax, and we will get to Node-RED, and throws it out the window. And that's really the only true lightning protection today is to totally disconnect, if you're worried about your radio, every cable from it. That includes the DC power cables, even the ground cables, and certainly the coax cables. So what do? We do the best we can with some polyphaser stuff. Maybe we'll use some relay control. But if you take a direct heads-on strike, you'll be doing some maintenance to find out, repairing stuff and getting it back online. That's just one of the risks we have with Lightning today. There's some cool things coming out that people are doing with linear actuators to pull the feed lines a foot apart. They will all help, but it doesn't really solve the problem. And if you want to learn more about lightning protection, you can read Ward Silver's book. ARRL sells it. I saw his presentation in the Contest University last May. I thought I knew something about lightning protection. I learned I didn't know a thing about lightning protection. So if you want to learn more, you can go read Rod's book. And so how do we control things? So that's going to lead us right into our Node-RED world. I showed you this earlier. Yes, this is a bit of a dog's breakfast, but we can see we've got a network switch. In the bottom left, we've got some DC power control. How do we turn all that stuff on and off? I had a watt meter that would hang every once in a while, and it just needed the power cycled to it. So that got routed through another relay so that I could just, in the middle of a contest, power cycle the watt meter. I have web switches. I had a Pi in the middle that had 16 relays on it using all the GPIO ports. It worked really well, but You want to make sure you have a device that if you reboot it, the relays don't reset because you don't want the power on your PC recycling. So that's why I have 2 different versions of web switches. I'm also a lightning map receiving station. So we have a lightning map controller, and I have a Raspberry Pi that its only job is to make sure the internet's up, and it checks every 20 minutes. Can I ping 3 different sites? Are they there? Great. 2 of them are gone. 1 of them is there. The internet's probably up. And its job is to reboot the router and the modem if that goes away, saying, because that's the first thing your company tells you, your ISP, well, did you reboot your modem and your router? So it automatically does that. The good news is today you can buy those things off the shelf on Amazon. And this is what the HF Shack today looks like. This is an SO2R full legal limit shack in a box. Why am I using such a big PC? Because it helps heat the box in the wintertime. And then why in the Astron 70 amp power supply on the bottom? Well, geez, couldn't use something a little more heat efficient? Absolutely. But this helps heat the box in the wintertime. So you sort of get the idea. I'm fortunate to have access to a Power Genius amplifier down here. And this is a Flex 6600 in the middle. Let me get my pointer active. There it is. Here's the 6600. I've gone to using an LP100A watt meter, and that is not a web-based device, but you'll see later on how I made it a web-based device. And it's also the most accurate watt meter I think you can get today. There's maybe 2 that accurately present peak envelope power. And this is just a drill in of what the rest of it looks like. And you can see now I've gone to 2 of these KM-tronic web-based switches, but I can still control those with Node-RED. Those are the backup, web switches that have ports forwarded to them, so I can get to them offline. Everything has a second path to it, just in case, except I only have 1 internet path. Some ham stations have 2 internet paths. They may have a cellular data phone they can flip to if they have to get logged back inside, either to turn things off or to do additional diagnosis. And this is the operating position. That's taken a couple of weeks ago, pretty much what it looks like today. So yes, if you see me looking up in the air, I'm looking up at this monitor where your presentation is running. Okay, Node-RED. So Node-RED was developed by IBM actually quite a long time ago. And it's a machine-to-machine communication tool. It's designed, I truly think, for people who aren't programmers but are logical thinkers. And you can tie all these nodes together and make it look like a web page. And I looked at it and went, I'm never going to learn this. And I was actually producing useful stuff within a few hours. Unlike the book of, let's see, I got Python, learning C# 3.0. I mean, all those books are there, but I can't program to save my life. So it's browser based. So it's very GUI, what you see is what you get. But what I really love about Node-RED, if somebody shares the code that they've written, which they've already done, it's easy to follow their logics through the flow. And we're going to see how that works when we look at George's GPIO box. And there's a lot of libraries built in that are already written. I wanted to know more about weather. Somebody had written a weather library that pulls the metadata from local airport, and then a little GUI pops up and says, hey, the temperature is and the wind's this. Maybe the wind's howling greater than 30 knots and it's out of the west. I can now send a rotor command and say, hey, turn the beam so it faces into the wind. So here's George's box. We've seen that earlier. I guess, I don't know, George, is this version 1 or 2? But we've got 8 relays. We can do voltage differential. I want you to notice that the voltage differential board is missing, and that's why I'm getting 0. At least that's what I thought you said. It plugs in about here.
That's right.
Is that right?
Yep, that's right.
Okay, I almost wondered why. I was going to ask you why I was getting 0. And then he sends me this list of commands, and he says, well, see what you can do. Well, we can see that in the raw commands, if we look up here, we've got a relay command. Here's an example, turn relay 3 on. Okay, I can live with that. And then he said we get this binary data back, and it's the status of all 8 relays, and then these digital inputs, or whether they're high or low, and the 4 voltage readings, and then the differentials, right? And then he's got some addressing at the beginning, which I really should do something with, but I sort of got skipped over that. And that's pretty much all he gave me. And about 2 hours later, I turned it into a web page that looked like this, that not only works on a web page, but it works on my iPhone, Android phone, whatever tablet you have. All this is running on a Raspberry Pi. So I have a Pi with a USB adapter, happens to be a 485 RS485 adapter connected to it. Again, they're not very expensive. And lo and behold, here we go. I left the digital inputs never got written, but I could add those actually in about 10 minutes now. So let's look at how that works. This is the program. Wow. Well, how do we start? Well, this is, we'll walk through the steps here to give you a clue. And as it breaks down, I think you'll see how easy it is. So we start here with a command called query. It sends his, he told me I'm doing it wrong, but it worked for me, /ping command out to the USB port on the Pi. And that's connected to his GPIO board. And that's cool. So that eventually goes away. And then the command comes back up here where we get the data from the serial port. So we get it in, and then we come in and we start to play with it a little bit. So the next thing, is we can, as the data comes in, we have to put it in some format. Again, these yellow things are tools of Node-RED. They actually convert the data from something like a string into something we can use. And I wanted it in an array. I didn't have to parse it on my own. There was all this array stuff built in, and it produced all this data. Look at this. I've got it already. It's coming from unit, from that unit, this address. This is what I'm really paying attention to stuff. These 8 bits are for the, what status the relays are in. The next one is whether any digital inputs are high or low. Then we get my voltages. So I've just got wires jumpered across to the 12-volt line and over to the 5-volt line. And then I think this is a checksum, right? So you get the idea, and we can parse those all out again with tools that are already built into Node-RED, and they're called message payloads as we communicate the data from node to node. And there's a couple of other advanced features, but the point is, we're just sharing information from one flow or one node to another. And in this case, in this volts 3, here's a big ugly string. Well, how does that work? Actually, I was able to just drag that in from the previous debug window and say, just grab this data. Okay, now we're going to parse it out and we're going to send it to the web page. And we'll show you the web page. Well, you've seen it already. The RBE means don't send it again unless it's really changed by 1%, 5%, or some number, and it helps eliminate any noise we may or may not see. So we look over here, I was going to go down this path of parsing out the web switch stuff, the 8 bits. We come in here, we split them out in a switch. This is what they look like in a switch. Well, bit 0, bit 1, bit 2, bit 3, bit 4, you get the idea. We change the component, and this is the web page part. This blue here, this light color blue, is actually the button we're going to see on the web page. But the button has enough code in it to know if it's true or false, and if I push it, to send out something on the other end to turn the switch on and off. And we did a demo earlier with just 4 switches that we could make that just work. Look at this here now at the end. This is what the raw data looks like. We have the raw data came in. Down here, we parsed it out to the data we wanted. So that's what the relay 1 and relay 5 are on. And over here, we sent the ping command, /ping, which I now need to do differently, out to the relay board. And that was it. Yes, looks a lot complicated. A lot of it's just really repetitive. So, and it's the nice thing too is there's a whole lot of data available online to get you through this. So once we're done, I had a web page that looked like this. You saw this already. And on the right hand, I just took a screenshot in my cell phone. And while it sort of overflowed to the right, I can move it around with my finger and make changes as I want. So this also means I could be in my car or anywhere else and have access, full control of the station. Okay, so that got you to George's web switch. What about some other stuff? Well, let's get through some of the intros first. This is some really cool documentation that's available on the Node-RED site. How to get started, whether you want to run Node-RED. So it's your interface control box. You can run it on a Windows PC. You can run it on a BeagleBone Black, a Pi, a number of things. They've designed it to make it truly platform agnostic. Then they have all these tutorials, you know, the user guide, which whoever looks at the user guide, well, you should, but of course we don't understand enough of it. So I'll go right to the tutorials. We've got cookbooks of things that people have done. We've got all sorts of different things. If we go to the next slide, there's a library here. Now, I forgot how many items. There's 3,000 things people have shared in the library. So if you also want to integrate Alexa or anything else into Node-RED and say, hey, Alexa, turn on my HF radio, you can do that. And you don't have to be a top-end developer programmer. Somebody has already done all that IoT stuff that makes it super easy to do. Bit of education, yes, but very easy to test as well. We also have a group on groups.io devoted to amateur radio. Now, a ton of it is Flex-centric, but that's okay because a lot of it's starting to come in now for the ICOM Kenwood Yaesu world. A lot of Kenwood stuff because the Kenwood command set's fairly well known to integrate other stuff. And I'm going to show you a whole bunch of slides coming up to what people have done to integrate their station into one application. The one thing is, in my ham shack earlier, when I started out, I had a number of items. I had to start a program for the amplifier, just start a program for the watt meter, just start a program for the antenna switch, and it was just, you know, in the early days it was cool, but it was clumsy, and I always wanted one thing better. So the groups.io, Node-RED-ham radio at groups.io, and we are there to help you. So there is no, you're not going to go read the manual. You might go walk through the tutorial on this and come back if you have any questions. Dave WO2X, who's retired and finds this incredibly relaxing, is actually going out and writing things for people as well. We've got Andreas from your neck of the woods, N6NU, has been an amazing help. He was the one that kicked us off on getting going this. He wrote some of the core stuff that we all took to the next level. So thanks to Andreas, and I apologize if I busted his call. We've got Alan Blind, who call sign escapes me, that has written some amazing everything, including satellite stuff and a whole bunch of different things. So here's and we also have a wiki for you to get started on it and running Raspberry Pis. I think the Pi is the best thing to run your Node-RED platform on. It's got web servers and everything built in, and it doesn't consume any power, and it's easy to keep it up and running forever. Some of the reference stuff, if you want to take a screenshot of this, or you can pause it. And again, you can certainly email me and I'll share this with you, but it's also on the groups.io. And by the way, here's some of the stuff people have written already to integrate, from amplifiers to automatic lightning disconnects. If there's lightning within 50 miles, if they fires off a whole bunch of relays to turn things off, high SWR alarms, stepper tuning, direct integration to McDoppler, reading the meters on all the Flex radios, the Power Geniuses, turning GPIO pins on and off, et cetera, et cetera. So a whole bunch of stuff. And then we have, you know, this, I deleted this whole flow because it was so simple, but you can go buy this relay on Amazon for $9, plug it into a Raspberry Pi, and have 4 relays that you can control on your own and have them turn on and off things. And if somebody goes down this path and they want the flow, I'll be happy to rewrite it for them and share the flow with you. It's very easy to share flows. And they came up with a web page going relay 1, 2, 3, 4 off. Heck, you could have the Node-RED say, hey, if the radio goes to 40 meters, I want this relay active, type of thing. So let's run through some control panels. This is my control panel right now. It needs a big facelift. But on the left, we've got all my relays. I have 16, but these are the only 8 or 10 I'm using. I've got probes on my Pi to read temperatures, on the amp tray, just how warm it is, or, you know, SWR from the LP100, my rotor headings, and automatic stepper stuff, and et cetera. Then we start to get carried away. So this is KK9 November's thing. He's got graphs. He can change all his antennas. I won't spend a lot of time on this, but if you're playing it back, you can pause and see a number of things. He's reading the frequency of the radio, voltage meters, LP100, And I don't know if he used my code or his own, because it was pretty easy to parse. Cat 500 control for his Elecraft. Somebody's using FR Stack, which is a Node-RED tool, to integrate to his radios, brings a whole bunch of different things as well. And in our world too, we want everything keys off frequency. If I go to 30 meters, what do I want my configuration to look like? Oh, I got to remember to switch that antenna. Maybe my power needs to be only 50 watts or 30 watts, because some radios will accept power level controls to tune the power down, etc. HF auto antenna control, or tuner control, again on one page, web page. This is Santiago, Hotel Indio 8, Sierra Mike X-rays. He's written a lot of stuff as well for his station. And whether it's local or remote, it doesn't matter. It's all web-based now. And not everybody's put their call on it. I like I use these graphs all the time to ping to see if I'm getting long latency on the internet. This is his Raspberry Pi control, the temperatures, etc. Another Node-RED dashboard where this is controlling the slices. A slice is a virtual receiver, or just a receiver on a flex radio. Some radios have 2, some have 4, some have 8. They can change filter widths. You can do anything. I'm actually waiting for someone to write a Node-RED client for their flex radio, and it's only a matter of time. Weather Center. And these are all people that are not serious programmers. Whiskey X-Ray 7 Yankee. This is Brent, and a whole bunch of different things. And by the way, we've also seen a lot of things. If you're colorblind, not uncommon for a manufacturer to send something out with red in it, and that's of course hard for you to read. So you can make your own high contrast screen, change your fonts, make it really big, really small. I like really small fonts, but most as we get older, we like really bigger fonts. So, and here's some more. I'll just toss through them. So there's just so many different options. Stepper control, Whiskey 9, Kilo X-Ray Quebec. You can start turning on alarms and warnings for temperatures. I really should do that on mine. If the temperature in the box gives above 30 Celsius, maybe it needs to text me to pay attention, because my fans have failed. Whiskey 9, Kilo X-Ray Quebec. He's got control for his SVE amplifier, etc. This is Dave, WO2X, with his, he's got a widescreen like me. He's got one of these nice big widescreens, so it doesn't present well, but he's got all his control on top and his flex radio underneath. Kilo Zero Victor Mike. And the nice thing is all these guys, they'll share the stuff with you. If somebody's written a W2 flow, they'll share it with you. And a bit of advertising, because yes, this is Flex is also a sponsor. And as for that, if you're interested in a radio, we actually have some coupon codes available. I'll put them here for a second. And we're pretty much at the end. George or Rod, so if you have any questions, I can't see the chat at the moment.
Okay, Rod, do you have any questions on the chat?
I'm a little thin on questions on the chat. I don't know if
couple.
anybody wants to type in at the last second.
Well, I have a couple. Actually, I have too many questions. So one question I've got, Mike, is if someone else has done this kind of Node-RED stuff and you want to get their program, what form does it actually take? Like, what do you get?
It's actually amazingly simple. They copy it into their clipboard and they send it to you in an email.
What is
it's JSON.
Oh, okay. So it's stored as it's a file, and then you just load it on your.
Yeah, it's all just regular character text. Heck, you could transfer it on packet radio if you wanted to. It's surprisingly efficient too. They're not very big program. They're like a couple of K, and most people just paste them into the body of an email.
Have you seen like other? What's like the most exotic integration? I mean, I see a lot of the same things that people have done, but like what's sort of the more unusual kind of things you've seen people try to integrate?
We're seeing a lot of the cool stuff now is, hey, if I go to the CW band, if I dial down to bottom end of 20, just reconfigure my radio. Okay, put it in CW. I want 400 hertz filters. I want, oh, and by the way, I'm on 40. I want the preamps on. I drop down to 80. I want the preamps off. I'm on 160. I want the attenuators on. And so as it starts out really simple, right? We turn a couple of relays on and go, well, geez, if I go, if I leave the room, turn the relays to ground, and, that's starting to happen as Kyle out of St. Louis said he got going on it and texts me the next day. He says, I stayed up till 3 a.m. not struggling because I was making huge progress, so that we found that the learning curve is not really big, which is so much better than, writing raw code because you've done it. I mean, at George's level, it's all embedded code, so it's okay. He doesn't have to worry about GUIs just to handle strings. But if you're an application developer, you've got to worry about the GUI. You got to now, okay, I got it going, but now I got to make the GUI look nice, and now you make your own GUI.
One of the reasons this is very appealing to me is that I've seen a lot of web UI environments for commercial products, and there's a very complicated set of software that you need. I mean, besides the web server, if you're gonna have a UI presentation language, you're gonna have a database. I mean, there's a lot of stuff to wrap your head around, and this seems like it's a pretty reasonable thing for anybody to attempt to do, which I guess is a key point that you're making.
Yeah, absolutely. And I think if anybody's remotely interested, no pun intended or implied, grab a Raspberry Pi, order up that web switch, that 4-port relay by Keystone, I think it was, and make that work. And then use it to, I don't know, turn your, whatever on and off.
So one specific question I was curious about, like, a lot of the examples here are flex radios, and it seems like you could do the same thing with like your 7100 or a 7300 or whatever. It's just a different serial port string that has to be sent to that.
Absolutely correct. Because the Yaesu, anything that does RS-232 bidirectionally, so ICOM does, and we haven't had a big ICOM group, and I can't wait for them to get in there because ICOM's bus addressing is really going to work well on this. Because every radio has its own hex address. So, and I probably should go do some. I just haven't had time. Pull the 7100 out, and or the 705. Yes, I work for Flex, but heck, I own a 705, a 9700, a 7100. I'm still a ham. I still buy stuff. I like my HF stuff where it is, but the other stuff's cool. And I probably should go to the 705 and start just reading data off it. I'll have to build a TTL to RS-232 computer, or I might have one in a box somewhere, but that's the only thing missing is someone just to say, okay, did you get it working? Can you read the frequency? That's all I want to do. Right. And then you get carried away. So
one other question I have for you, it's some of those meters, there's like power meters and stuff like that. Some data is pretty static, like the power's on or off. If it's on, the light's on, right? It's not going to change for 7 hours until you shut it off. But something like the RF power meter, that data is like changing constantly. So right. How do you deal with that? Frequently does that display update? What's practical?
So that's a nice thing. The LP100 or any RS-232 watt meter is only as good as its sample rate, right? So if you read the meter once a second, you're going to get the power at that nanosecond. The smarter meters, and there's the other name I can't think of, but the LP100 actually continues to do the math and will report peak power. Rod's nodding his head because he's learned that lesson. Report its peak power over its longer sample rate, which gives you a much more better peak reading. I read my watt meters because since I've offloaded the reading to the watt meter itself, I think every 500 every half second.
So you actually see the meter like bouncing around.
Oh yeah.
Oh yeah. Oh, okay.
But you bring up a good point. I have a full meter for my 12 volt power, bus metering. Well, I don't really care if it's 12 or 13. I just want it to be there. What I really need to do is change that into an alarm and say it's below 11 or above 15, right? And have it flash, the whole red screen red or something going.
So here's a whole nother application for this that I'm very interested in also, and that is instrumenting our repeater site. Because anybody who's been a repeater administrator knows that for a lot of us, you can't get to the site conveniently, or maybe it's in a snowy mountaintop and you just can't get there for 6 months, and you want to know if something poops out, you want to know what failed so you know what to take to repair it. And you'd also like to know when things are starting to go bad. So if, let's say you have a 100-watt repeater and it's putting out a nice solid 100 watts and everybody's happy. Well, if it starts putting out 85 watts, it sounds the same, but I'd really like to know that, because it starts to tell me that maybe there's some water getting in the feed line, or maybe the PA is starting to age, or something is not quite right. And knowing that would be really useful. In fact, logging that would be even more useful. So are there facilities in there where you can log the data at periodic rates?
Yeah, you could. There's whole database access if you want. You could just write it out as a CSV file. And, as a repeater operator, if I had this back when my repeater days, I think, the first thing I'd be logging is current, PA current. What a story that would tell, right? Hey, I've got to go up with a new, the PA tripped off, didn't notice it, but it alarmed. And the Toronto FM Communication Society, we had a little bit of that, but we had to go, something's not right. And we had to go pull the binary down and then go through the telemetry and say, oh yeah, that voltage is a little off, or is the sensor bad? So, but yes, absolutely. And it's not complicated to write anymore, but you've got me going now. Now I got to get a current, probe, and I'm going to put it on my power supply, because exactly that. Or more importantly, it should be no more than 20 watts and I'm drawing a lot more, because I can give it. Let's wait for the fire.
One of the first things that I looked for too, by the way, on that repeater theme, is probably half a dozen times a year that I'm aware of, we lose power at the repeater site, which is the reason why we put in a backup battery system. And I would like to know when that happens. So even if the radio stays on, if the power goes away, I'd like to get a text message that tells me that the AC power is out, or when it comes back.
We did that too. We actually had the CW identifier drop to a different tone. That's how we knew the power went out. And there's, what, I'll be honest, there's no reason why you couldn't write a repeater controller in this in about 20 minutes, if you can handle the audio switching. And you could do it all with relays if you wanted to. It's maybe not pretty, but it's nothing wrong with it. I think Rod was going to say something.
Yeah, I was going to ask a question further on the LP100, because there was discussion of that earlier on. Somebody picked that out of one of your diagrams. Is it easier, harder to work with that as a measurement device?
Oh, I think it was hugely easier. I have two Elecraft Watt 2 WT watt meters for sale that I'm not using, but wonderful watt meters. But this is just better. No, that's lab grade equipment, Rod, and it was easier for me to manage that than the Elecraft watt meter, because I had to keep sampling and I was worried about starting to load up the Pi. With the LP100, I could just ask it every 500 milliseconds and I would get a valid number. And to be honest, I don't really care if the number is 89 watts or 100 watts. I just want to make sure it's not 3 watts when I'm expecting 100 watts.
You're looking for an indication, not a lab measurement.
But that is lab grade equipment. But yes.
So how much is the LP watt meter?
Dual probes, 500 US. It's not cheap.
So here's if you want the homebrew version of something like that to consider.
Please. Yep.
So I was looking at doing a remote monitoring of the power for this reason a while back, and I was looking at different directional couplers, and you can spend a boatload of money on really good commercial couplers, and I found a source that I thought was incredibly reasonable, and it's another company that makes watt meters called WaveNode. I don't know if you're familiar with them. But the fellow Alan who runs WaveNode's great guy, and so I bought some of his sensors. So I actually don't have his watt meter, but you can buy the sensors, the directional couplers by themselves, and he has them at different power levels at different bands, HF, VHF, UHF, etc. And what the directional coupler gives you is a voltage. So if you put power through it, it will give you a voltage that is an indication of the forward RF power, and on another pin, an indication of the reflected power. So for like $100-ish, you can just buy the directional coupler, take those two voltages and put them into the analog to digital converter on your GPIO board or whatever, and then have a look at the table and tell you what the wattage is.
There's one.
And Marcel is sharing something on the screen. What is that?
Marcel has to speak in order for his video to be seen and to be unmuted.
It shows up on the video. But yeah, the directional coupler with, like you said, with two BNC ports on it that give you the voltage output. So same idea.
Yep.
And that's probably a surplus one you picked up somewhere along the way. So that again, it would probably be easy to do, because all you have to do, like let's say, for example, if with my GPIO board where you've got an Arduino and an ADC there, you could just take that voltage in, and then in the Node-RED code, you can translate that voltage into watts, and then there you go for $100.
I was actually going to ask you, could you pull the voltage off the Elecraft probes?
Oh yeah,
do
actually,
the same thing?
I've done that.
Okay.
Yeah, I have the Elecraft directional coupler for their watt meter, and of course, I don't have their watt meter, but I have the directional coupler. The problem is that those directional couplers have frequency compensation built into the watt meter itself. The wave node couplers are flat. So in other words, over the frequency range of the device, you'll get a consistent voltage curve for the wattage. So they did a really nice job of calibrating them so that that's the best probe to use for this application that I found that's reasonably priced.
Perfect.
So Mike, one other question here around other devices, consumer devices even. Is there libraries that we can use to get other things in devices like Zigbee or Z-Wave or things like that?
Probably. So if you're sitting in front of your computer, oh wait, you are, go to nodered.org, I think it is. It's pretty easy to find, and then go to the library and just search on Zigbee and see what comes up.
Okay.
And and I think you'll be surprised. Search on weather. Search on IO. There's a whole bunch of stuff. I think it's 3,000 or 4,000 flows people have, like you and I have written, and we haven't put the amateur stuff there. I guess we could.
So the thing that's
and what about libraries for cat commands, that kind of thing, like kind of a ham lib for Node-RED?
Not that I've seen, but I think what we're doing is we really had talked about we need to build a library for different types of radios so people could, but I don't think anybody in the groups yet figured how to build they're called nodes, how to actually build the node and says, give me the Kenwood frequency node, we're still doing it sort of the hard way, but I can see guys like Alan Blind pulling that off when he's up all night one night and just saying,
well, that'd be pretty easy. You could just sample the serial port and then decompose. Kenwood would be super easy because it's
the easy one.
Text. Yeah.
Yeah, we just have to look through the cookbook and say, how do you create a node? How do you create and publish the node? That's sort of the next.
So what you did to decode the response from my GPIO board, it's no more difficult than that. It's just
correct
format. So that'd be pretty straightforward.
Okay, I think that's all the questions we had. There's a quick question about logging the CSV files, but
it's pretty straightforward. It's just grab all your data and write it. And you don't have to worry about file management.
But the answer is yes.
Yes, no problem.
Okay. Hey, thanks a lot, Mike. That's really interesting, and that's something else I have to put on my list to do in the near term. So thanks a lot for that.
Too bad you have to sleep.
Well, I'm working on it. All right, thanks. All right. So with that, we're going to go ahead and hand it over to John and Marcel for another drawing.
Sounds great. Thanks so much. Hey, John, what time is it?
Fantastic, everybody. This time, it's drawing time.
Bing, 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 bing. Correct. Remember, it is a fundraiser today. Thanks to everyone who's been buying extra tickets and bidding up on the auction as well. It's going really well right now. We will be closing the sound auction and closing ticket sales for the drawing at 4 o'clock Pacific. So you've got another about 2.5 hours for those in different time zones. So do check that out. And we would have 2 extra bonus prizes that were just added to the end of the raffle, or of the drawing at the end of the day. So looking forward to that, and make sure that you get ready and excited. So we're going to do 3 more right now. The first one is this Nuelec SDR dongle and HF converter. This one's pretty slick, $50 value. John, who's this one going to?
Yep, and we now have over 4,700 tickets in the drum. People are still buying, which is much appreciated. And the number is going to 3710. So let me look that up. 3710 goes to Larry Groom, last name Groom, Larry Groom.
Awesome. Congrats, Larry, for getting the Nuelec SDR. It's a pretty slick one. I've seen some people using that online as well. All right, we got another one. This is a fun little DIY solar panel grab bag mystery box. So this is a fun box of all sorts of random solar panel assorted parts and cables and stuff. Pretty exciting. So John, who's this one going to?
Yep, this is going to number 3618. And I will see who that is here. 3618 is Randy Neals, Neals.
Awesome. Congrats, Randy Neals for getting the mini solar panel grab bag mystery box. All right, and we've got one more. This one's pretty slick. It's the West Mountain Radio Rig Blaster plug and play. So if you're wanting to start doing some more Node-RED stuff and interfacing your radio to the computer, this is a great way to do it. $120 value. Pretty excited about this one. Who's this one going to, John?
All right, and the winner is 2093. And that is $2093, confirming here, is Richard Tate, last name Tate, Richard Tate.
Awesome. Congratulations, Richard. So thanks again for everyone that's been buying drawing tickets and supporting the silent auction. The silent auction is getting pretty active right now. We've got a couple more people bidding in. The Ultimate Analog Discovery 2 bundle from Digilent is up to $325 now, top bid. Remember, you can just edit your bid and you don't have to resubmit a whole new form if you don't want to. When you submit on the last screen, there's a way to go back and change your bid, and you can add a new bid. It'll update the timestamp to when you hit submit. So that saves you a little bit of typing for those folks that have been resubmitting. With that, George, we've got a great presentation coming up.
Thanks, Marcel. So one of the hot topics right now is satellite operating. And you might say, well, hasn't that been a hot topic for the last 40 years? And of course, yes, but now there's even more interest because with the ISS having an FM repeater as part of that, there's just a lot of folks that are starting to get into satellites for the first time. And so we have a great presentation from John, KJ6ZL, who's going to give us an overview of what you can do with satellites, what kind of gear you need, and how it all works. Take it away, John.
Hello, and welcome to Working Amateur Satellites. I'd like to be able to give you some information about how the satellites operate, what you can expect when you're on the air, and hopefully kind of kick off a little interest here and get as many people as possible to play this game. I think they're great fun, and I would like to see lots more people doing it. First, let's go a little bit into history. I hope you can see my mouse here. We'll go a little bit into the history of some of the amateur satellites, a little bit about satellite law, what's going on nowadays, a little bit of the international efforts for amateur satellites. Then we will explore the AMSAT webpage itself a little bit. Quite honestly, because it is one of the best places to gather information about what's going on, what the satellites are like, and how they're doing in operation at the moment. Then we will go directly into satellite operation, what you can expect to hear on the air, why things will change a little bit in what you're hearing on the air, and a little bit about setting up a satellite station. Okay, so let's jump right into some history. So amateur satellites began, I guess, in the 70s. For me, my involvement began in the 80s, I guess, and they were already up and operational. Operation was on 2 meters and 10 meters and moved very quickly to 2 meters and 440. Now, 440 at the time was sort of an experimental band. You kind of had to make some of your own equipment. It wasn't common to be able to come across 440 equipment, but that's all in the past. Now, of course, 2 meters and 440 is very common, and an HT with 2 meters and 440 is all you need to be able to work satellites. And very likely that's not going to change much in the future. So your equipment that you have right now is still useful. The older satellites were large. They ranged in size from, say, maybe a 5-gallon bucket to a garage can size, garbage can size. Some were a little bit larger than that, but not many. And I really honestly don't know how amateurs were able to pull off launches of satellites at that time. But it's getting, that's another thing that's getting harder to do, which is get a chance to get your satellite launched. Some of the earlier ones actually had rocket motors on board, so that they could move from a circular orbit into a larger sort of elliptical orbit. Nowadays, I think talking someone into a amateur building a satellite with a rocket motor on it that has fuel that can explode is going to be a little more difficult. But apparently in the past, things were a little more open. Okay, now the satellites, pretty much all satellites work this way. They're powered by solar cells, and they tend to be spin stabilized, so that they can possibly, they will be spinning on one axis of some sort, so they stay pointed on some axis. But the real reason for the spin is to kind of evenly heat the satellite. Up in the sun there, the sun side is very hot, and the non-sun side is very cold. So spinning them is really the way that you help the electronics on board. So a little bit of history here, and the reason I brought these two up, these are old satellites, but they're still operating. AO7 is still one you can use, was put up in the 70s. And this is what it looks like in space. It has 2 meters and 10 meters on board. You can see the 10-meter antenna on that satellite. The 2-meter antenna is these beams here. Fuji Oscar 29 is also, has been a fabulous satellite for years. I think now its batteries are beginning to fail a little bit, but it's been an incredible operator. And you can see its physical size here by comparison as they're doing some testing. You can see it's covered with solar cells, as I mentioned. AO13 was a somewhat large satellite. It's roughly about 6 feet across. Reason I bring this one up is because this did indeed have a rocket motor. You can see the motor in this portion of the picture here, or in the drawing. You can see the motor in this area. And it was used to accelerate the satellite up into an elliptical orbit where you could actually see the thing. The thing would be in view for a long period of time. You could work the satellite for an hour and a half or so. So satellite law has had to come in place a little bit now that we're putting up more things. And one of the most important things is, in the world of space debris, you have to develop a plan before you can get your satellite to be launched. This has been agreed upon around the world, that you have to be able to have some form of a plan to be able to remove the satellite from the sky after 25 years of operation. Now, there is already controversy about that thought. There are some people wanting to make that less time. It may be a good idea. Maybe 25 years is too long. Maybe it should be 15 years. And there's a huge amount of effort going on in low Earth orbit, LEO satellites. LEO satellites. There's companies and everything else involved in amateur satellites, mostly are low Earth orbit satellites. But there is an interesting thought about this. As we have filled up space, it will reach a point where the low Earth orbit satellites themselves are becoming a problem. As John Jenko wants to mention here, putting a non-maneuverable CubeSat, for example, in low Earth orbit, in densely populated orbits, it's a little bit like allowing go-karts to be on the freeway. It's probably something you shouldn't do. If you're going to try to be able to launch through a crowded area with a bunch of small things in the way, you're looking for trouble. And he's possibly got a point. So as time goes on, we're going to end up having to be careful about how much we've put up in space. So there's things called graveyard orbits and satellites. How do you how do you make a plan to be able to get your satellite out of orbit? That's part of the plan you have to make as you launch one. There's also international space law seems to be open. It's hard to determine if there's agreement taking place around the world. So we don't really have full understanding of how it is that we're going to handle space. I guess that's the way to leave it. So here's an interesting video of satellites in orbit. This is a map of our current set of satellites. You can see the large band here would be the satellites that are in geosynchronous orbit. The low Earth orbit satellites are so close in around here, you can't hardly even tell the difference between them and the atmosphere. There's so many going around the Earth that it's hard to tell what's going on. But this is there's space. There's a lot of space in space, and these things are not hitting each other. But as you can see, it may become a problem. Okay, moving on. In the world of amateur satellites, there is organizations around the world. AMSAT is one, amateur SAT. So AMSAT North America is the one here in the United States. There's AMSAT Deutschland, AMSAT UK, there's AMSAT Japan, and in China there's CAMSAT. But to give you an idea, AMSAT Deutschland has actually put up a geosynchronous amateur payload. That's quite an accomplishment. And they also have a rather ambitious project going called Go Mars, which is to actually orbit a satellite around Mars. AMSAT UK has been very deeply involved in making the things they call the fun cube sats. They're CubeSats, fun cubes. And they also tend to have a support structure of sorts to support ground stations and be able to do satellite control. But they're not the only ones in the game. Philippines have put up satellite, PO-101, works great. Saudi Sat, SO-50 has been up for quite a while, and that's a very popular satellite. Argentina now has a transponder satellite up. Jordan has put up a satellite. China, as mentioned, has the XW Sats, which have been very successful, and the CAS Sats. Most of the development and efforts comes from universities in these countries. In China, student satellites, there's actually a satellite launched by university students that's orbiting the moon. Okay, so Deutschland, AMSAT Deutschland, this is the footprint of their geosynchronous satellite. It covers, it's over Africa, so it covers Europe. It can be touch portions of Indonesia over here, a little bit of South America, but it's not where we will see it in North America. So we really have no view of that geosynchronous satellite. I see a lot of effort, a lot of excitement going on with amateurs in Europe, building equipment to be able to communicate on it. It's 2.4 gigahertz and 10 gigahertz up and down links. So a little bit into the realm of experimental equipment. You can buy equipment for these ranges, but you can also build your own. So it's sort of sparking a bunch of development. The Go Mars project is hoping for launch. Its initial plans was in 2002, and then they restarted it as a plan in 2012 and tried again in 2018. I think it's very aggressive, and let's wish them luck. AMSAT UK, as mentioned, has a lot of capability for ground support. They have a science control center. They also have a main control center with up and downlink capability and monitoring capability. They tend to be very successful in the range of doing ground support for a lot of the satellites. I believe a great deal of the Earth, of the world, is using their their facilities. Okay, let's go to AMSAT North America and look around a little bit. So I'm going to leave my PowerPoint presentation and let's open a web browser here. Okay, so this is AMSAT's homepage, AMSAT North America's homepage, and I'd like to invite you to navigate to this bar here to satellite info. Let's look at communication satellites. And the good news about AMSAT North America is that they have everything. They have a good list of everything available. The communication satellites, for example, this is the list of FM repeater satellites that can be operated, and the transponder satellites, and the digital satellites. For any of you who don't know what FM or transponder or digital means, we'll get that in a minute. But look at how many these are amateur satellites. Look at how many are available for use. Another thing on their page here would be the current status. Under satellite info, we'll go to current status. Now, this is an interesting page. Amateurs using the satellites can add to this page. What you would do here is if you heard the satellite, you would say which one it was, what you heard, what time it was, and submit your data and provide a list of operational capabilities. You can see by date, this is today's date, and then that's yesterday, and then the day before yesterday. So it's 6 days back in a row, with this being the most fresh, and the various colors. Yellow would mean there's telemetry beacons. Blue means that the voice transponder was active and you possibly heard voices. So if you wanted to work, for example, voice here on AO27 looked quite successful, and a few people have put in their information. WD9EWK says that he heard it. AA5PK says that he heard it at this time. Others, for example, here's a single. And you can go to this page and you can find out immediately what satellites are on the air, having been used or are being used at the moment, and if they're operational. So that's a very handy thing to see on the page. There are many more things on this page. I invite you all to explore this location, and you can even look up software, satellite prediction software, and things like that. Okay, let's go back to the PowerPoint. So, satellite operation. What can you really expect when you actually get on the air for satellites? Well, almost all the satellites up are CubeSats, meaning that they're small. They would all be up in low Earth orbits, meaning that they're close. Therefore, going by fast. So what you get is you get a time where they're overhead from horizon to horizon. It's probably less than 20 minutes in most cases. And the satellite, of course, has got radiating antennas on board. We'll talk a little bit about what that means. And also, many people are trying to use the satellites, and multiple users at the same time. There can be some effects from that. But of course, the most important thing going on all the time is Doppler. The satellites are moving so fast that they will indeed affect your RF signal and shift you out of frequency. The Doppler, it's an ever-present issue. They, of course, as they're getting closer to you, they're shifting up. You're up in frequency. They're going away from you. It's going to be down in frequency. And what's the easiest way in today's world to handle such things? Software that will predict what these frequency offsets are going to be. So let's get into it. Okay, for example, this is a CubeSat. This is from AMSAT UK. It's the FunCube. Look at the physical size here of this satellite. It's roughly 6 inches square. At any one time, only half of its solar panels are going to be able to be in sunlight. So you can imagine how much power such a device can have. This would be its radiating antennas, and possibly it's producing about 5-watt output. Let's go take a look at some. The FunCube 3 was a double satellite. It's two cubes, 1, 2, 1, 2, and had a payload on board, including a camera and some other sensors. Now, here is an interesting issue of a launch of these CubeSats coming from the International Space Station. You can see the launch device up here. What you could do is you can load the satellite in to these various containers and pop the doors, and a little spring action can shoot them out. So we can get the thing launched away from the space station. And notice here in this picture, the satellites are still close enough that you can get a fairly good picture of them from the space station, and they're already tumbling and appearing to be in different orientations. So it doesn't take much to be able to get them out of whack, and the ground control team works to be able to stabilize it in whatever pointing position they would like to have. Usually it takes a few months to get that to start working correctly. Working with Earth's magnetic field, they can get the thing to rotate and spin into the orientation they want. Okay, so satellites in orbit. An awful lot of the time, what you'll see is a picture like this. Here's Earth, and here's a satellite, and a slightly elliptical sort of thing, and they say, look, satellite going around the Earth. Well, actually, let's look at the reality. Okay, in real size pictures, a low Earth orbit satellite really is more like this. The Earth is 8,000 miles in diameter, and the satellite is maybe 250 miles up. So it kind of looks like its orbit is more like this. It's quite close to us. The International Space Station, for example, is even closer than these satellites, whipping around the Earth fairly quickly. So you see, the satellite itself, even though it may have the ability to see from horizon to horizon, its horizon view is still limited to about this. So it can see a patch of the Earth about that large in diameter. That's what they call its footprint. That's what the satellite itself can see from horizon to horizon. So a signal like 440 would head off into space here and be lost. So you can really only work that satellite if you happen to be in the footprint. So the satellite itself on board has got antennas. They are not necessarily designed to be gain antennas. They are designed primarily to be omnidirectional because of the way that the satellite itself is spin stabilized in one axis pointing in one direction, and then it flies around the Earth so close to the Earth that it really can't always be pointing towards the Earth. So having gain on the satellite doesn't really help it very much. So instead, they're really sort of omnidirectional antennas. And of course, you try your best to make a perfect spherical omnidirectional performance, but there will always be some weakness compared to possibly some gain side. That can happen. And so, for example, when this satellite is in orbit and the gain is pointing at the Earth, everything is pretty good. But then the satellite will continue around its orbit, and over here, it's no longer got that gain section pointing at Earth. Instead, what you're getting towards Earth is is the slight decrease in performance from the antennas. So you see, the satellite itself, throughout its orbit, will change in signal strength. You really can't do much about it, and you can expect to see that happen. And at the same time, it, of course, is rotating like this in some rotation. So you may be able to see some fade from it as it's doing that as well. So the effect of other users. This can be important. There are 3 operational modes on satellites. FM, which I'm sure you've heard of, FM satellite, which is very similar to terrestrial FM repeater, and a transponder satellite, and we'll talk about that in a minute, and of course digital modes. So FM, what's going on in FM satellites is very much the same as what's going on at a repeater. What the repeater has is it has an FM detector. It will receive on a specific frequency an FM signal. It will amplify that signal, and it will retransmit it out on a different frequency. That's what a terrestrial repeater will do. Well, that's pretty much exactly the same thing that an FM satellite is going to do. It's going to receive FM signals only, and it really is looking at one particular frequency. So one particular input frequency and FM. Now, a transponder, on the other hand, is slightly different. What it does is it listens, it receives a swath of frequencies. It's just listening to a swath of frequencies. It's not using a simple FM detector. It's listening to a bandwidth of frequencies, amplifies that set of frequencies. It amplifies what it receives, and then retransmits it on a different frequency. That's what a transponder is doing. The width of that swath is wide enough to support multiple conversations. If you were going to do Morse code, for example, you could fit a great deal of Morse code signals. So many groups of people could be having a communication back and forth in Morse code or in sideband on a transponder satellite at the same time. That's a little different than the FM repeater, which could really only have one person talking with one other person at the same time, since they're sort of on one frequency only. Digital is similar to FM, although there may be more than one channel, and there's a variety of digital modes used. So you could uplink digital data to the satellite, and it could be immediately downlinked by someone else, or it could store and forward it. It could hold it for a while, just like sending an email to a mail server, and then someone somewhere else could download that email and receive it. So the satellites, you could upload here, and a half an hour later it'll be over Europe, and someone could download, and then they could upload theirs, and a half an hour later you can have it. That's the digital modes can do that. So other users using the satellite at the same time. On an FM satellite, it's very similar to a FM repeater. The loudest signal will be the one that wins. If 4 or 5 people try to communicate into the satellite at the same time, the strongest signal will be the one that will be, quote, captured by the FM detector. And now, you may have heard this on terrestrial repeaters where more than one person is trying to communicate on the repeater at the same time. Well, imagine that repeater had a coverage that was a workable coverage that covered all of the Western states at the same time. So you see, a lot of people will be trying to communicate to the satellite at the same moment, and they tend to be very busy, and the conversation then is really very short. All you really do is you put out your call sign and your grid square, and someone else replies with their call sign and grid square, and that's the contact, and that's it. You're off the satellite and wait for and let other people get a chance to use it. Digital, sort of like that as well. You uplink something quickly, and you leave the channel open for other people to uplink. Transponders, on the other hand, you can actually stay on the air because there's other places on the transponder for people to communicate. So more than one conversation can be happening at once on the transponder. So it's an opportunity to rag chew a little bit, talk with friends, and work the whole thing. You stay on the air and work the whole length of the pass on a transponder satellite. However, you do have to keep in mind something. Remember that the satellite is trying to faithfully reproduce the signal that it received in its receiver on its retransmission. So that would include the amplitude of the signal. So if you're talking with someone on a transponder satellite and then an additional conversation takes place on the transponder with someone else in a different part of the frequency of the transponder, then the overall power output to you from the satellite could be a little bit less, because some of that power is being taken by the other signals. So the result of this is that you're going to get variable signal strength from the satellite. It's going to take place at random times. It could be due to the satellite's antenna. It could be due to the usage that's taking place by other people on the satellite at the same time. And that's just the way it is. Okay, now, what's the first thing that would be useful for satellites work? Well, you need to know where they are. You need to know which one is overhead, and so that you can start determining what frequency to be on to try to listen to them. So the first step is probably to try to go ahead and get a hold of some software that will predict satellite location and frequency. So let's go take a look at one satellite program. We're going to look at SatPC32. It's I'll step away from the PowerPoint here again and open that program, and we'll take a look. Okay, this is SatPC32, and here we are in California. You can see my mouse, and at the moment there's nothing in the sky above us, but all of these circles that you see here are the footprints of various satellites. Let's look at it a little differently. Let's look at the 3D view over the Earth here. So this is where we stand right now. Here we are, and some of them are over the poles and they're coming our direction. So let's do a quick little preview. I'm going to predict forward in time here. Every step that I'm predicting forward is what? Every 2 minutes. So we're going to watch a movie here that updates every 2 minutes. Here we go. Okay, there they are flying around. There's more to play. Look at that one. There's plenty to play with. One more, one more, one more. They come by over us many, many times. About every 15 minutes or so, you get a little bit of empty time, but then there's always something happening. You're like, there's a number of things going to take place right there. Whole bunch of satellites at once. That's the way they are. You don't know what's going to be in the sky. You need to go take a look. So let's go back to our 2D map. And for example, we are looking. This is the coverage of. We're currently looking at RS-44, and that's what the blue ball is here. Let's see who comes next. Let's go back to our preview mode and see which one gets on top of us first here. Oh, okay, so look at that. I just happened to hit this one here, and you know what that is? That's the International Space Station. It's going to go overhead just about a half an hour from now. I'll tell you what, let's don't look at that one. Let's look at SO50. So let me get out of this mode here and turn on SO50. Find it here. Okay. So this is the SO50 footprint, and this is its frequencies. The downlink is on 440, so it's at 436, and you see that it's shifting. This is the predicting right now where the absolute shifting of frequency as this thing is coming and going. And this is the 2 meter frequency, the uplink, and that's the downlink frequency. currently, it's way far away from us. You can see the range down here. It's 12,000 kilometers away. So let's see what happens when it gets closer. Let's start our prediction. Okay, it's coming from the south, heading towards us. It's over the Pacific right now. And right about here, we're within its coverage. Right at this time, we're within its coverage. It's about 40 minutes from now. And you'll notice the footprint here allows us to be able to contact Hawaii on this satellite. In a minute or two, that was just 2 more minutes. Now we could communicate with anybody in all of California on that satellite, plus a little bit of Nevada. And here we are in just at this point here, just at the end of Hawaii. But the coverage of this particular pass is California, all of Oregon, all of Washington, all the way over into Montana. And we could communicate up in that point. Now, keep in mind something. This satellite is a CubeSat. It's probably 5-watt output. And its range at this point is 1,900 kilometers away. Surprisingly, that is still going to be quite useful. And you'll find that you can communicate with it quite well. Now, imagine that. This thing has got the same amount of power as a man standing with an HT. And he's probably got an antenna that really is omnidirectional as well. But the nature of space being so open and without atmosphere and things is that you can communicate with this satellite from that distance. I mean, you would probably be amazed and surprised if you were holding an HT in San Jose and you managed to communicate with someone in downtown San Francisco who was using his HT. But that would be an incredible leap. But you'll be able to work a satellite 1,900 kilometers away with almost the same kind of power. That's what I find fascinating about satellite work. Okay, let's go back to the PowerPoint here. Now, so we want to set up a station and we want to start working here. So what should we do first? Well, almost all of us have got an FM radio for 2 meter and 440. You're going to need 2 meters and 440. And if you want to work FM, then you can use an FM radio that's 2 meter and 440. And you could use the same radio for digital modes. So I would suggest the very first thing that you do is go to the AMSAT page, find the satellites, find what frequency they are on, and program your radio for those frequencies. Then get a satellite prediction program so that you can know when they're going to be in the sky and monitor those frequencies. And you'll be surprised what you're going to hear. Just with an HT and a relatively small antenna, it's very likely that you're going to hear quite well. A good set of headphones, of course, will help because these are going to be a little bit noisy conversations. Get yourself some software. I should say next step, I should say, how about we do that first? Now, gain antennas, well, it's always gain is better, of course. But of course, with a gain antenna requires that you find a way to point them correctly. There's no way around that. You have to be able to be pointing a gain antenna in the right direction. So if you're going to go for gain antennas, you're also going to need to create some methodology for pointing. Now, for the transponders, you would probably like to use single sideband, Morse code, or something like that. And that's where you need an all-mode radio. And 2 meter and 440 all-mode radios are not nearly as common in this world as FM radios. Almost all of us have got some form of FM 2 meter and 440. But an all-mode radio for the same frequencies is not so common. But that would be definitely worth having. Okay, let's say that you just want to use a handheld and you want to make contacts well. Now, these people here are making very good contacts. You can see that what they're doing is they're making a plan to point in the right direction. They've got an estimate of where they believe the satellite was going to be, and they're pointing some gain antenna in those directions. Now, it's not a lot of gain. For example, on 2 meters here, it's really a 3-element antenna here for 2 meters, which is not much gain. Quite honestly, that really is, it's got a pattern that's 45 degrees wide or so. So it's mostly just everything in this direction is on 2 meters. So he's really, as far as pointing accurately, it's just that it's important that he's pointing to the left side of himself than to the right side of himself. The particular antennas he's holding there are not so pointy that he has to be extremely accurate. Now, of course, there's always gain antennas, multiple elements and things like this on 440 and 2 meters. And in this kind of a gain, you probably want some kind of a rotator for azimuth and elevation. Even in this case, though, I'm going to say that you don't have to be that accurate. If you've got enough gain to be able to hear well, then you could still be off pointing from the satellite 10 or 15 degrees and you'll still hear it well. You won't, of course, you will not hear it if it's below the horizon. But up at the sky is open. And so you can do well. You don't have to be that accurate with your pointing. In fact, you may only just have to rotate your antennas around and not necessarily change them much in elevation, and you'd probably be okay. The real issue is, can you receive? Can you hear? Can you understand the conversation? And that's where good headphones come into play in a nice, quiet environment. And if you are attempting towards the satellites with gain and you find that it's fading and coming and going, don't start believing that that's a problem with your equipment. Just wait, because the fade may return. The satellite may come right back. It may not be you. It may be that the reason it faded away is because of the satellite itself, because of other users on the satellite, because of all those things we discussed. Okay, so a radio. What's the right thing to get started with? You'll notice that that they're 2 meters and 440. It's 435. It's in the range of 435. It's not in the actual repeater band section of 440 to 450. It's lower than that. So a lot of the time, the satellites are 440 as a downlength. So what you're doing is you're receiving at 435 and you're transmitting at 2 meters. So check your radio and see if that you can actually receive down in these lower frequencies. 1.2 gigahertz band is used on the satellites in a number of places for telemetry, which is fun to do, but you really don't need to have a 1.2 gig capability to be able to work the satellites. This is really what you need, 2 meters and 440, and let's look at it carefully, 2 meters and 435. Okay, so FM, of course, is the most common radio, and there were plenty of satellites that we could look at for both voice and digital using FM radios, and there's a lot of fun to be had at that location. Therefore, there's a lot of people out there doing it. So you can expect the satellites to be quite busy on that at FM. For all mode, using Morse code and sideband and things like this, well, maybe the first thing to do is to just work on all mode receive. Now, you'll be surprised at all mode receive. There's a lot of ways to do that other than radio. And of course, all mode for transmit and receive, well, there's also some other tricks. And I don't know how many of you are aware of this, but you can get a wideband, basically turn this into a complete all mode receiver, a USB dongle that can receive everything you need to receive from satellites, the whole 2-meter band, the whole 440 band. And these things can be in the range of $15 up to $50. And what you're doing here is you're using software. This is SDR, software-defined receive, software-defined radio. And of course, you can receive all modes with such a thing. Now, that will give you a chance to get an idea what's going on the transponder satellites. If you want to communicate, if you want to transmit on the transponder satellites, you need to have an all-mode radio. You should work with an all-mode radio. So there is a lot going on out there. Satellite operation is actually very busy. I think it's got a chance. It gives us all a look at the future, and that whole thing of space, the final frontier, and all of those things gives you a chance to play with what's really going on out there. I would say that it's very active. Internationally, it's very active. There's a lot of university involvement with a lot of far-reaching ideas. Putting together a station doesn't have to be that hard. You can start with your handheld and a good set of headphones and find out where the satellite is, what frequency to be on. It's not necessarily going to be simple, but it's not impossible. And listen and see what you hear. You might be surprised. Or then, of course, you can go for it and you can start working yourself into some gain antennas and then, of course, you will have to have the ability to point those antennas. You don't have to be extremely accurate, but you will have to point and aim for the stars. I hope to hear you on the air. Thank you very much.
That was a great presentation, John. Thanks so much for that. And I think, Rod, do we have some questions in the queue for John?
Sure do. Yeah, the first one's from Greg Wallace, and he's got a question for somebody starting out in this. What do you guys recommend as a website or further reading materials for information about working satellites as a beginner?
As a beginner, I would still say start immediately with the AMSAT web page. You can, if you look carefully at that page, first you can find what satellites are up there, what frequencies they're on. You can look at every single one of them. You can actually even look at predictions. There's even a sort of a live prediction program going on there telling you when the satellites are in the sky.
Oh, very good.
You don't have to get your own software, but you can also get software from that site, and I recommend that.
Okay. And a question from David Ranch, who says, why do ham sats use 2.4 and 10 gigahertz for supporting simple voice and even CW communications? Is it just to support more simultaneous QSOs because the sat supports a bigger bandwidth on its transponder?
The 2.4 gig and the 10 gig uplink and downlink is only being used for that geosynchronous satellite that was put up by AMSAT Deutschland. And that is so that you can create enough gain for that. The low Earth orbit satellites are 200 miles up and their ranges can be what they are. Geosynchronous is 26,000 miles up. That would be a geosynchronous height. So that's the purpose for the 2.4 gig and the 10 gig. It's so that you can make an easy gain, a lot of gain in your antennas.
Okay. And a question around, John, is it better for me to attempt and work a satellite on a low overhead pass or a high? Is there a preferable choice of antenna for each situation?
I would say that you actually do get a slight improvement. I don't know if you can call it ground wave or not, but when the satellites are closer to the horizon, they sound better. Directly overhead, they will go by fast. They will be out of your pointing position quickly. And at the horizon, it'll stay in location within your beam width of your antenna for a longer period of time. but also it just seems to work a little better off the ground. I think there's possibly a little bit of a ground wave that helps you out. So if you, for example, had some gain antennas and we're just going to only use one rotator that rotates in around in a circle, point the antennas up maybe 15 degrees, 20 degrees, and leave it there. And directly overhead, there might be a little bit of fade, but quite honestly, you're probably not going to notice it very much.
So what about for those people, again, just starting out, if you've got a fixed antenna mounted on the roof, are you going to hear anything at all?
Yes, absolutely. If you have an HT in your hand, you're going to be able to hear some things. So,
Okay.
So the key is to be monitoring the frequencies with a squelch wide open and listen along and see what you're going to get. And if you had a J-pole or something like that, which tends to have a slightly up bending pattern, circular pattern that stays sort of off of the ground and a little bit facing upward, that's a large improvement. And so if you had a 2 meter or a 440 J-pole on your roof, you'd be able to hear pretty well.
Okay. George has got a question about egg beaters.
Yeah, one of the antennas, John, that I've been interested in for a long time are the egg beater antennas, the kind that M Squared makes. And the thing that's attractive to me about that antenna is that I don't need a rotor. And I'm wondering if having an antenna like that would be adequate for working most of the satellites, or do you think that's not enough?
Okay, well, first of all, the point of the egg beater is that it's a circular polarity. Okay, and quite honestly, I'm going to say something a little bit scandalous. I'm going to say you don't need circular polarity. You're not, what I have found in my time and working with circular polarity antennas compared to just adding a few more elements on a Yagi and getting a little more gain, is that I say go for the gain. The circular polarity is not really going to decrease the fades and things that you will get from the satellites. And it's because of all of those other reasons about why the satellite itself will be changing in power output towards you. So, so quite honestly, circular polarity, I'm finding is not really all that helpful. So an egg beater antenna compared to, say, using like I said, a J-pole on the roof, the egg beaters, just a simple one like that, roughly has about the same gain as a J-pole. And so I would say just put up the J-pole and give it a try. If you really want to go completely all out for everything just right, then yes, you could go for switchable circular polarity and everything else and try to do everything you can to fill in the fades, but you're still going to feel that it fades. So I would say stay with simpler things, stay with simpler Yagis and see what you get.
Okay, that sounds like some great advice. Thanks so much. That was a great presentation. I think that's probably one of the best introductions I've seen to working satellites to cover all the bases in a very concise way. So thank you so much for putting it together and presenting today.
Well, thank you for your comments.
That's great. So at this point, we're going to shift gears over to the next drawing. So I'm going to hand it over to John and Marcel.
Sounds good. Thanks, George. Well, what time is it, John?
It's drawing time. And we're getting down to the end here. There's not a lot left, but we're very grateful. People are still buying tickets, and rest assured, if you purchase tickets in the last 10 minutes, your numbers are in the queue. So awesome. What are we drawing this time, Marcel?
Well, we've got 3 drawings coming up this round. I just want to remind people the silent auction bidding does close at 4 o'clock, as do any ticket sales for the rest of the drawings for the day. We're about halfway through the items in the opportunity drawing, so still a lot left and a couple bonus items we've added to the end of the presentations as well. Just visit bay-net.org/prizes on the URL here on your screen, and we'll have someone drop that in the chat as well. But yeah, let's do a quick 3 drawings here. The first one is a QRP Labs GPS receiver kit, $20 value, pretty neat little DIY kit that you can build up. And who's that one going to, John?
All right, and the number here is 2416. If you saw me looking down there, I had to re-update or update the upper number after the last round. So let's see here, 2416. 2416 goes to our good friend Barrick Dunn. 2416.
Nice. Congrats, Barrick. That should be a fun little receiver kit, and you can test it up against some of the Enritsu test gear and see how it performs. All right, we're doing our second RTL SDR dongle now, also donated by Ray KF6GPE. Thanks so much for supporting Baynet and donating this to the drawing. Who's this one going to, John?
This is going to 565.
One of our early registrants for the event.
Yes, yes. 565. We are Rodney Stafford, Stafford. Rodney, thank you very much. I think you're Rod, but you registered as Rodney, so thank you.
Thanks, Rod. Well, congratulations on getting the RTL SDR dongle. It's a nice little one. These are the ones that come in the metal case as well. I remember getting one of these in college a long time ago with the plastic case, and you wanted to do a couple mods to make them better. So pretty cool to see how these work out. We got one more here as well. This is the QRP Labs receiver module kit, high performance SDR with IQ output. And this one's going to who?
2269.
2269.
2269. Let me make 22. 2269 is me, so we're gonna do another drawing.
This is another rig drawing.
Yeah, it is. It is. Hey, I bought a few tickets. 800. That's an easy one to remember. 800. $800 is John Sutter, Sutter, John Sutter.
Awesome. Congratulations, John, on the QRP Labs receiver module kit. And just as a reminder, if someone does refuse the prize when we email them, we will be drawing again, and then you might get an email a couple days later. So do keep an eye on your inboxes for the mailing address that you registered with on the Eventbrite, and make sure to respond within 48 hours so we can get you your prizes. All right, John, what time is it now?
It's presentation time.
That's right. So we got another fun presentation coming up here. George, you want to tell us about it?
Sure thing. So the next presentation is by Dennis, W6DQ. Dennis is a good friend of mine that is a old-time radio collector and restorer. And one of the most interesting projects he's been involved with was the salvaging of a transmitter from the Voice of America Delano relay site some years ago. And this is really a fascinating project. It's not exactly ham radio, but it's pretty close to our heart. So over to Dennis.
Hello there. My name is Dennis Kidder. I'm W6DQ. I'm going to be sharing a story with you today about the recovery of one of the largest broadcast transmitters ever constructed by the Collins Radio Company. In November of last year, in an interview by George, KJ6VU, and Mike, VA3MW for Ham Radio Workbench with W6DQ, we started talking about this project of preserving this transmitter, this Collins transmitter, and how we went about getting that and extracting it from the Voice of America site and putting it on display at the Antique Wireless Association Museum. Well, we thought it would be a nice idea to provide some more information on that story, give it a little bit more detail, some of the background, and even share some photographs of the work we did for Baynet. So that's what we're doing here today. Now, a little bit about me. I was licensed in 1969 as a novice. I rapidly moved up to my advanced and eventually my extra, and was granted the call sign W6DQ of one of my Elmers from my high school days, which is, I'm so proud of. It's just wonderful that I was able to do that. I've always had an interest in Collins radio. You might see behind me, we're sitting in my ham shack here today. One of my Collins S lines, and one of the pieces of equipment in that S line, that 75 S3, I purchased in 1969, soon after I got my license. Still use it. It's a daily driver. We love Collins. So the Collins Collectors Association, of course, we're all about preserving and recording the history of Collins, and a group of us got together to perform this project. So we're going to talk a little bit more about that now, how that came about, and what the status of the transmitter is today, which is quite wonderful. So without further ado, I am going to move over to my slides. Here we go. So the Voice of America, of course, and we're specifically talking about Delano Relay DL8. That's the name of the transmitter. But I'm going to start out by giving you a little background on Voice of America, like what it is. Now, I'm sure many of you have heard, listened to, or know of the Voice of America. And of course, this is shortwave transmissions. I know as I was a kid, I used to listen to Voice of America, probably listening to Delano Relay, if none of the others. But this is the official U.S. federal government's external broadcast entity, meaning it's not for audiences here in the continental United States, but outside of the United States. So it's operated under the United States Agency for Global Media, USAGM, and it's one of 5 civilian U.S. international broadcasters. They provide programming on radio, television, as well as on the internet, and produce something like 1,800 hours weekly in 47 different languages. Their global weekly audience numbers more than 278 million people, and they maintain 19 major transmitting sites worldwide. Now, one of the facilities is still in existence and still operating. Of course, that is the currently the Edward R. Murrow transmitting facility in Greenville, North Carolina, but there's also another transmitting facility off the west coast of Africa, the island of Sao Tome, and they primarily do medium wave broadcasts to Central Africa from the coast there. But formerly, there were many other sites, including what was called Bethany Relay, which is located near Cincinnati, Ohio, and is now a museum, Voice of America Museum. Of course, Delano Relay, which is what we're talking about, which was located or is located in the town of Delano, or city of Delano, roughly halfway between Bakersfield and Fresno here in Central California along Highway 99. In fact, if you've driven up Highway 99 north of Bakersfield, you can't help but notice the huge antenna farm, which is several miles off to the west side of the highway. Lastly, there are the relays. There was Dixon, which is now gone, of course, and it was located near Sacramento, also in the Central Valley. There are also numerous other broadcast facilities, Hawaii, Okinawa, Liberia, Costa Rica, and Belize, to name a few of those. So in their history, VOA started on the shortwave during World War II. In fact, their transmissions, the first transmissions were called Voices from America. They were targeted towards Germany, and it went into operation on February 1st, 1942 as Stimmen aus Amerika, Voices from America. Now, over the years, they maintained a lot of shortwave broadcasting. And of course, as you know, shortwave broadcasters their numbers are dwindling. We don't see as much shortwave anymore these days. And it's the impact of technology, of course. That's what's done this. The proliferation primarily of the internet. But the Voice of America still does, as I mentioned earlier, does maintain broadcast services that are still remaining for Africa. But their medium wave and shortwave broadcasting facilities are no more. They've gone over to the internet, as I mentioned. So their internet services, believe it or not, Voice of America was the first broadcast news organization on the internet in 1994. So they have that distinction. Still, today they broadcast, as I mentioned earlier, in English and 46 additional languages. And as resources, they maintain 20,000 servers in 71 countries. Quite an infrastructure. So Voice of America Delano, one of the last relay facilities. This is a relay transmitting site. And its history began in the May of 1944. They broke ground on the facility. And believe it or not, by November of 1944, the first rhombic was on the air, up in the air, 170 feet, and they were on the air. This was the first of the 3 relay sites that they built, the others being Bethany and Dixon, as I mentioned earlier. They also established a receive site a little ways up the road in the town of Pixley. Now, the reason for the receive site, this wasn't their primary method of moving program material from the studios in Washington, D.C. out to the transmitting facilities. They mainly relied on the Bell System's landline facilities of the time. Well, they were concerned about the reliability and the availability of the Bell System. Should they go down, they still wanted to be able to get their program material. So they established this receive site. Believe it or not, in their entire history, they never had to use those receivers other than for testing. They did regular testing. The Bell System, the landlines stayed up. They were always available, and they had a great history with the Bell System. Well, sadly, on October 27th, 2007, at 8:30 p.m., their last transmission took place. It was a scheduled program on 5890 kilohertz in Thai. Station shut down. No special observance was made for 63 years of service. It just shut down, turned everything off, dropped what they were doing, and walked away. So starting in 1944, I've got a couple of pictures of the early construction and some photographs of their facility there from the old days, but this is one of the 200-foot towers that support a dipole curtain array. It's one of the arrays you can see from the highway. There's 3 towers that support it. And you can see one of the footings being constructed there, one of the towers under construction, also on the right-hand side there. In the early days, their transmitter lineup consisted of a 200 kilowatt Federal transmitter, one of those guys, 3 50 kilowatt RCA transmitters, and eventually they had 2 General Electric 100 kilowatt transmitters. Those went away to be replaced by the 3 Collins 821A1 250 kilowatt transmitter, like we're talking about today. And there were 4 Brown Bovary SK53 250 kilowatt transmitters. Those are now on the air in the Philippines. They were sold to another broadcast entity who currently has them operating out there. And in addition, there were 2 Continental 50 kilowatt single sideband transmitters that were located at the site. So in the early days, these are some early photographs. These are the upper photographs of the control room. And the control room on the right shows transcription turntables. So the material would have been transmitted from Washington, D.C. studios out to this site, recorded on a transcription disc, and then played back for retransmission to the remote sites through that. And of course, eventually the transcription turntables were replaced by reel-to-reel tape decks, and you see a set of Ampex tape decks there that they used. On the bottom is a photograph of the portion of the facility. You can see those 3 towers in the background. Those are the 3 that were being constructed in the earlier photographs, and of course the building itself as it looked in those days from the front, from the east side. Well, in 1964, the building was expanded, and this was with the Voice of America contracting with Collins Radio Company to build these 821A1s. They built 9 of them for the Voice of America. 3 were located at each of the relay stations. Well, they had to make room for that, of course. So they built an extension on to the east side of the building, and you see the 2 stories there. The bottom floor is where the transmitters are located, the 3 821A1s, as well as the 2 Continentals. And that second story is for the cooling equipment for those transmitters. As you might imagine, 3 250 kilowatt transmitters, as well as 2 50 kilowatt transmitters, produced a lot of waste heat. So we had to get rid of that. So that's what the second floor housed. Well, let's talk a bit about where we got started with this thing, following the Delano shutdown. The Voice of America transferred the facilities to the GSA. Now, in the case of Delano, the GSA is looking for a new owner for the property. There's some 800 acres with a bunch of structures on it. They're trying to find a buyer. They're looking for either a private buyer or a government buyer. Well, they weren't having much luck with that. Dixon had already been sold. As it turns out, the Delano site, it was discovered by the California Department of Fish and Game that an endangered species of shrew has taken up residence on that property, and therefore they were forbidden to demolish the facility. How do you like that? So Delano still stands. Although there's a lot of it's been gutted, the facilities are still there, all the towers are still there. They can't do anything until that gets settled. I'm not sure what they'll do with it, but Delano was looking to use it for a regional airport or expand their prison that's located in town there. They thought about using it as a homeless shelter. Well, like I said, Dixon sold. It was sold to a farmer up there in the Dixon area, and Bethany, of course, is now the Voice of America Museum there near Cincinnati. Well, two members of the Collins Collectors Association, Bill Carnes, N70TQ, and Jim Stitzinger, WA3CEX, came up with this idea. Why not try and preserve one of these transmitters? Get it into a museum somewhere, rather than letting it end up in a landfill bulldozed to the ground as scrap metal. So the Collins Collectors Association embarks on this project to seek to obtain one of the 821A1 transmitters. So working with the GSA, this is how they found out that it had been transferred from the VOA to the GSA. We figured that it would be good, maybe display at the Antique Wireless Association and or the Collins Museum in Cedar Rapids. Well, Antique Wireless Association was right on board with us. They were very excited about being able to obtain one of these transmitters for display. So they were right in the middle of this with us. So GSA eventually agreed, but they levied some conditions. And oh, what conditions they were. First, we had to have the transmitter off the site within 2 weeks after starting. And oh, by the way, you need to have it on display within 18 months. Okay, well, we had our timetable. So let's talk a little bit about the transmitter. This is quite a piece of hardware. Of course, you're all familiar, I hope, with Collins Radio. They're now part of United Technologies. And this little transmitter here, the mighty Collins 821A1, was a 250 kilowatt auto-tuned shortwave transmitter. This is important to note. Why is auto-tune important? Well, let's talk about this a bit. This transmitter was able to tune between 3.95 and 26.5 kilocycles, retune to full output on any frequency within 20 seconds. Why? Consider the time. This is the mid-60s. We're in the midst of the Cold War. We're waging a propaganda war with the behind the Iron Curtain, the Soviet Union and their allies. The Soviet Union is actively jamming transmissions. Well, if you look at a conventional transmitter, such as those that might be used for jamming, it takes some time to retune one of those when you change frequency. 10 to 25 minutes, normally it could take an hour or more to retune a transmitter to a new frequency to be able to jam this shortwave broadcast. So having a transmitter that could tune up in 20 seconds instead of an hour is quite an accomplishment and gives you that much more airtime to get your program material out to the remote sites before you're jammed. So you can understand the reason that the Voice of America wanted this equipment, and Collins was able to provide that. These guys averaged, from looking at their logbooks, about 4 frequency changes per day per transmitter. So 3 transmitters, 4 changes a day, per transmitter, 12 changes. So moving around quite a bit during the day. I mentioned this before. This was the most powerful transmitter ever offered by Collins Radio as a shortwave broadcast transmitter, the 821A1. They were working on a higher power model, but they never finished that project. Well, let's go back to May of 2014. This is when we began our project. Our team arrived at the Delano site, consisting of some folks I mentioned before, Bill Carnes and 70TQ, Jim Stitzinger, WA3CEX, with his assistant, his employee that works for him, Tim. Vince Maker from the Voice of America, who is an invaluable asset to us throughout the course of this whole project. Vince really helped us, and we were so happy to have him on site. Of course, that was a requirement of the Voice of America to have Vince there. Vince was there daily, whether we were there or not. Vince was still working for the Voice of America as kind of a caretaker at the facility. We also had Ron Bloxham, Rod blocks, I'm sorry, N0DAS. Now, Rod was one of the principal designers of the HF80 system and drew a lot of its design from this transmitter, this 821A1, done in the 60s. Also on the team is Scott Kerr, who was the president of the Collins Collectors Association at the time, KE1RR. We had another member of Collins Collectors Association, Brian Garrick, KE6IYC, as well as Dave Jennings, WJ6W. And some of you may recognize that call sign. Dave is a well-known amateur AM user here on the West Coast and operates often all the time on 75 meters AM, a beautiful signal out of the San Fernando Valley here in Southern California. And of course, yours truly, W6DQ. And so begins the relocation of Delano DL8. Now, if you've ever been to the Delano site, I'm sure some of you have probably visited the site. You might recognize this next photograph. This is as you come in the main entrance, this is the first gallery. You can see those two Continentals there on the left-hand side. And behind the wall, behind those Continentals are the three Collins transmitters. As you go through the door, this is what you might see. This is DL8 in the flesh. That's it. This is essentially the control console for the transmitter, as well as the drivers and all the tuning controls and everything located right there. Now, at the other end, far end of that hall, is the control room. And this is where you have remote control of all the audio and transmitting facilities there. So we relocated all of this equipment as well. Nothing was left behind. This was all part of what went to the AWA. So as we go back to the transmitter, this is kind of a shot showing an image showing the front of the transmitter, which you saw in the earlier photograph. And it also shows the cage behind it where the actual transmitter is housed, the PA, the modulator, and things like that. And this extends some 60 feet behind that front row of racks to the power supply, which is an entire room. So let's take a little bit closer look at some of these things here. We walk around the corner. This is actually the output matching network, part of it. And this converts the coaxial feed from the PA into a balanced feed out to the antenna farm, the switching yard. So looking up in the air, we can see what look like two airlines or maybe a steam pipes or something. Those are actually two pieces of coax that form the balanced line through shields there. You see it go up and over the top. They're about, what, maybe 6 or 8 inches in diameter, and they drop down into what looks like a piece of air conditioning duct. That air conditioning duct is actually the housing and shielding for that balanced line that runs out to the antenna farm, the switch yard, and the antennas. So it's protecting the personnel because it runs through the building where there'd be a lot of people, offices, and things like that. So we walk a little bit farther and we see inside this transmitter cage that you saw earlier, this is actually the PA housing. This houses the two final transmitting tubes. They're a IMAC 3CV 100,000C transmitting tube. They're tetrodes. They are what are called vapor phase cool, and I'll show you a little bit more about that in a minute. But that's the actual transmitter, the housing for the transmitter. If we walk around the corner to the left, we'll see the modulator. Two more of those 4CV 100,000Cs, the vapor phase cooled tube, they're located in this modulator. Now the two in the modulator run in push-pull, while the two in the PA run as parallel. And here's a little close-up shot of that tube. This thing weighs about 95 pounds. It's a very heavyweight tube. Now it's not water-cooled. It's actually what they call vapor-cooled. It's cooled by steam. It sits in a tub of water. The water boils off as steam. The steam is carried away to a condenser that's located up in that second floor, and it returns as water back to the cooling tub to be recycled. The continuous cycle there. So you can see the corrosion. You know, this thing's been sitting in water. It's been sitting there since 2007 was the last time this thing was fired up. So there's a bit of corrosion on there. So I mentioned Vince Baker before as being such an asset to us. We are disassembling this equipment and trying to figure out how to get those tubes out of the tubs, we see there's a rail overhead, but we don't see any way to extract the tube. It's bolted in. We remove the screws that hold it down, remove all of that. We remove the socket, which you see behind the tube there. Pardon me. But we don't see any way to extract the tube. There's a socket on the top of the tube that some kind of a locking fixture goes into that you can remove it. Well, we pull out the manuals, which we happen to have, and we're looking through there. It talks about the maintenance instructions and things like that. And we see this picture of this little winch assembly. And we're talking to Vince, and we don't see this around anywhere. Vince says, hey, that looks familiar. I've seen those around here somewhere. I think I know where those are. Vince runs off. A little while later, he comes back with a whole bunch of these winches that were located out in a storage building out on the other side of the property. So it really made it easy to remove those tubes. Thankfully, we had to pull out the 4. We pulled out all the tubes actually from all of the transmitters, and they were sent off to the museum. They're on display along with their maintenance cart and a few other things that went along. But a nice story. We're really grateful for Vince being there. Without him, we probably never would have gotten those tubes out. So here we are wheeling that modulator off to the staging area to be packed up and shipped. There's Rod and Scott trying to manhandle that thing out of the cage there. This is the actual PA itself. We've removed the racks across the front that you saw earlier, and what's left here is the PA cabinet. Now the tubes and the cast aluminum tub that they sit in, that's part of the cooling system, those are all removed. What remains are the filament supply and the screen supply, as well as the output matching section, which is the thing going up vertically in the background there. We'll get to in a second. This is quite a machine. So I mentioned the matching section. This is, on the left-hand side, is the output of the PA cabinet. And it goes into this, what is called a pie line section. Pie line section is an interesting creation by Warren Breeny, who was the principal engineer on this system, the design of the 821A1. He came up with a concept for tuning the output of this transmitter by what he calls this pie line section. It's basically a section of coax that periodically uses a variable capacitor between the center conductor and the shield to tune that coax to the resonant frequency and perform the impedance matching. Well, when you look at this picture, your first impression might be that piece of copper pipe is the center conductor, but it wouldn't have a choke in the middle of it like that. That's actually the high voltage feed to the PA coming in from the high voltage power supply. The center conductor to the coax is actually that box that the cover's off of, that the copper pipe is inside of. That's the center conductor of the coax. And that's probably about 18 inches square, maybe something like that is how big that is. It's a pretty good sized box. The shield is the outer enclosure. And if you look in the right-hand photograph, you see those 4 disc things there. Those are actually vacuum variables that are used to tune that section of coax in the pie line section. And there's a number of those located throughout this enclosure, and they're all servo controlled. They're all controlled by remote control to tune the transmitter. So next photograph shows a little bit more overall of what this thing looks like as we get a better view of it. You can see in the center is where that PA cabinet was located. We've removed that. You can see how it goes up in the air. The coax goes over the top. You can see the shield. The center conductor's been removed up there, and it comes down on the left-hand side into the enclosure that I showed earlier, the output section. And you can see some of the covers are off. I'll give you some close-ups of that in a moment and talk about that a little bit. So this is on the left-hand side. This is actually a balun. This is where you go from the coax feed from that pie line section to the balanced feed going out to the switch yard and the antenna farm. And basically what it does is it takes 2 pieces of coax. You saw the 2 pieces of coax going out the top of that matching unit. Well, the single coax coming in is split, and one section goes directly up with its own matching network. The other section goes through a phase inverter, and the phase inverter is so clever. I was just amazed looking at this. you can see the phase inverter, which is located right here. And what it does is it takes the input coax, takes the center conductor, and connects it to the shield of the outgoing coax. And the shield of this incoming coax is connected to the center conductor of the outgoing coax. So it basically does a 180-degree phase reversal, so you get a balanced feed from this. So in a sense, this is a balance. On the right-hand side, Rod is grinning up on the ladder, is holding a section of that shielding, the duct that looks like the air conditioning duct, that was holding the balanced feed line going out to the outside. One of the interesting things we discovered as we pulled this ducting down, you guys are going to be familiar with this, a W2AU balun. Now, I've used those since I was first licensed. My first dipole had a W2AU balun back in 1969. Well, there's a W2AU balun hooked up to the balanced feed line in here. And we're looking at that. It's got a couple of high megohm resistors tying it into the balanced feed, and it's extracting that out to a piece of RG58 that goes off to the control room. And the best we could figure, that was probably their modulation monitor. They were watching the waveforms on the output and monitoring their modulation levels to see that they had a good, clean waveform. Very clever use of a W2AU balun. I really loved that. That was cool. So I mentioned the servos on those vacuum variables. Here's another view as we extract those assemblies out of the tuning section. What you see here are the vacuum variables down on the bottom, and then you see all the mechanism up on the top, including the servo motors. These are the servo motors right here, these two units. And of course, the drive mechanisms, the chain drives, and the drive screws for the vacuum variables located down here. Now, all these hoses, you might wonder what those are. Well, believe it or not, these are water-cooled variable capacitors, water-cooled. And they ran chilled water through these capacitors to keep them from overheating and failing. Now, we're talking about high power. We're really talking about some high power. You know, you think about it, 250 kilowatts, that's your carrier. With 100% modulation, your output actually is 4 times that, or 1 megawatt. That's what this thing puts out on peak power, 1 megawatt. That's a lot of soup. And accidents are bound to happen. As we were walking around and looking at the feed up there, that matching section overhead, we spotted this. And I say that's a little bit of slag. What you see there is where one of the fixed capacitors, it was still a vacuum capacitor, it's a fixed capacitor, was bolted to the shield, which is the piece of metal you're looking at, and the center conductor. And at some time or another, there was a major arc over, and you can see it created a bit of slag there. This is actually on the inside. We first spotted it on the outside. You can see this bubble of aluminum sticking out of the enclosure. Well, a little later, we were going through the logbooks, and we found an entry in the logbook that says, attempted to tune transmitter on 20-something megacycles. And over in the notes, the engineer had written, don't ever do that again. We have to believe that this was the result of that. But whether that's really what happened or not, this is just an amazing display of how much power we're talking about here. While we're speaking about high power and high voltage, this is something we saw quite frequently, and with good reason. You know, this thing's running at 15,000 volts, 15 kilovolts. A lot of soup. I mentioned that. So you definitely have, there are chicken sticks everywhere to ground this baby. Well, speaking about power, how about a power supply that you could actually walk inside of? Wow. What you see there from left to right, on the left-hand side is the plate supply, transformers and rectifiers. In the center is the modulator supply and modulation transformer and modulation reactor. And off on the right, those are the filter capacitors for the PA plate supply. So looking at it from a little bit different angle, looking at the plate, and the modulator, you see in a row there, there's the filter capacitors for the modulator. Next are the rectifiers, 3-phase rectifier bank, the modulator power transformer, the modulation transformer, and then a modulator reactor. That is the modulator side. On the PA side, What you see here is the high voltage transformer. It's a 3-phase transformer supplying PA voltage to a 3-phase rectifier that's immersed in oil, 148 gallons of oil to be exact. And off to the left is a general purpose utility transformer that takes the 5160 volts AC on the input 3-phase and gives us 220 or probably 208 3-phase and 115 utility for other systems here. So this is big stuff. That one plate transformer weighs 5,000 pounds. 5,000 pounds. Yikes. So moving outside the building, this is the feed lines going out to on the way out to the switch yard. And what you see here, there's that air conditioning duct right there, up there in the upper right. And here's the balanced feed lines coming out. There you can see the vents from the cooling area. These are where the cooling fans and condensers are located. So there's the three outputs of the 821A1s. Then these two here, one here and one here, those are coax coming from the 50 kilowatt Continentals. And of course, to convert that coaxial output over to a balanced feed, there's another ballon. That ballon looks about the size of a pole pig that you see on the power line outside your house from the utility company. That's a big ballon, 50 kilowatts. It's a biggie. So this is the feed. Now, continuing on, if we follow the feed lines, they go to the first switch yard. And here is the first switch yard. And in the background, you can see one of the towers from that curtain array I showed before, the dipole curtain array. And there's 2 towers that support another dipole curtain array. And there's also feeds going off to the right that feed one of the fields of the rhombics. And let's see, what have I got next here? The next picture is of that 3-bay curtain array, or 3-section. Each section has a number of bays within it. That is that was one of the first arrays that was put up at the site back there in the 40s. You saw the pictures of being erected, the tower put up, and the footings being poured. So this is kind of an overall view looking at that. And in the background of that shot, that image, is one of the newer antenna arrays. Those towers are 400 feet tall, the tallest ones. And then the 3 others are 200 feet tall, the same height as these 3 guys here. I got a little close-up of the feed going up that curtain array. You can see some elements. These are the dipole elements here. And you can see they're kind of like fanned out, and that's kind of like a cage dipole to help make it more broadband. And of course, the dipole array consists of it's a matrix of dipole elements, both horizontal and vertical, that you can switch in and out to change the operating frequency and tune the antenna. That is the whole purpose. You can change the phasing between the bays to steer the array as well. So that's a little bit of the feed. This next photograph is that later antenna was put up. The two antennas. This is a shortwave array, the shorter towers at 200 feet, and this is a medium wave array, broadcast, kind of like broadcast frequencies, the 400-foot towers. So these are big towers, huge. I've got some pictures of the switch yard, some pieces of the switch yard, some of the phasing lines, give you an idea of what some of this stuff looks like. And this is feeding up into this dipole curtain array that we were looking at. These are the 400-foot tall towers. So the switches, here's a close-up, sort of close-up of the switches. These are pneumatically operated switches. And you can see the feed lines here. This is a copper pipe. And there's 3 switches. There's one here, one here, one over here. And again, some of the phasing lines, what have you. Quite a complicated system. Now, just to put this tower in scale, 400-foot tower, that's a big tower. I like this next photograph. Here's Rod, N0DAS, standing next to one of the equalizers for those towers. That is huge. That's big hardware. You know, we're used to, my towers here, you know, mine have a turnbuckle so big, you know, 8 inches, 10 inches long. Those things are huge. Those guys are like 2 inches in diameter. That's massive hardware. Well, we finished our tour of the antenna farm. And that was quite exciting. I mean, there's some interesting stuff to see out there. And we headed back to the hall. And of course, we went back to the hall. What do we find back there? Everything's gone. We'd cleaned the place up. That transmitter is gone. We moved it out to a staging area out in another part of the building. We palletized and shrink wrapped everything. And the next step was load out. Here's Jim Stitzinger with his forklift, loading a set of racks into an 18-wheeler. And we hauled all this gear off to Bloomfield, New York, to the Antique Wireless Association Museum. There it is, all packed up, ready to go. And I have to share a photo of our team. Here's the remaining team after we got everything out. We've got Vince Baker there on the left from Voice of America, Rod Bloxham next, myself, W60Q, Dave Jennings, Jim Stitchinger holding a roll of engineering drawings of the transmitter, and his assistant, Tim. So we just had, this was quite an exciting project. Kind of a once-in-a-lifetime thing to be able to go and take this transmitter apart. But there is an ending to the story, of course. We talked about the AWA. Well, DL8 has a new home. DL8's home is in Bloomfield, New York, at the Antique Wireless Museum. And here you see the display they've put together, which is just a beautiful display. You see the control console there on the left, and you see the modulator and the transmitter control panel there on the right, and a scale model of one of the antenna arrays. So what a wonderful thing the AWA did, and has prominently displayed this transmitter, and it's preserved there for everyone to see and hear the story of the Voice of America. So with that, we're going to move on to the questions and answers, Q&A. There's kind of an overall shot, late afternoon of the site. And we will now terminate this slideshow and move on to Q&A. Thanks very much, guys. Really appreciate this. I hope you all enjoyed the talk here, and look forward to the questions.
That's awesome, Dennis. Thank you so much for that. And Dennis has perfect timing. He just joined us online. So I want to welcome Dennis, you to the event today. Thank you so much for doing the presentation. Great to see you.
Please hold while he connects his audio.
As we're getting the audio set up.
Yeah, Dennis's audio is just connecting. I was just curious there. That's an awful lot of cable to deal with. Man, oh man. The cleanup must have been as severe as the deinstallation.
Hey, Dennis. You get your audio muted?
There we go. Yeah, I had it muted. We'll take
awesome.
care of that.
So
Yeah.
I have thank you so much for doing that. This is a fascinating talk. I have one question, then I'll hand it over to Rod. But
Okay.
I was trying to figure out, how did you guys manage to disassemble that and haul it out in just those couple of weeks? It's just, when you see that, all that heavy gear bolted in place, it just seems like it sounds great before you get there. And when you walked in, is probably like, oh man, what are we getting ourselves into?
What have we signed up for? Yeah, it's just a lot of little pieces all bolted together. If you think about it, a bunch of 19-inch racks. They're in a row. We had to separate all that stuff out. Everything stayed in the racks, but they were taken out in modules. So there'd be like 3 bays in a rack. And everything, like the transmitter itself, was just a bunch of aluminum panels that were in a framework that looked like unistrut. And so you just unscrew stuff and it all came apart. It was like a big jigsaw puzzle. And we made very careful notes, marked every part as we pulled it apart, so that when it went back to the museum, they could just put it all back together again the way we took it apart. So yeah, I got a couple of things. I do have a couple of things here that I wanted to share with you guys. I didn't get them in the video, but talking about power supplies, you'll love this. There's a rectifier stack out of the power supply, one of the power supplies.
Oh, wow.
That's one phase out of the it's a 3-phase system. So there were, I don't know, there'd probably be what, like there's 6 of these in each of the power supplies. And this is the one from the modulator. So those were the ones that were sitting out in air cooled. The other ones are oil cooled in the PA. I have another artifact that I want to share. This one's really special.
Ah, looks like, is that like the
This is
current voltage meters?
This is one of the control panels for one of the transmitters. This particular one came from Dixon, but this is actually where this is part of three other panels that are used to actually control the transmitter. And one of the things that's really significant, this is a directional watt meter. And if you look at the scale on here, 500 kilowatts. Yeah.
As you do. Yeah.
Yeah, I like that. But one of the cool stories we heard about VOA is that there was a guy going on a tour up there and he's looking at that watt meter and it says 15 kilowatts. And he's going, well, that's not very much power. And they go, well, that's the reflected power. But I love this. Plate voltage, 20 kilovolts, plate current, 30 amps.
Wow.
Yeah, we're talking some big power. So yeah, it was a lot of fun. It was a lot of fun to work.
So by the way, you'd mentioned Dixon before.
Oh.
So what's the difference between the Delano site and the Dixon site?
Well, they were basically copies of each other, and Bethany as well. All three were the three relay sites. There were three of these Collins transmitters at each location. And they were used to feed off to the remote broadcast facilities wherever they happened to be at the time. This one fed out into the Pacific. And I think Dixon fed out into the Pacific as well. So, yeah.
That's amazing. And the other transmitters, so you got one. There were still two more just like that, plus the 250 kWs. What happened to those?
Okay, so the other two transmitters are still at Delano. We were able to remove some parts from them. We were allowed to cannibalize some of the pieces. The ones from Dixon, they're all gone. I don't really know what happened to them. They probably ended up, well, I know that a lot of parts were removed. Dixon shut down before Delano. And a lot of parts were removed from Dixon and shipped down to Delano as spares. And we found a couple of storerooms full of all kinds of spare parts. That could be a story all in and of itself. Going through the facility and the stuff that we found there, parts and what have you. Of course, the 4 brown bovaries, those are gone. Those were sent out to the Philippines. The other remaining transmitters, the 2 General Electrics, well, the Federals and the RCAs were removed years ago before the brown bovaries went in. The General Electric transmitters were in 2 wings. Those were removed years ago. One wing then became their satellite facility. That's where all the ground equipment is for their satellite hookup. Was in one where one of the GEs was. The other GE was in another wing, and that became a conference room, and that's where their ham radio club was, which is kind of neat. The Continentals are still there, but we were able to remove some parts from the Continentals. So the 50 kilowatt sideband rigs, those were.
So were you able to make any special arrangements to get on the property during field day by any chance and use the antenna?
Oh, that would have been a blast. What we wanted to do was have a special event station while we were there, and Jim Stitzinger brought along a KWM 380, and we were just going to patch that into one of the curtain arrays. But because of the vandalism, there was actually some vandalism that went on while we were there. Somebody broke into the property overnight and cut a bunch of the copper tubing out of the phasing array for that one curtain array, which was the one we were planning on using. So it made it somewhat unusable. Oh man!
Oh wow! So Rod, do you have some questions in the?
Yeah, actually, partially answered. One of them is the question about are the antennas still up, and of course, with no feed lines, that's going to be a little tough. Yeah. But the other question was, did you feel more like a historian trying to archive this? Because I'm thinking, yeah, you can get stuff apart, but it might be 20 years before somebody tries to realistically put this back together.
And
or 50.
It's all back together. You know, they now it's not operable, obviously, but you saw the photograph from the AWA's museum. It was back together within a year. They had it back and had it up and running. And I like to, I didn't talk about this because, we were limited for time. I like to refer to what a lot of what we were doing is radio archaeology. While we were, on our off time, we'd be wandering around through the buildings there and looking at stuff. And one of the things we found was a box of QSL, or not QSL cards. Well, we found some QSL cards, but we found a box of reception reports that had never been answered. And we also found a box of QSLs. So those reception reports were from like 2007 and earlier, you know, when they shut down. We packed that stuff up and we sent it to AWA, and they were going to send out QSL cards on behalf of those, the Voice of America, for those reception reports. So a little bit of archaeology, but I swear, literally, it looked like when they shut the thing down, people just dropped what they're doing and walked out the door. Quite literally, it was really something to see.
What a great experience!
What a fantastic place.
Okay.
Bittersweet as well.
I bet.
So, Raj, you got any more questions there?
Oh,
No, I think we're.
Hang on a second. I'm losing my audio here.
So, Dennis, before we wrap up, do you have any other radio archaeological projects on your agenda for 21?
Oh boy. Oh, a bunch of radios that I'm restoring and rebuilding here. There's a couple of old Collins radios that I got to get back on the air. There's a KW1 in the back and a 30K4, which are this gear from the 50s, Collins gear. And
so sometime we'll have to get a tour of the museum.
Well, we can do that after the shack is finished. You know, we're in our radio shack, and you know, you saw her sitting here next to me. Lisa's here with me too. You've met Lisa before, George.
Hi, Lisa.
And she was one of your drawing winners. How about that? We heard her name come up.
Oh, excellent.
Yeah. So she's a lucky winner today. But yeah, we're still working on the ham shack here. This is a 1,500 square foot structure that's about half completed. So I've got 1,500 square feet of radio equipment in half that space right now. So it's like,
you realize that 1,500 square feet is a nice size house here in the Bay Area. So
yeah,
we're kind of all very jealous.
It's almost as big as our house here.
Well, I want to thank you so much for taking the time to make the presentation and join us for a little Q&A. And we have to figure out a way to dive a little bit deeper into some more Collins history and technology and lore. Since I restored my 75A4 this last year, I've kind of gotten bit by that. So you're way ahead of me. You've got about 100 times more gear than I do, but
yeah,
we'll have to follow up.
Well, I remember we were talking on Workbench about the 75A4s, you know, and the year 75A4 that you're restoring. And it's like, yeah, good stuff.
Yeah, exactly.
Yeah.
All right. Well, thanks so much. Good to see you. Good to see you, Lisa. 73. And we'll go ahead and move on to the next segment.
Here you go. 73 to y'all. And thanks to everybody for joining us. And thank you guys for hosting this. You're doing a great job. This is awesome.
Oh, thank you so much for being part of it. Appreciate it. Well, Marcel and John, let me punt it over to you guys for another drawing.
Marcel, let's change it up. Marcel, what time is it?
John, it's drawing time. Thanks for asking. Remember, this event is a fundraiser for BayNet. We've been doing really well, lots of great ticket sales, and the silent auction has been going pretty crazy too. So remember, we will be closing out ticket sales and the auction bidding at 4 p.m. Pacific. That's in about 45 minutes. So please make sure that you get those bids in before 4 o'clock Pacific in 45 minutes if you want to make sure that you're getting in for the final drawing at the end of the day. So we're going to do three quick drawing items right now. We'll do the first one here. Prize number 25, Seed Studio Arduino Relay Shield Boards. There are 4 of them in this prize drawing together. John, who do we have?
We have number 14. Wow.
You can put that one back in if that's me.
I think that's probably you, Marcel. Number 14 is, a guy named Marcel. Okay, so we'll go again.
Put that one back in the hat. Let's see who else we can get.
Yeah. This won't be you, 2340, but it kind of, I think mine were in that range too. So let's see here, 23, yeah. Okay, so let's go. That was me. So let's go.
It's not rigged, guys.
It's not. 2271.
You guys bought a lot of tickets.
We did. We love this club. George, have I ever told you the merits of this club and how beneficial it is to support it? Let's see, 2271. Oh, that was really close to me. I just, wrong one. Hang on, 2270. Yeah, Frank Dries again. Frank Dries, something like that. He won earlier as well. Dries.
Cool. Congratulations, Frank. You'll get the Seed Studio Arduino Relay Shield boards. We've got another one now. This is a Hustler 440 mobile collinear antenna. It's a 3/8 wave on a quarter 20 antenna mount, donated by Mike K6QFO as well. Nice little antenna. Who's that one going to?
It's going to magic number. Ooh, that's hard to read on the screen. 418. Sorry, guys, as the day gets longer, my thumbs get slower. 418 is 418. David Goldenberg, Goldenberg.
Awesome. Congrats, David. And we have one more now, the DIY antenna grab bag mystery box. This is again a box of assorted Pactenna parts and HF wire antenna parts. Pretty fun. Who's this one going to, John?
Yeah, good stuff. I've actually looked in these boxes, and this is the antenna boxes are exceptionally 3624. 3624. $36.24 goes to Randy Neals, Neals, Randy Neals.
Another one of our big ticket buyers. So thanks very much, Randy. I think that's your second win for today as well. So congratulations to everyone this round. Remember, silent auction bidding and ticket sales for the final drawing end at 4 o'clock Pacific. That's in about 43 minutes or 41 minutes or so. So make sure that you're finishing that up. And we'll be reaching out to you for your prizes once you win.
Thanks,
right,
everybody.
Thanks, John. Thanks, Marcel. So we're in the final stretch here. We have 2 more presentations to go. The next one up is Mark KR6ZY, and he's going to talk about building a slot antenna for HF. Go ahead, Mark.
Hello, Mark Smith here, also known as Smitty Halibut, KR6ZY, although soon to be N6MTS. We'll talk about that in a second. I am here happy to present at the BayCon 2021 event on February 6, 2021. Today I'll be talking about the W6NBC Double Delta Slot HF antenna and how I built and tested one. So who am I? Well, my name is Mark Smith, currently, or aka Smitty or Smitty Halibut. Currently, my call sign is KR6ZY as I record this, but I'm hoping to be N6MTS by the time you see this video. On Twitter and YouTube, I am Smitty Halibut. You can find me there. Twitter's probably the best place to get a hold of me. What are we going to be talking about today? Well, this double delta slot HF antenna. I'm going to give you the background of why I'm giving this presentation today and what goals we're going to try and to meet with this presentation. We're going to talk about how I built the antenna, how I took the measurements, how I analyzed the antenna from those measurements, and what conclusions I've drawn. And then we'll talk about what's next. So first off, background and goals. So what is this antenna? Well, it's an antenna that was designed by a gentleman named John Portune. His call sign is W6NBC. He's written many articles in many different publications, such as QST, CQ, etc., etc. Several years ago, he got an interest in slot antennas. If you remember an article in QST where you could take a satellite TV dish, like one of the Dish TV kind of network, Dish Network kind of TV slot, dish antennas, and then cut a slot in it with a little vampire teeth hanging down on the side, and use it as a VHF antenna, like a 2-meter antenna. That was his article. He wrote that article. Last year at the QSO Today Ham Expo in 2020, he presented on an HF slot antenna, and he gave a great presentation. It's one of my favorites. The article for that presentation is at this link here, w6nbc.com. From there, you navigate to articles and look for his article on the double delta slot antenna. I'm going to be talking a little bit about that antenna, but really for all the details, go see his presentation or read his article. So why this antenna? Why do I want this antenna? Why am I interested in it? Well, it's got a lot of really neat features. It's got a small footprint, like a vertical antenna, right? It's built like a vertical antenna, very small footprint on the ground, very tall, no ground plane, except that it radiates like a horizontal dipole at the elevation of the top of the antenna, which is pretty rad. It's multi-band, sort of. It's non-resonant, so you use a tuner to make it multi-band, but that's what we're going to be talking about today. But it'll operate on a wide range of bands. And it's electrically steerable, electrically pointable. There's no rotator. There's no physical moving parts other than the relay to be able to change what direction it's radiating in. So it's got a lot of really neat features. Sounds pretty great, huh? Well, let's go take a look at it. What are the goals for this presentation? I blame George because we were talking about this antenna on the ham radio workbench. I think it was on the podcast. And he started asking all kinds of questions for me that I didn't have answers to. Like, one of the questions is, how do you build it? You got two loops. They're physically 90 degrees out of phase from each other. And John doesn't really answer this question of whether you put those loops in parallel or in series. He doesn't even talk about how to analyze it. But what do I mean by parallel and series? Well, parallel and series, right? You got a north-south loop and you've got an east-west loop. One's pointing north-south and the other one is pointing east-west. When I say pointing, I mean broadside, which way they radiate. And they don't actually have to literally be north-south and east-west. They can point it whichever way you want, but I'm going to call them the north-south and the east-west loops. You could literally put them in parallel like this, or you could connect them in series. They'll work the same either way. The impedances will be different, and the job that the antenna tuner has to do is different. But electrically, the radiation pattern of the antenna is the same in either of these cases. The other question is about rotation. 90 degrees isn't very precise. I can either have it point that way or I can have it point that way. And my question was, if I energize only a single loop, not both loops, I can also add the 45s between those 90s as a radiation pattern. So let me tell you what that looks like. When you got two loops, so here's our north-south loop, and here's our east-west loop. In the sides of the loop that are in phase, both of the same phase, that's where the radiation is going to go out, right? So that plus and that plus, they're going to constructively interfere with each other going that way. Same with the minus and minus. They're going to constructively interfere this way. But the plus and the minus on this side are going to destructively interfere going out that direction. So this is the null. These are your radiation patterns. If you electrically reverse one of them, just swap the leads, that's the minus and that's the plus. Now the plus and plus are down here. This is your in phase, and that's where it's going to radiate. And your in phase is out here, and then this is where your nulls are going to be. So just by reversing the polarity of one of the two loops, you have rotated your antenna by 90 degrees. That's pretty slick. But would it be helpful to also have the 45s? If I only energize one of those two loops, right, then it just radiates like a normal loop, and it goes broadside of the loop that's energized. So the east-west is turned off here, but the north-south is energized, and so it radiates on the broadside. If you do the same thing with the east-west, it radiates the other way. And so in these four different configurations, you could have all 45-degree radiation pattern options. So George was asking me a bunch of questions. Is one of these options, either parallel or series, better than the other? If not, can we build the antenna so that it can use all available of these options? And then, is it worth the added complexity to do that? And that's what I'm going to be trying. Those are the questions I'm going to try and answer today. So that's the background and the goals. Let's go build the antenna. One of the cool things about this antenna is that the dimensions are not critical because it is non-resonant. The tuner will match it to whatever the antenna is within limits to what the radio wants to see, to the 50 ohms the radio wants to see. It doesn't matter whether it's exact dimensions. We're not resonating the antenna. So you can build it in just about any way you want. Hand wavy. In my particular case, I had a 24-foot section of 2x4. It's actually a 20-foot section with a 5-foot section kind of overlapped by about a foot screwed on top of it. So from ground to the tip, it's about 24 feet. I'm using lumber because that's what I had. If you have a metal mast, that works just fine as well. It does not need to be non-metallic for the mast. My base, my bow line, is about 2 feet off the ground because it makes it easier to work on. So the total height of the antenna is about 22 feet. The spreaders at the top of the mast are 4-foot sections of fiberglass tubes sticking out, like 1/2-inch fiberglass pipes, and that I run the wires through. And since they stick out from the mast by about 4 feet on either side, the total spread at the top is about 8 feet. The ballon down at the bottom is a 1-to-1 ballon. It's just 11 turns of speaker wire on an FT 140 43 toroid. The tuner is an LDG RT600 remote tuner. Again, all of the details of building this are available in John's article. I'm just kind of hand-waving and describing how I built this antenna. The feed line, because of where it is in the yard and where the shack is and how the cable runs, it ends up being about 200 feet. I had RG213 around. There's a big story about how good that cable is or whether it's good or not. I ended up buying some DX Engineering 400 Max to replace it with. I have not replaced it yet, but the spool of cable is in my garage. I will be replacing it before too long. So that's what I built. Here are some pictures of it. So this is a picture down at the bottom facing upward, so you can see the 2x4 mast. It's bolted to the corner of my fence. There's a steel fence post right behind it that's about 2 feet into the ground with concrete. So that's how the mast is anchored. Here's the matching box. You can see the wires going up, the spreader up at the top there. This is what it looks like when you're looking at it from the yard. So it's at the corner of the fence. This is the ballon box. It's just SO238 coming in here, turns on a FT 140 43, and then goes up to the stainless steel screw terminals for the wires coming down to up to the antenna. About a 3-foot section of coax over to the RT600 tuner, and then what's not shown here is the feed line going into the tuner over to the shack. All right, so pretty simple build. The spreader bracket at the top is something that I had to design custom. This is a OpenSCAD parametric model. I 3D printed this bracket. It fits right on top of a 2x4 with some screw holes that you can screw into the 2x4 to keep it in place. Then it's got these 4 brackets here for the fiberglass masts coming into them, or spreaders. And then the wire goes in through the hole there and then out through the top, up and over into the next one over to that spreader there, right? So the wires kind of cross over each other on the top of the model. I could have made the spreaders go straight through all the way across and then just made them one on top of the other so they're not coplanar with everything else. I opted for this. I'm not entirely sure why. It's somewhat arbitrary. But this model, both the OpenSCAD source code and the STL are available on that GitHub. So all of these files, all this data that I'm showing you are on GitHub. Okay, so, oops. I built my antenna a little bit differently than the way John describes it. So W6NBC's design is radio to feed line, to ballon, to the tuner, to the antenna. All right. I built mine radio feed line, tuner, then ballon, then antenna. So you'll notice that I swapped the order of the ballon and the tuner. What's the implication of this? Well, in John's design, the tuner is on the balanced side of the ballon, even though it is an unbalanced tuner. Okay, that's not ideal. It works, but it's not great. I, on the other hand, have the tuner on the unbalanced side of the ballon, but now my ballon, which is designed for 50 ohms, is now being used in a circuit with wildly varying impedances and very complex impedances, right? I have not done the analysis to figure out how well my ballon's going to work in all of those situations. Probably not as great as I would like it to. Both of these are compromises. Neither one of these is a great design. I am going to go ahead and proceed with my design because, to be frank, I didn't find out that I screwed this up until very late in this process. I had already collected all the data and done all of the analysis. I'm going to proceed with what I've built because it works. It's got its issues, but it works. All right, so that's my oops. That's the antenna build. Let's look at the measurements. How am I measuring it? Well, I'm going to use everybody's favorite new tool is the Nano VNA. I have a Nano VNA F, the larger one with the 4-inch screen. I recommend the 4-inch screen for us guys whose eyes are getting older. Anyway, Hopefully you saw Alan's presentation earlier today. Even though I'm recording this several weeks before the event, I'm sure it was awesome. Actually, all of Alan's stuff is awesome. If you haven't seen him on YouTube, go check him out. Hopefully you saw his presentation earlier today on the Nano VNA. Because of that, I am not going to go into details. I will mention that I had some fun adventures in Nano VNA calibration. There was a lot of a learning curve on how to calibrate over the right frequency range and all kinds of fun things like that. So took me a while to figure that out. I took a lot of bad data, removed it from GitHub. It's all in the Git history if you want to go take a look at it, but it's all junk anyway. So the stuff that's still in GitHub right now, currently in GitHub, is all good, taken after properly calibrating the Nano VNA. In addition to the Nano VNA, I also used a software package called Nano VNA Saver. It's a software package. It runs on Windows, Mac, Linux, and it adds a lot of functionality to the Nano VNA. It just uses the Nano VNA for the hardware. It uses it as a sensor, and then it talks to it over a USB cable, controls the Nano VNA, gets the raw data from the Nano VNA, and does its own analysis internally. One of the big advantages to Nano VNA Saver is that you can configure it to do multiple segments. A Nano VNA will only measure 101 data points from the start to the end frequency. If you tell it to measure between 3 and 30 megahertz, it's still only going to measure 101 data points from 3 to 30 megahertz, and that's not great precision. I wanted to measure from 3 to 30 megahertz in about 10 kilohertz steps. So I configured it to measure from 3 to 30.27 in 27 segments of 101 steps each. Hand wave. You got to jump through some hoops, but 2,727 steps of 10 kilohertz each will measure between 3 megahertz and 30.27 megahertz. I got that whole thing in 10 kilohertz steps. What is it measuring? It's measuring the S11 parameters, not the S21. That's different. The S11 parameters. What is an S11 parameter? Hopefully Alan explained this better than I will, but put a signal out this port 1, hence the first one, actually the second one. The output is 1 on port 1, and then we're measuring what's coming back in from port 1. So input on port 1, output on port 1. That's why it's S11, the 1-1. We're outputting a signal, then we're measuring the amplitude of whatever signal comes back, and we're measuring the phase, the relative phase of whatever signal comes back. The fact that we're measuring the phase is what makes this a vector network analyzer instead of a scalar network analyzer. If all we were measuring was the amplitude, that would be a scalar network analyzer. All right, and then Nano VNA Saver saves all of this data in a standard file format called Touchstone. The file extension is .s1p. If you're measuring S21 parameters, where it's out on one port and in on a different port, that would be an S2p file. We're only using S1ps, or the S11 parameters. Nano VNA does a lot of visualizations. It is a very useful tool in and of itself. It's neat to visualize that data. We're not going to be doing that very much for this data. I'm primarily interested in those Touchstone files. But this is what Nano VNA looks like, right? So it's super useful. Up here is where you set that sweep. I was talking about the 27 segments of 101 steps each. This is where you configure that. You can set up a bunch of markers, what frequencies. I've got them in the centers of each of the bands. Here's what's showing the data at those markers. You can tell it what data you want it to display for each of those markers. I've got a bunch of graphs on here, the Smith chart of what the antenna looks like, the complex impedances, yada, yada, yada. A lot of really cool stuff that you can do with Nano VNA Saver. This is not a presentation on Saver. So I use the Nano VNA and Saver just to take the measurements and save it to a Touchstone file. Next thing we need to do is we need to analyze that data. And that's where a lot of my fun stuff comes in. So what are we analyzing? Well, what does the antenna look like natively? That's what the Touchstone file has, right? The complex impedance of the antenna at a given frequency. And it's got a whole lot of those frequencies. It measured it every 10 kilohertz between 3 and 30 megahertz, right? So let's calculate what the theoretical perfect matching network would be at that frequency to match that impedance to a 50 ohm resistive load, which is what the radio is expecting to see. What is that theoretical perfect matching network? All right. My RT600 is not a perfect tuner. It is not infinite. It does not have an infinite range of capacitance and inductance values, and it does not have an infinitely small precision, right? It can count from 0 to 127 in 10 picofarad steps. So from 0 to 1,270 picofarads. Or it can count from 0 to 127 in 100 nanohenry steps. So from 0 to 12,700 nanohenries, right? So it's a 7-bit switching network of 10 picofarads or 100 nanohenries. And that's what it can do. And then the inductor is in series, and then the capacitor is either in parallel with the source or with the load. It can move the capacitor to either side of the inductor. So it's an L network. It's a low-pass L network with a capacitor on either side of the inductor. That's what the RT600 can make. So now that we've limited the theoretical perfect matching network to what the RT600 can actually produce, what is the impedance presented to the radio based on this real matching network and the actual impedance of the antenna, right? It's not going to be 50 ohms because we've got some limitations on the tuner. So let's go figure out what that impedance is when it's presented to the radio. That number is ultimately what we're going to be looking at the rest of this trip. So I wrote a Python script to figure all of this out. There's a lot of calculations. We got a lot of data points. I started out like copying and pasting values into an online calculator, and I very quickly realized, no. I just wrote a Python script that does this for me. So the Python script takes in an S1P file and outputs all of this. You'll note that the first column here are the measurements. This is what's in the touchstone file. So we got the frequency that we're calculating at. What are the complex impedances at that frequency? Then we calculate the amplitude of the impedance and the SWR. Then we calculate what the ideal matching network is. If the capacitor is in parallel with the source, then it'll show up in this column. If it's in parallel with the load, it'll show up in this column. And then the inductor is just always in series, so it's always there. Then we apply the limitations of the RT600 to that matching network. We limit it at 12,700 nanohenries and at 1,270 picofarads, and then also to 100 nanohenry steps or 10 picofarad steps, right? So this is the matching network that the RT600 can make to get as close to this ideal as possible. This here is an alarm that says we're out of range. We need way more inductance than what we can provide. So this says we are out of range on the inductance. In the other data, some of the data below that's not on the screen here, we are out of range on capacitance as well. Then, given this actual tuning network applied to this complex impedance on the antenna, what does the radio see? Right? That's what we're showing on this last column, and that's what we are interested in for analyzing this antenna. Given this network and this complex impedance, this is what the radio is actually going to see. Okay? That's what we're doing. I'm not going to show you all the raw data here. That screen was just to demonstrate what my Python script had done. If you want to see the actual data, go to my GitHub. It's all there. What I am going to present here are the conclusions. So I've taken a look at all of this data and I've looked through it and tried to figure out tried to answer George's questions based on that data. But first, a disclaimer. All of this is based on my particular build of this antenna, right? One of the big features of this antenna is that it is very flexible in its construction. The dimensions are not critical. The antenna tuner will match whatever you build to your radio, mostly hand wave, right? If you build your antenna with different dimensions than what I built, your numbers will be different. I'm not saying that you have to build your antenna exactly like I built mine so that these numbers match yours. What I'm saying is build the antenna that you want to build for whatever your constraints are or your capabilities are, but use my tools that I have published and made them freely available on GitHub so that you can measure your actual antenna and analyze your actual antenna and perform this same analysis for your use cases. Okay, so what are the actual conclusions for my antenna that I built? And here are the different bands, the different qualitative analysis based on the parallel, the series, and the single loop. And then some notes on here. This slide is in the slide deck. You can go read it. I'm not going to go over every single one of these pieces of data, right? What I am going to do is answer this question. What does it all mean? Well, in parallel, with loops in parallel, we get a good or great match pretty much from 60 meters to 10 meters, with the exception of 30 and 20. It's a little reactive on 30 and 20 meters, but the tuner inside your antenna, or the tuner inside your radio, will be able to match the reactiveness of the SWR on 30 and 20 meters. The SWR is still pretty low. It's just mostly reactive instead of resistive. In series, we get a good but not great match on 60 meters and 15 and up. The match is great on 30 meters. And again, it's usable but very reactive on 40, 20, and 17. Right? So you can already see how the series is good on 30 meters, but it's not good on, but 30 meters is not good on parallel, right? So it's good on series, but not on parallel. But if the opposite is true for 40 meters, it's good in parallel, but not in series, right? So now we have a case of two different bands where one is good on one, but not on the other, and then the other one is good on the other, but not the one. So this is why you might want to put the switching in the base of the antenna to select the configuration, parallel or series, based on what bands you're operating on at any given time. And then single loops for the 45s. It's good or great from 60 to 10, except, again, for 30 and 20 meters. In the parallel, you could kind of make it work on 30 and 20. It's within range, but just very reactive. It is an unusably high SWR. It's above 3.0 to 1 or higher on 30 and 20 meters for a single loop. So the single loops are great for everything except 30 and 20 meters. I haven't used the antenna a whole lot because I just got it working a few weeks ago, and I've been super busy with work. But I have done some testing, and what on-air testing I have done matches this data. I'm seeing on bands that it says it should match super clear, the radio is saying, yeah, 1-to-1. On bands that it's saying I should have about a 2-to-1, I'm seeing about a 2-to-1. So it's matching pretty close with this data. That makes me confident that this analysis that we're doing is going to be pretty good. So what is this antenna good at? Well, it has all the benefits that John mentions in his presentation, in his article, right? Small footprint, horizontal radiation polarization out of a vertical antenna, all that fun stuff. In my case, it covers all bands from 60 to 10 meters at varying degrees. It might also work on 6 meters. I don't know. I haven't measured 6 meters, but I can't think of a reason why it wouldn't also work at 6 meters. It's pretty easy to construct. It's inexpensive, except for that tuner. It could be made portable, but more field day portable, not so much soda portable. What's it not good at? Well, again, as built in my yard, 80 meters and below is pretty much a complete loss. The SWRs are high enough that I'm not likely to be using it on 80 meters anytime soon. If you built your loop taller or wider or larger in some way, you could probably fix that. You could probably make it work on 80 meters. I can't think of a reason why you wouldn't be able to. 20 meters, one of my favorite bands, is not great in any of the configurations. It's usable, but it's pretty reactive. Using the tuner in my radio, I can probably compensate for that because I have, but it does mean that I need to use the tuner in the radio, which when you've got a remote tuner, you're kind of not supposed to do. Is it worth the complexity for having parallel and series? If I cared strongly about 30 meters, I could see building a switching network here to change between parallel and series. But for my use case, I don't use 30 meters very often. I'm not a CW guy, and I can do FT8 on 20 and 40 just as easily. So I'm willing to trade 30 meters in exchange for a simpler build. So I'm going to keep mine 2 loops in parallel and just use the parallel configuration. It means 30 meters is not great and 20 meters is not great, but it makes it a much simpler system. Someone with different goals, or if you build your antenna differently and you end up with different numbers, I could very easily see someone justifying this complexity. The complexity isn't great, isn't huge, but for my use case, I don't think I need it. But someone else, I could easily see justifying that. So, is it worth supporting single loops to be able to get those 45s? This one's a little bit harder. Would it help? Would it even help to do that? Well, the modeling that John did shows that the antenna is down about 3 dB, 45 degrees off from center, right? So if that's the radiation direction, 45 degrees off, you're about 3 dB down. So the total beam width is about 90 degrees at a minus 3 dB range. So rotating it by 45 degrees would only get you about 3 dB worth of benefit. 3 dB is not nothing, but it's not huge either. The side nulls are a lot narrower, so it might be worth trying to point your antenna more precisely to be able to null out a noise source or a strong signal or something. So I could see someone trying to get it for that. Can it be done? Well, the single loop is pretty similar to the parallel. It's good from 60 to 10, except for 30 and 20, although it's pretty much unusable on 30 and 20. The SWR is really high. Should it be done? The RT600 is a memory tuner. There's a term for it, that has a memory. So when you transmit on a frequency for the first time, it goes through its full process, 10 or 15 seconds of switching out all of the relays, trying to find the perfect match. And it finds the best match for that given frequency, and it stores it in memory. And then you go off to some other frequency and do something else and have to retune it. And then you come back to that frequency, and it says, aha, I've already tuned on this frequency. I remember what the matching network is. And it goes straight to it, and it says, yep, that's still a nice low match. Perfect, we're good to go. And so it goes straight to that matching network that it remembered from last time. But if you've changed your antenna from parallel or from a dual loop antenna to a single loop antenna, that will inherently change the impedance of the antenna on a given frequency. And now you've lost the benefit of that memory in your tuner. So now your tuner has to go through and perform a full retune every single time. I found the tuner to be more of a pain in the butt than I anticipated, and anything that makes it even less convenient is not a good thing. So for me, for my personal use case, I don't think it's worth bothering with the complexity to add single loops. Even if the complexity weren't all that much, to me it's not worth it. So, summary, for my antenna at my use case, I'm going to keep them dual loops in parallel. I'm going to put a remote switch out there to swap the phase of one of the 2 loops so that I can rotate it by 90 degrees. I am not going to bother supporting series or single loops for my personal build. Again, as built that way, it will cover 60 meters through 10 meters to varying degrees. 20 and 30 will require a little bit of additional tuning in the shack, but for the most part, it's okay. And I'll probably make a second one of these for use with my club for field day. I think it would work really well as a field day antenna. All right, so those are the conclusions I've drawn. What is next? All right, so let's say you built your antenna differently, or you have different goals, and you do want that complex switching network. What would that look like? Well, I drew that up. Again, this diagram is also in the GitHub, so all of that data is there. With these 4 double pole, double throw switches, we can get full configuration of the antenna. These 2 switches, switch 1 and switch 2, turn on and off each of the individual loops. By default, they are normally enabled, normally closed, I guess. So the loop is in the circuit. You energize one or the other of these 2 relays to take that loop out of the circuit. Switch 3 changes the 2 loops, changes the loops from it being in parallel to in series. And then switch 4 reverses the phase of one of the 2 loops for that 90-degree rotation. So with these 4 switches, or these 4 relays, you can completely configure your antenna for any of these configurations that we've talked about. Bonus points. If you run the power for switch 1 and switch 2 through a third pole of switch 3, so that when you energize switch 3 to be in parallel, it removes power from switch 1 and 2. You create a safety interlock. So whenever you have these in series, you want to make sure that both the loops are always there in series, because if you make one of the loops go away, then now you've got an open circuit. So you want to make sure that both of your loops are there for in series. And if you run the power for these switches here that take the loops out of the circuit, and turn that power off whenever that relay switch 3 is engaged, you create a safety interlock. I highly recommend you do that if you're going to do that. So make this a 3-pole or a 4-pole relay here to be able to cut off power to these two. So there's the switching network you would build if you wanted to. You can design a board with like an SO239 at the bottom, a little spot for a ballon in there, all of the relays you want, and then terminals for the loops up at the top of that. If you really want to get fancy, you can control it with a microcontroller on the board to control all those relays, and you can make it so that it knows all of the different configurations. You just tell it, I want, on this band, and I want to point in that direction, and it, does all of the relays for you to figure that out. You can even control it using George's fancy serial protocol, his RS-485 over a Cat5 cable, or wirelessly over Zigbee if you have a way to get power out to the thing. In addition to that, John is continuing to work on this antenna design. He's got more coming. He's continuing development. I won't steal his thunder here. I know what he's doing. It's pretty cool. But I'm going to let him talk about it. So I strongly encourage you to go watch his presentation at the QSO Today Ham Expo in March of 2021. He's giving a presentation there. And that's it. I promised there would be notes at the end, a slide with all of the links. Here it is. And I will take time to answer any questions. Again, I'm Smitty Halibut. Find me on Twitter or YouTube. And thank you very much for watching.
Thanks, Mark. That was an awesome presentation. And this is one of those great projects where I really want to build it myself, but I managed to prod you along to get you to do it so I could just see how it went and then decide if I want to do it myself.
There's a reason I blamed you all the way through the presentation. Yes.
Yeah, I'm happy to have helped.
And I got to slip silently along as a subcontractor. So
that's right. And you escaped all blame. You just shoved all that onto George.
It's what I'm good at. So you go with your skills.
That's right.
I've got a few questions here. The first one is from Russell, and it says, hey, what was the material for the spreader basket? Was it ABS or some other magical thing?
So I do recommend better materials than what I did. What's up there is actually a test print using, gravy, the cheap stuff that, PLA. Great gravy. Why did I forget that for a second? It's using PLA, and it's my fast print configuration. It's not even like the big dense one. I fully expect that to snap and break and come down. And when that happens, or probably before that happens, I should reprint another one with better infill, better shells, and using ABS, something that's not going to get broken down by ultraviolet. What's up there is absolutely temporary, and it needs to be better.
Okay, and Philip is asking, what does the radiation pattern look like? How different is it for the parallel versus the series?
So the radiation pattern does not change at all for parallel versus series. The currents and voltages on each individual loop stay the same. The only thing that changes between parallel and series is what is presented to the tuner. The tuner sees the same, each of the loops has a given complex impedance at any given frequency, and you just either have that complex impedance in parallel or in series when the tuner sees it, but each loop is the same. It doesn't change the configuration of the loop. So ultimately the radiation pattern is the same.
Super. Okay, yep. I got another question from W2.
Oh, actually, hang on. Let me answer the first part of his question. His question is, what is the radiation pattern? It looks like a dipole. It's the standard 2-lobe symmetric, no front to back ratio, but you've got radiation out in that direction and some nulls out in that direction.
Okay, good catch.
Yep.
From W2AEW, assuming you calibrated the VNA at the 600, or say the RT 600 feed point to determine the tuner parameters, were the impedance seen by the radio numbers calculated by taking into account the coax to the transmitter?
Good point. No, they were not. So it would have been more accurate to describe that as the impedance at the radio port of the tuner. That would have been a more accurate representation for what those numbers were.
Okay. And Berg's got a question. Did you try modeling to see if the frequency could change enough to allow 20 meters? Because frankly, everybody wants 20 meters.
Everybody wants 20 meters. It is 20 and 40 are the two bands to go to right now. No, I have not done any modeling. John has done a bunch of modeling, but I think he primarily modeled the one that he built, which ended up being about 30 feet tall, taller than mine. I have not done any modeling on this. I literally look at John's design and said, well, the dimensions aren't critical. What do I have around the house? And I had a big 20-foot section of 2x4 and some other 2x4. And I went out and bought the fiberglass spreaders. I had some wire, and I literally threw this together with very minimal purchases of parts. And the dimensions were ultimately decided by the materials I had. It was not a conscious decision of, I'm going to build it with these dimensions for this reason.
Oh, very good. Okay, and this is the last question. Everybody is thinking of asking this. At some point, this is from Daniel. Mark Smith, I'd like to hear about where halibut came from.
Where did halibut come from? All right, so I'm a nerd, as you may have noticed, and I've been a nerd my entire life. When I was 12 years old, when I was 10 years old, my mother, of all people, got me into BBSing. This was 1985 up in the Bay Area, in the South Bay, where I grew up. And by the time I was 12 years old, 7th grade, I wanted to run my own BBS. And I was trying to think of what name I wanted to call it. And the best name, I'm like, well, why am I going to run a BBS? Well, just for the hell of it. And my mom is looking at me, a 12-year-old kid. Maybe that's not the best name. Why don't you change that to Just for the Halibut BBS? Okay, fine. So it became Just for the Halibut BBS. But this is the 80s, and I couldn't afford a hard drive, so everything was running on a floppy disk, which meant, of course, they died every 6 months and needed to be reinstalled. And eventually, the BBS just got shortened to the Halibut BBS. And so Halibut kind of became my brand at that point. In high school, I started a computer repair business called Halibut Computers. When I was in college, I was in the dorms the first quarter that they brought Ethernet to the dorms. That was a mistake. And so I had halibut0.calpoly.edu. I got a contracting gig in the summer of 1995, so the summer after my second year of college, helping somebody up in Redwood City start a ISP. And as payment for ongoing support after I went back to college for my third year, rather than me charging money to be on retainer, I built my own server, stuck it in the corner of his garage where this ISP was. I had an IP address on his 56 kilobit digital line, and I had a static IP on the internet. It was co-location, but we didn't know that it was co-location because we didn't call it co-location because that industry hadn't been created yet. But it was basically, I put together a server, a Linux box in 1995 on the internet. And of course I needed a domain name. So of course I'm going to register halibut.com. And it was available because 1995, it was free because 1995. So I've always been Halibut. Halibut is my brand. That's
as you do.
I have a question now. So I want to know if your retirement plan is to sell the domain halibut.com for $1 million.
So for how much? What did you guess?
Well, a couple $1 million.
Okay, so if we really want to go there, I do occasionally get emails from people offering to buy the domain, and I respond to them. These are the only unsolicited emails I ever respond to because I'm actually curious. The current high water mark for an offer was $25,000. And $25,000 is a very easy, no, this is my brand. It's not worth $25,000 to me. $2.5 million, that would be I'll rebrand for $2.5 million. The question is that middle ground of $250,000. Like, I've tried to do the what if in my head. If someone came and said, I'll offer you $250,000, that'd be awfully hard to say no to.
On one hand, you have the low water mark of a decent ham shack.
Yep.
On the other hand, you have your own yacht.
Yeah.
And then we're trying to shoot somewhere in the middle. Okay.
Yeah. Like pay off my mortgage and, add a whole lot to my retirement. It would be hard to say no to that, but it's also not an immediate yes.
Terrific. Hey, that's all the questions I've got.
I have one last one before we let Mark go,
Okay.
and that is, since you said that John, when he built the antenna, he built his taller, around 30 feet. Do you recall, did he have better performance on 20 meters with that version?
I don't think he actually ever analyzed his the same way I did. He did all of his analysis based on modeling. He found that 32 feet tall should absolutely be avoided because 32 feet ends up being resonant on, I think that would be 40 meters or 20 meters, one of the two. I can't remember. I think it ends up being a full loop.
It's a half wave on 20 at that point.
Yeah, but remember, it's symmetric, so it would be like 64 feet total.
Right.
And so that would be a full wave at 20 meters and a half wave at 40 meters. So that's where it ends up being resonant, and that is very difficult for the tuner to deal with. So you actually, if you're going to do a non-resonant antenna, you want it to entirely be non-resonant. And so he found that 32 feet was a height to avoid, but as long as you were either taller or shorter than that by a couple of feet, it ended up working out okay.
Great. Well, thanks so much, Mark. It's a fascinating project. I mean, having a vertical antenna that's horizontally polarized and doesn't have radials that you can plant in your backyard,
right,
is kind of like a magic antenna.
Yeah.
So even though you said it was not very good on 20, if it worked kind of at all, it might not be bad to do that.
So it works well on 20. It's just reactive, right? So it's not a perfect 50 ohm resistive load. It still works just fine on 20. Two things. One, the other advantage to this antenna is that I swear I'm going to put up little semaphore flags to make it look like a yacht with the little letter flags down the side, because it does look like a yacht rigging. And two, John has another presentation on this antenna with some other enhancements that he's doing at the QSO Today Expo. I highly recommend you go watch that video, because he's adding some cool things that I know what he's doing, and it looks very awesome. I'm not going to talk about it. I don't want to steal his thunder, but go watch his presentation.
Well, great. Well, that's coming up in March, so a month from now. So it's a good fair warning to be looking out for that one.
Yeah.
And that'll be a great event. Thanks a bunch, Mark. Appreciate it.
Cheers. Thanks.
So we're going to go ahead and kick it over to Marcel and John for the last drawing before the last presentation.
What time is it, Marcel?
It's drawing time, John. I'm so glad you asked.
It's the last time these poor people are going to have to hear our
second to last. I mean, the final drawing will be at the end of the last presentation, but this is the last one in the middle of the day. So we've got a couple items here that we're going to be putting into the drawing. Reminder, the full listing of what's available is at baynet.org/prizes. We did just close down the silent auction just before we came to this break. And it was some pretty hefty bidding there for the Analog Discovery 2. So right at the end, we had a couple more bids come in. We'll announce all the winners at the end of the day today, including the number 2 winners. So I know there are a couple people that are biting their fingernails and trying to figure out if they managed to get that number 2 spot. So with that, we'll go ahead and jump right in, John. We've got a couple items here. First one is a QRP Labs 5-watt PA kit. A nice little match for your dummy load kit in case you won that one earlier. Who's going to get this one?
All right, here we go. And the number is 690. And scrolling up the list here. And for those of you that think I should just do a Command F, the spreadsheet's not set up like that because of ranges. So let's see here, 690 is, want to check the number again, 690 would be Patrick McKenna, M-C-K-E-N-N-A, Patrick McKenna.
Cool, congrats Patrick for your nice little PA kit. That should be a fun little project. All right, we got another one here, Gordon West Extra Class Course. So this one's the match. This is the 6 CD system that matches the earlier one. Again, a lot of the materials very, very similar, even though this is a generation old. Donated by Mike K6 QFO. Thanks so much for putting this one together. Who's this one going to, John?
Yep, this one is going to number 2331. And that is 20. 2331 is me again. So we'll draw again. It's embarrassing.
Is that statistically possible?
You bought a lot of tickets.
1777. I bought a lot of tickets. What better thing to do with your money than, it's a great organization, George. At least that's what you've been telling me. So let's see here. 1777 goes to Clinton Daug, Dague.
Clint, congrats. Always fun to see some folks on there. Great. All right, we have two more here. This one's a Heil headset cable adapter for ICOM radio, donated by Mike as well, in case you have an ICOM radio, or you'll probably have a friend that you can trade this one for if you don't. So who's getting this one, John?
This is 2376. 2376 is 2370 is Frank Dries again. Well, I think that's the third time. He was a big donor as well, bought several tickets. So
cool. Congrats, Frank. All right, and last one for this round is a nice DIY antenna grab bag mystery box. This is the fourth of four that we're getting here in the drawing. Again, filled with all sorts of fun Pactenna parts, so you can make your very own HF antenna. Who's this one going to, John?
It's going to 3567. 3567 is Randy Neals, Neals. I think he may have won earlier as well. Again, another big ticket purchase guy. So thank you, Randy.
Congrats, Randy. Yeah, it's always fun to see. The people that get a lot of tickets do definitely up their chances. So congrats to everyone that just run there. Remember, sticking out for the very end, we've got a whole bunch of really cool prizes in our last drawing right at the end of the last presentation. And thanks so much for everyone that did support and buy raffle or drawing tickets today and pay for the silent auction. So we'll be giving all those announcements at the very end.
All right, thanks, Marcel. So we're at the last presentation of the day. Thanks everybody for sticking with the program. And we're going to go ahead and do the last one now, then come back and do the final drawing and the silent auction, and then we'll wrap things up. So next up is Rex KE6MT. Rex is a very active SOTA operator and overall outdoor radio operator, and he's going to do a great presentation for us on HF radio on a budget.
Hello, I'm Rex Vokey, KE6MT, and this is my presentation for BayCon 2021, HF on a budget. A little bit about me. I'm a hiker and a trail runner, and I got into ham radio back in 2015. I wanted to get more range out of radios and kind of had a vague idea that ham radio could do that. And once I got into it and got my license, started discovering all of the things you can do with ham radio, kind of that concept of the hobby of 1,000 hobbies that's been thrown around. And I really just started diving into it because not only does it have the electronics aspect of things, but there's just all sorts of magic things that can happen when you're talking about radio and communication over any sort of distance wirelessly. So it's always really excited me. Even to this day, I'm 5 years in and it feels like I'm still new, and compared to some I am. But yeah, I'm also the W6 or California Association Manager for Summits on the Air, and pretty active in Summits on the Air. So why do HF on a budget? Well, essentially, this is information I really, really wish I would have had when I was a new ham. Because I got into ham radio, and I was looking for a way to do HF on a budget. I tried things like Pixies and Chinese rock mic kits, and they're not very obvious as far as, some of those aren't very obvious as far as how to put them together. And in the case of the Pixie, it doesn't provide the functionality you'll need to become successful with it right away. So I wanted to find a path that somebody just getting into this, or even somebody that's been doing it a while, could try out and have success with. So these are the basics that you'll need to do HF on a budget. A new golden age in amateur radio. This is a concept I think that's been thrown around on the ham radio workbench. I fully believe this concept. We are fully in a new golden age in amateur radio. It's you have great access to information. Availability of parts is like never before. And not only is there good availability of parts and the ease of ordering them, but these parts can do a lot. You have microcontrollers that you can program to do just about anything, including generate frequencies in some cases. So just a wealth of information, parts, well-designed kits. I'm going to get into this later in the presentation, but there are kits out there where you can go from very, very, very little knowledge to having a fully built radio at the end of it. So that's a great resource to have. That hasn't always been there. Learning resources, YouTube videos, blog posts, there's so much content available now. I guess the hardest part of it these days is finding what content that is going to help you. So, you know, it's all there. So you just have to find it and sort through it. But, you know, it's more information than we've ever had in the past. And it's a great combination with all of this other stuff to have our golden age. The magic of shortwave or HF radio. So this is the thing that really gets me. I love VHF, UHF, microwave. I love all aspects of ham radio, basically. They all have their magic, but HF has a certain magic to me that's, at least for the time being, the most interesting, because you can have direct, non-line of sight communications over thousands of miles. And I threw a little illustration in here just to have fun. But these two stations are down in valleys. This station, whether it's a mile or 5 miles away, it doesn't matter. This mountain is in the way, and it's not going to be able to talk to this station with line of sight or VHF, UHF communication. But HF, with the right antenna, depending on the distance, is going to be able to, you know, shoot the signal up into the sky, bounce it off the ionosphere, and it's going to land with this other station, and they can talk back and forth using that path. Low power can work with HF. It doesn't have to be low power, but it can work quite well when you're using a full-size antenna. There are a wide array of antenna possibilities. That's one thing that's fun about this, is there's probably hundreds of different antenna designs you could use. There's only a few that I actually do, but it's a very, very fun aspect to explore. And there's a lot of tolerance in what you can use and how you can build these antennas. So say, for example, you need to build an antenna that works on the 40 meter or 7 megahertz band of HF. If you cut that antenna an inch or two short or long, it's not going to make that big of a difference. So there's a lot of tolerance in how you can build things and the parts that can be used for HF. And last but not least, solar cycle 25. We're getting into solar cycle 25. We're starting to get more sunspots and better ionization of the atmosphere. And I guess that could be considered, we have more solar radiation hitting us, but it's great for radio communications. So we're getting into that. It's going to become easier and easier to use HF to make these contacts. So how do we build this on a budget? You're going to be investing, the biggest trade-off here is that you're going to be investing time versus money. So you're going to take the time to build the equipment you're going to be using. You're going to be taking time to learn, and you're investing a lot of time in order to pull this off. So if if you're somebody that doesn't have the time to invest in a hobby like this, then maybe it's not for you. But if you want to learn and build your own equipment and use your own equipment and save a bunch of money, this could be a great way to go. Some electronics familiarity can be handy if you're going to go this route, and definitely persistence and patience, because as smooth as this path may seem, there are always potential things you could run into that'll slow you down or stop you, and you have to be able to push through those. So what's needed equipment-wise? You're going to need a basic electronics tools, a transceiver, of course, an antenna, key or a paddle, and by key I mean a straight key. That's where you form the dits and DAWs yourself. That can be as simple as a couple of wires touching together or an actual straight key. You'll need a paddle. I tend to go the paddle route. I have used a key, but paddle, I'll explain that a little bit. A paddle will, it'll tell the radio or the keyer. The keyer is something that forms the dits and DAWs for you. It'll tell that device to send strings of dits or strings of DAWs. So that's what a paddle is there. You'll need an antenna analyzer. It's a somewhat optional item, but at the cost these days for something like a nano VNA, which I'll talk about later, it's something that you might as well get. Various wires and cables and odds and ends, power and antenna support. And I'll talk about these in a little more detail here. So for the tools, you're going to want a soldering iron. A basic soldering iron will do, but it helps to have something a little more high quality. Nonetheless, if you get the $20 Amazon special soldering iron, you're still going to be able to get this job done. Screwdrivers, of course, are going to be something you'll need. There are screws involved in putting together the radio if you're going to be using a case. I suppose you could get away with not using a screwdriver if you're just soldering without a case. There are actually no, there's screws. You need screwdrivers. Multimeter, that's pretty essential to doing anything with electronics, but you don't need anything fancy there. Diagonal cutters, you're going to need those in order to make the cuts of the leads once you've soldered them in. Needle nose pliers, that's another universal. You might as well have that tool for just about anything you're doing, so get needle nose pliers. Helping hands, you know those two little alligator clips that are you can articulate into the position you need to hold something for you? Those are really handy for assembling electronics. A magnifying glass is really handy, especially if you are starting to need reading glasses like I am. They can be handy for inspecting solder joints. Unless you have amazingly great up-close vision, a magnifying glass is a pretty good item to have. And a big hammer, because why not? All right, for the transceiver, I've tried lots of different kits, and this kit by far is the most user-friendly in terms of assembly and even using it. But the biggest aspect of this kit is that it's super user-friendly for the assembly of it. The instructions are very detailed. It's like Hans Summers, the designer of this. He basically holds your hand through the instructions. So your hand is held through the entire assembly of this, and with good persistence and patience and attention to detail, you will get from beginning to end of this build with a working radio. The initial radio he built was called a QCX, and I built one of those, I think it was back in 2018 or 2017. Great radio. It's essentially the same as what I have pictured here, but bigger. He doesn't currently sell the QCX, but does have the QCX Plus, which is a bigger version of the QCX in a bit of a different form factor, where the display is on the front. So when it's sitting on a bench, you're viewing it from the front. And then more recently, he released the QCX Mini, which is what's pictured here. And this one I highly recommend. It's not as available right now since it's a fairly new product. They were all snatched up by people, including myself, and there's another production run in progress at the time of this recording. So you can order one, but you'll have to wait a little bit. If you're in a hurry, you can get the QCX Plus, and that'll come right away. But this kit is high performance. It's a high performance radio. The design is excellent. You'll be able to pick out signals with the best of them. It's not a top shelf, IC 7300 or Elecraft radio that can pick out just any signal with all the interference. But this rig will do, 90% of that. And it's way more than adequate to make some contacts on the air and do a really great job. It's got tons of functionality, including actually, which I try to say don't count on these, but it's got a CW decoder, so it can actually decode Morse code on the air, assuming the signal's pretty solid and consistent, which is rarely the case on HF, but nonetheless, that's a feature that's available. It's also got a feature where that decodes what you're sending, so you can kind of check that you're sending your Morse code well. It's low cost. It's $55 or $80 with the case, plus shipping. And as I said, it's a really easy to build through-hole kit. It comes with all of the surface mount components pre-soldered, so you're actually getting a partially assembled kit. You mainly do some winding of toroids, and then you solder components and stick it in its case. Really great kit. Can't recommend it enough. And for an antenna, I'm recommending an end-fed half-wave. There are tons of other options you can do. You can build your own dipole with just some coax and wire if you happen to have it. But this is the one I'm recommending. It's a kit you can get from QRP Guys called the QRP Guys No Tune End-Fed Half-Wave Antenna. It's a very long name, but very descriptive. You put this kit together by winding this toroid and soldering it in place, and soldering a couple of other components here, and cutting your wire to length. And then you use that antenna analyzer I was talking about to make sure you get the wire cut to resonance. There are other ways to do that, but I recommend doing it with an antenna analyzer because it will be quick and save you time. You do supply your own wire with this kit. We'll talk about sources for wire a little bit later. The only thing I don't like about this kit is, you see, the wire here is meant to be wrapped around this section in a circle, not a figure eight, and that makes it actually very difficult to deploy because you're essentially twisting the wire as you wind it around this. So a good thing to use, and a lot of people that do portable operations use these, is a kite winder. This is a miniature one. It's about the same size as this, but it allows you to do a figure eight wind of the wire around like that. So you're actually, just winding the wire around that way, and you can literally just hold this winder as you're pulling the wire off. It'll actually pull itself off. You can walk with the winder and it'll flop back and forth and unwind itself. So it's a much easier way to deal with the wire. So I may modify this actually. I might cut this section out and just wind the wire in a figure eight on here. We'll try that out, but I haven't done it yet. And for a paddle, you can go pretty cheap and do pretty well these days. There are huge range of paddle options out there, from this thing, which is $30, and there may even be cheaper versions of it. I mean, if you have a 3D printer, you can print your own using the plans you can search for online. And of course, there are super expensive paddles like Bengali paddles and others. But this thing right here, I got this off of Etsy. I think it was Morse code paddles or something like that. It's a good 3D printed design. It's a little bit bigger than my thumb, I think. So it's not a big thing, but it's pretty lightweight and it does the job pretty well. So you can find something like this on Etsy or eBay, or just search really for anything that says paddle or iambic. I actually prefer a single paddle, this is a double or iambic paddle, but you know, do what works basically. I know people have built their own. There's plans for that online. You can build out of wood and strips of metal. There's so many options. And the antenna analyzer. I believe there's a presentation about this in today's BayCon presentations. The Nano VNA, this thing's kind of become a little bit of a revolution in the last few years. It's a super inexpensive vector network analyzer, or VNA, and you can use this as a quote-unquote antenna analyzer. So there are a couple of different models. There's this smaller screen version and a bigger screen version, and there's one that's in a plastic case, and there's all sorts of different variations. So what you'll want to try to do is search for the kind of the model you want and make sure it's a reputable seller. There's a Nano VNA group where you can see kind of there are clones of this that aren't well made. You can see what the differences are. So with all that in mind, you should be able to find one for around $43 to $55 or so US dollars. You can go higher than that if you're getting the one that has a bigger screen. I find the bigger screen probably would be useful. It's a little bit tricky doing the touchscreen stuff on this, but it's more than met my needs. It's a really, really handy device to have. With the latest firmware, you can actually even measure coax loss and coax length, doing time domain type stuff with it. So it's a very, very handy device. Wires and cables and other items. You won't need a whole lot to get running with the equipment I'm talking about here, but short coax cables can be handy with BNC connectors on them. Various adapters like BNC to BNC, you know, a male to male BNC, different things like that. Those will be handy when you're dealing with this stuff. A dummy load can be a really good thing to have. In fact, I'd almost say it's necessary. You can get those from QRP guys and QRP labs and off of eBay. There's a lot of different kits, but search for QRP dummy load and that'll get you what you need. Antenna wire obviously is going to be necessary. I'm talking about like the end-fed half-wave antenna that I mentioned. That's a wire antenna. So you're going to be using lengths of wire on the order of tens of feet to build an antenna like that. Like a 40-meter end-fed half-wave antenna would be around 66 feet of wire or so. Headphones you're going to need. Just about any headphones will work with the QCX, and you're going to need a 3.5 millimeter stereo male-to-male cable to plug in your paddle or whatever you end up doing. You can sometimes paddles have you just directly wire them, but you'll need something to hook that up. And the places you can get these sorts of things, there's a place called the Wireman that's got a lot of wire. And Pactenna has a lot of different items you can get. And also, if you don't want to build your own antenna transformer thing, you can get that from Pactenna. Cables Online has a bunch of different cables and adapters. And of course, on eBay, you can find pretty much anything. Just search for it. Another supplier that I recently discovered is amateurradiosupplies.com. They have a bunch of different things as well. So lots of different places you can get things. You just have to kind of look around. And for power, If you have a 12 volt power supply of some kind, great. That something you can plug in that might be like a benchtop power supply that's current limited, that's great. But as far as battery power goes, this is something I've found. It's called a Talent Cell is the brand. They sell their packs on Amazon, and I think they start around 3,000 milliamp hours. But the cool thing about these packs is that they are a lithium battery pack that starts that puts out 12 volts. So it's got a 12 volt connector that will put out the nominal 12.6-ish volts that a lithium ion pack will do, and a USB output, so you can use it to charge your phone or whatever you need to do. So these can supply more than enough power for the QCX and other things. I actually initially used this one on an FT817. And there's lots of other options. Anything that can supply up to an amp and 11 to 14 volts is going to work just fine for the QCX. It's not terribly picky, but if you want to get the most power out of it, you'll want to go with something like 14 volts, up to 14 volts. There are different options. You have lithium polymer. That one can be a bit dangerous if you're using unprotected cells. So if I do use that, I tend to try to stick with the smaller ones. Lithium iron phosphate, that's the this one here, lithium iron phosphate. That's a newer technology, lithium technology, and they are very safe, very tolerant of overcharging, undercharging, etc. By the way, don't do those things. And then good old SLA, or sealed lead acid. Those are those heavy, those 6 or 12 volt packs you can find in alarm systems and the sort. Those are the least desirable, both in weight and size, and the number of cycles and actual capacity you get out of them. So if you have one and that's all you have to power your radio, that's great, use it. Otherwise, try to go for something that's lithium based for lightweight and energy density. And then supporting that antenna, it's a wire antenna. You got to get it up in the air somehow. My favorite thing to use are these fiberglass fishing poles you can get on eBay. I search for FRP 7.2 meters. They're a little bit harder to find right at the moment. Usually there are a lot of options, but generally speaking, you can find them, and they're not actually 7.2 meters. It's more like 5.5 meters, but it's more than enough to get your antenna up in the air. You can usually get them for under $30. There's a picture of me using one here on a summit in Nevada. You can see my wire going up to the center here, and I've got a little ice cream lid cut out with a few holes in it to run the wire through, and it slides down onto the top of the fishing pole there. So the wire goes up to the top and then down off and tied off in the distance in an inverted V setup. But if you don't want to use a pole, or if you can't use a pole, if you're having trouble getting it set up or whatever, trees, if there's nearby trees, you can throw your wire over a tree. Especially if you're doing QRP, it's not going to really affect things very much. And there are other extendable poles, so you can just sort of search for an option. But this is the least expensive and most efficient option I've found. Very lightweight. These poles weigh less than a pound. I can't remember the exact weight, but they're very lightweight. So that's all the equipment. But how do you actually do this? How do you get on the air? Here's what you're going to need to do. You got to get the equipment and put it together. You got to set up a place to do assembly, and I strongly recommend having a place that's undisturbed. So don't do this on your dining room table if at all possible. Set up a place that's going to be left undisturbed for days, because you may want to take several days to put the radio together. Some of the more simple stuff, you'll maybe get it done in under an hour, but the radio could span days. Depends how much available time chunks you have. Acquire your tools if you don't already have them. And I do recommend building the radio first. You'll want some of the other parts as you go along, but you can build the radio first and then get yourself set up to be able to practice the Morse code to get on the air. The QCX has a practice mode, so you can actually essentially put it in practice mode and it'll emit the tones and everything for Morse code, but it won't transmit, so you don't need to use a dummy load in that case. I advise always having a dummy load or antenna hooked up to the radio in case you do accidentally transmit, because if you, on the QCX, this isn't the case with expensive commercial radios, but on the QCX, if you try transmitting without anything hooked up, the final amplifier stage of the radio can quickly overheat and destroy itself. So use that practice mode. And then the other aspect of this is, and maybe the most time consuming, actually definitely the most time consuming, is learning CW or Morse code. I practiced using apps like Morse Toad. That was a fun kind of game kind of app on a phone. It was both iOS and Android. But really the thing that finally got me going was signing up for CW Academy. That's there's a club called CW Ops, and they have a program called CW Academy. And essentially what that does is it sets you up in it's kind of a classroom type setup. So you have a couple of weekly meetings with your instructor, and you're given homework in between those. You do homework each day, and you have accountability for learning, which is really what I needed. I needed that kind of structure and accountability around learning so that I actually pulled it off. Another one I've heard about that I think is really great, and I really want to check it out further, is Long Island CW Club. They have classes and on-air events and Zoom meetings and all sorts of resources to help you learn CW. In fact, I do plan on signing up and improving my CW even more. So I'm definitely going to pursue that. But some key points are to practice every day if possible. When you're learning, that's extremely important. But practice in small, like less than 15-minute chunks of practice. You don't want to burn yourself out when you're learning this. So, do 2, 3, 4, 5, 15-minute chunks of practice each day. Even if you only do 15 minutes, you're still going to make progress. It's that familiarity. And I can't stress enough to listen, because that's actually the hardest part of learning CW or Morse code, is being able to decode it. And, there's decoders on radios, and even the best of those isn't going to be as good as the decoder in your head. So just listen, and you'll get it down. Now, here's a really great reason to learn Morse code, and I have this point over here. 5 watts equals 80 watts. And what I mean by that is that 5 watts of CW is roughly equivalent in practice to 80 watts of sideband or voice audio. It just gets out way better. The signal to noise ratio for the bandwidth that CW uses is far lower. So you're actually going to be able to make contacts as if you were using 80 watts of sideband. So go for it. And then for the technicians out there, if you're getting into HF, and this is your path to getting into HF, here are the parts of the bands you can use. You can actually use part of the 80 meter band, 40 meter band, and 15 meters. And of course you can use Morse code or voice on 10 meters, but if I were just getting into this, the QCX I pictured is the QCX Mini that I built is for 30 meters. But if I were to build one band, and especially if I were a technician getting into HF, I would build it for this 40 meter band and use it there. It'd be super useful. You can make some pretty good local contacts and even some farther away contacts, depending on your antenna and the time of day on that band, but it can be really, really versatile. So I just wanted to point that out. You don't have to be a general or extra class to get into this HF stuff. You can jump right in as a technician. And that's all I have. So if there's any questions, let me know. If you want to reach me, you can reach me on email at rex@ke6mt.us. I have a website, ke6mt.us, and on Twitter, I'm at rex_ke6mt. Thank you, and have a good day.
Rex, that was really great. Thanks a lot for doing that presentation.
You bet. Yeah.
And by the way, I have to really, I got to plug your website. It's really nicely done. And
oh, thanks.
It's very inspirational for those of us who don't get out to operate in the field as much as we'd like to. So I'm jealous of your adventures.
I'm feeling a little behind. I have probably at least 5 or 10 soda expeditions that aren't on there. So, gotta get back into it. You know how those things fluctuate. Sometimes you feel like riding and sometimes you don't.
So Rod, do we have any questions queued up for Rex?
We had a whole bunch of comments, which are very complimentary, mostly around, I think somebody even citing you as being responsible for getting them into HF. So nicely done, sir. I'm interested in what you think, because we're dealing with building small kits, very affordable kits, for using this as a method for getting students interested. Because I mean, it's a big leap to get past CW for the students. But on the other hand, my experience lately with students has been, hey, they got a much more malleable brain than mine ever was. And when I have introduced them to CW, they seem to pick it up crazy fast. So what are your thoughts on that?
Yeah, I think it could definitely be a great route. My own kids haven't been that interested in learning these things, but when they've tried, because Morse code is fascinating, no matter who you are. It just, I think pretty much universally, even my friends that make fun of me for how geeky I am are fascinated by Morse code. And so back when I first started learning Morse code, my young kids would try and pick it up a lot faster than me. So I think it's totally true. And also, I find the interest in assembling things pretty much universal as well. And it's super fun to, pick up a hot soldering iron from the right place and learn how to solder too. So I think there's definitely that could be a great path, because, you get this transceiver kit for $55 and, some shared tools, and you're off to the races.
Well, and as parents, the investment you make on a kid to get involved in any sports or any activity of any sort is like, how many hundreds of dollars. This is not, we're not buying big rigs for these kids. So I think it's a very interesting aspect to it. Like I said, I get most of my experience when I was trying to learn CW with my kids, them being in the back seat, picking it up way faster than I was. So there's always an issue. Hey, we've got a question here about what size of hammer you think is appropriate in your toolkit.
No size is incorrect. I have an assortment. Sometimes the bigger, the better. I have one all the way up to 3 pounds. So, as long as you can swing it. That's a good question. I like that.
You've covered off a lot of bases in that presentation, so I'm not sure if there's a whole bunch of gaps. Were you thinking of anything in particular? Sorry, a little technical problem.
Actually, I had a bunch of questions in my mind, but they were kind of all covered in the presentation. So that was
exactly where I was going. I was taking notes along the way, and to your credit, Rex, you kept ticking off every single question I could think of asking you.
So I'm sorry, go ahead, Rex.
This presentation is based on a blog post I wrote, I think back in 2017, where, I had lots of time to think about all the different aspects that I wanted to talk about. And it was a topic that was near and dear to my heart because, having a family and, just living in the Bay Area, there isn't a lot of extra cash all the time. And, unless you're George with the radios, but that's a different story. But no, I'm not trying to pick on you, George, but
Yes,
you
you
know,
are.
it's just a nice thing to know that there is a path. I didn't discover it right away when I got into ham radio, and I really wished I had, because I totally would have built a QCX and learned Morse code right away. Instead, I did a bunch of other things, and it took me a while to discover this, but it's something I care about a lot. I want people that are new to ham radio, if they want to try HF, I want them to know it's not going to be a huge barrier as long as they're willing to put in the time.
Here's a good question that has come in. How about a soda peak around the Bay Area? Unfortunately, I'm far away, but if you live in the Bay Area, what's a first couple of soda peaks that you should pick?
Well, an easy one you can drive to is Mount Umunhum. Gotta love that name. And another one that is a little bit of a hike, and George has done this one, is Coyote Peak. It's one of my favorites, actually. It's local, and it's a quick hike, and plenty of room to operate if you go to the peak where, you know, there's not a bunch of people. You can set up all the antennas you want. Quite a bit of equipment up there, though. So occasionally there's some HF noise you'll get from the equipment in the transmitting towers up there, not from the transmissions themselves, but yeah, Mount Umunhum. There's lots of different peaks around here. Mount Umunhum is an hour drive, even though you can see it right above you. So,
okay,
it's a spectacular view.
What bands do the QCX operate on?
So the QCX comes in. You choose your band when you order it. And that determines the low pass filter parts for it. And you can get it in 80 meter all the way through to, I think, 17 meters. Somebody will correct me on that, I'm sure, if I'm wrong. But and I'm pretty sure it goes to 17 meters. And I know of people that have converted it to 15 meters because they wanted to go just a bit higher. But once you start getting into that range, the through-hole components and other things and the tolerances of the different parts aren't going to work as well. So,
yeah, I had one other quick question on gear. So you covered all of the essential radio stuff, and I'm curious, like when you go do a SOTA event, what is the non-radio couple of essential items that you always take with you?
Well, that really depends on the trip. Some of my summit activations will be as a trail run, and so I'm bringing as little as possible. When I'm really diving into the radio aspect of it, I'll bring as much radio stuff as I can think of bringing, and probably a chair. A chair is a new one for me. I've put off getting a chair for years and years, and then finally my wife and kids got me a backpacking chair, and I haven't left it behind on any of my activations since then. But yeah, basically you want to stay warm or cool depending on the time of year. So I bring whatever I need to stay warm and comfortable. That's actually the biggest thing is what do I need to be comfortable while I'm operating? There's another little piece I didn't mention on this presentation because it's not totally related, but there's a mini Leatherman. It's a Leatherman Squirt LS4 or something like that. There's one they have that has wire strippers, and I bring that along whenever I can.
So Rex, Rod and I are laughing about this because Rod and I have bonded over the ES4 Squirt, realizing that you're the other person that sees the value in it. So now there's three of us.
And it's discontinued.
No,
so
more
you
of
can
us.
actually find it out there, but it's going for an atrocious price.
So I was actually steered toward it by Adam K6ARK. I think a lot of people know who he is. And I bought one used, and then I think a spring fell out of the scissors or something, and I sent it in to Leatherman for warranty repair, and they gave me a brand new one. So if you want a new one,
maybe they're holding back some stock. Okay, we'll have to go work on that. Okay, and hey, tell me about this 146.58 frequency thing.
Oh, okay.
There's a topic.
Wow. Did that come up in the chat? I
It
didn't see
did.
that. Okay. So 14658. So I George came to me and several other portable operators talking about starting an adventure frequency. And I was when I got the email, I was like, oh my God, I'm not the only one, because in various areas, SOTA operators have their frequency they'll use with their buddies, and Southern California kind of has an agreement of kind of what frequency they want to use, and I always thought I wanted one for Northern California, or even greater, like maybe the West Coast or something like that. So George came to me with this idea of an adventure frequency, and there's a lot more to this, and I probably won't go all the way with this, but I saw this email from George and I was like, well, the very first thing we have to do is get agreement on using a frequency. George had a lot of other amazing ideas to go along with that. So I started just pushing on the SOTA NA groups.io, SOTA North America. I started just pushing the idea there, and then it got written about by another ham on his blog. K0NR, I think it was, that wrote about it. So the idea has gotten some traction. I hope it gets more, because it's nice to have a frequency that's agreed on that's not the national calling frequency. Because 146.52 is great for calling, and it can work really well if you're not hearing anybody around and you need to see if you get an answer. It can be a great frequency. But if it's already being used by rag chewers, or maybe even somebody else doing SOTA or something, it's nice to have an agreed upon frequency. To bring even more meaning to this, George's idea, it has to do with using tones to trigger certain actions and let people know that you're on a summit. And there's a whole bunch of stuff that George could talk about that I love and I hope to see happen soon. So yeah, George, just let me know when you need help setting that up on Black Mountain.
Yeah, well,
I
actually,
think that is a great topic for a video
yeah,
on this very channel.
I think it could be. When I first posed the idea, I came at it from the standpoint of as a backpacker listening on 5.2. I didn't hear anything a lot of times, especially you're down in a canyon and you're not going to hear anything. And it always struck me as kind of a repeater administrator kind of guy, that there should be a remote receiver listening on some frequency, and if somebody presses the trigger button, that it alerts people that someone needs to communicate. And that was sort of the germ of the idea. And then when I bounced it off of Rex, I thought, we really need the community to want to do this. It can't just be some like crazy idea. And so you were very positive about the thought, and I kind of ran with it from there. So I think what we're going to wind up doing later this year is look at putting something together. I so already happen to have a radio. I picked up a Motorola CDM 1550 for 2 meters, and also we found some extra pass cavities that we could put at the repeater site and not interfere with our repeater. So we're going to stick that on one of the ports on our repeater controller with an extra tone decoder board that scans PL tones. And depending on what PL tone it hits, it does something. So we'll just sort of leave it at that. But the whole notion was there's sort of at least 2 levels of this. The first level is simple, which is let's just agree on a frequency to chat on, so that if the frequency lights up, someone's activating. And then if we want to go to the next level, if you have some repeater in the area equipped with a decoder, then maybe a different tone would be an emergency alert. So we can kind of take it from there. So that's sort of the germ of the idea.
Yeah,
very good.
Great.
Well, that seems to be the questions I've got.
Rex, thanks so much. This is really, really great, and motivates me to kind of get off my backside a little bit more to get out. So looking forward to more adventure write-ups on the blog and the website. Thanks.
You got one more lover right here. I've got that ES4 as well. That thing's amazing.
Oh, Marcel, you're in the brotherhood of the Leatherman Squirt.
One of my favorites.
I can just envision everybody, as you're announcing what the Leatherman is, everybody has their paper and pencil out and they're writing the number down and they're ready to pounce on and buy them on someplace. And then as soon as you said they're no longer in, production, everybody's pencils drop and the heads hang, and then they go to eBay and try to buy them at auction.
the Leatherman Squirt Futures market is oscillating wildly as we.
Yeah, here we go.
Well, there you go. All right. So
All right.
Marcel and John, do you want to go ahead and take it for the last drawing?
Yeah,
before
you
we
bet.
wrap things up.
Absolutely.
Sounds good.
John, what time is it now?
It's last drawing time.
That's right. This is the final drawing for the day. Remember, this was a fundraiser for everyone. Thanks for everyone who chipped in. What's our total ticket count like, John, for the whole day?
We are over 4,800 tickets for today. So that is a lot of tickets. For those of you that have attended a BayCon event in the past, we have nowhere near that many tickets that we sell, during the day. So thank you everybody for your support. That's fantastic.
Yeah, that's really huge. So just want to say that again. We got a whole bunch of items here at the end to put into the final drawing, and then we'll cover the winners of the silent auction. All right, so first up is another Pactenna, the mini end-fed half-wave antenna for your SOTA needs. 40-foot antenna wire. This is great. I'm sure Rex would recommend one of these as well. Who's this one going to, John?
Okay, so if I win this one, I'm winning it, legit. Oh, there we go. 1342. That doesn't sound like me though. 1342. 1342 is another double winner. 1342 is Paul Kostka. I think he won your battery earlier, Marcel. So
He did.
wow, now he has a battery. He's won big.
That's going to be great
Paul,
for your
Paul. Feel free to donate more money later if you care to. You've won pretty big today. All right, who's the next?
All right, the next one we've got a really cool ADSP2 speaker donated by Mike K6QFO. $130 MSRP. These are no longer available, so pretty exciting to see who gets this.
Okay, 1206. Don't have to scroll too far. Michael Gitschill. I believe Michael's name was said earlier as well. He donated that?
That's him. So you want to probably pull that one again. All right, good job, Mike.
See, you can't make this stuff up, right? Yeah, anybody thinks there's shenanigans going on. 3,000, let me get the color right. It's green, so it's hard. 3,004. That's funny, wins his own stuff back. 3,004 goes to a new name. I'm glad to see it. Seth Lavender. Lavinder. Lavinder. Seth.
Cool. Congratulations, Seth. That should be a great addition to any ham shack at home. Got another one here. This is a great one. It's the printed copy of the buddy pull in the field manual. So some folks like to use buddy pulls as well, and this is a great option. Who's this one going to, John?
This is going to 945. If I tilt my camera right there. 945 goes to Eric Schmidt. I don't think we've had a winner, or Eric hasn't won yet today, I think. 945. Yes, Eric Schmidt.
Cool. Congratulations, Eric. Should be a nice addition.
Two entries on Eric there. Yep.
All right. This should be a fun one. This is a Hustler CG144 2-meter collinear antenna. I had to look this one up. Mike also donated this one to the drawing. It's got 5.2 dB of gain. It's a huge antenna, 85 inches tall. I just want to see who puts this on their car. Maybe a little Fiat 500 with this antenna on top. That would be pretty slick. Who's this one going to, John?
All right. And the winner is, what is that? 3325. 3325. Lisa Kidder. Congratulations again, Lisa. I think you won earlier today.
Yeah, awesome. All right, that should be a good one. All right, here's a first of 3 bonus prizes for this round. We're doing another glow-in-the-dark super elastic signal stick by Signal Stuff, supporting ham study and exam tools for all your remote exam testing needs. Who's this one going to?
It's going to 2426. 2426, Bill Bodeker. Yeah, 2426 Bill Bodeker, Boedeker, Boedeker.
Cool. Awesome. Congrats, Bill, for getting one of the signal sticks. Those are really fun antennas for your HTs. All right, the next one here is a pretty fun one. It's local pickup only. This is a 5 kilovolt amp isolation transformer. You will want to lift it carefully. It is 120 and 240 volt capable. I was reading through the manual on this thing. Pretty slick little setup. If you have a test bench at home and you want to isolate it from your mains, or if you need a step up or step down transformer for maybe your water pump in the backyard or a well or something, you know, whatever works out. Great option here. Also donated by Mike K6QFO. Thanks very much for providing. This one's a new inbox. So John, let's see who's going to go to, and hopefully they're local.
We're not liable for any hernias picking it up. 571, the number's 571. 571 is Rod Stafford again. Stafford. Bought lots
Cool.
of tickets. Thank you, Rod.
Congrats, Rod. So hopefully you'll be able to arrange pickup for that one. It should be a nice little addition to your shack. All right, and then the final one, I won the Pactena earlier in the drawing here, so I made sure to put one more antenna in the bucket. So now there are 3 signal sticks going out. Who's this one going to, John? One more chance for you to win it. I'm giving you this chance.
Man. 30. That's probably you, Marcel.
That's probably me.
It is you, Marcel.
All right.
So hold it. No. Sorry.
Not.
30 is different. 30 is Kyle. I'm just going to spell it. Dettke. Detke. Kyle, Dettke.
All right, Kyle, congratulations. You won a beautiful glow-in-the-dark super elastic signal stick. So we'll be reaching out via email to all the winners from the drawing today. Thanks very much again for everyone that contributed and picked up tickets today. John, anything else you wanted to add?
Yeah, I just wanted to add that again, like Marcel said, thank you so much for supporting the club. I think everyone on here benefits and values from the club. We appreciate it. Wanted to let folks know that you know, that you can give throughout the year as well, right? On our BayNet page or on the page that you go to today, there's a big red easy button that says donate. And so you can use that to donate at any time. We're a 501c3 charity, as George mentioned. For those of you that work for large employers that actually match donations, I know that BayNet is listed as a Benevity matching fund as well. So if I give to BayNet through my work, they will match me dollar for dollar up to a certain dollar amount. So if you want your donation to maybe go a little further, check with your employer and see, because I do know, again, for those in the Bay Area where that's a common thing, that employers match gifts to charitable organizations. We are listed there. So thank you for supporting BayNet, and I will turn it back to you, Marcel.
Sounds good. And George, I think you want to join me for this one. We're going to go through the silent auction results. So you probably already figured out some of them, but you'll get to wait to the very end for figuring out who the number 2 winner was. So we'll start this right up. First one was a BeagleBone XM, $145 value, and the top bidder was KI6 ETL for $60.
You'll know what to do with it.
Yep. And the second item number 8, the BeagleBone White. This is a pretty cool one of the originals. And the winner was also KI6 ETL. He also did the top bid.
You'll know what to do with that too. By the way, the pair of those is worth more than 125 actually. That
with the sound
that's
cable.
The audio adapter, the audio codec board. So
I couldn't find the price for that because it's so rare. So yeah.
It's a good combo.
All right, next one, Microbit X, fully assembled. And this one is John Kim for $75.
Oh, cool.
Thanks for your
great. Congratulations, John.
All right, and the Hamcrafters K42 keyer. This one was actually pretty popular in the auction today. Antonis, AA6PP, thanks so much. 140. Really appreciate that donation to the club. That's a great way.
Oh, that's cool. And that's got the decoder in it too. Very nice.
All right, George, you get to talk this one up.
Okay, this is a signal generator. Doug talked about it in his presentation earlier today. So this is one of our top prizes. Thank you very much to Elecraft for donating this. So Marcel, who's the lucky buyer? Oh,
also Antonis.
Excellent.
bid up a whole bunch of other folks on this one. There was very active bidding on this one today. So thanks everyone that put in a bid, and congrats Antonis for topping it out.
So the San Francisco Radio Club is well represented at the event today. Congratulations.
Yep. Also heavily contested, the QRP Labs Ultimate S3. This one was going with a lot of bidders. And this one went to Arnie, K5ARN. Thanks very much for a $125 bid on this. Congratulations.
Yeah, congratulations. That's actually quite a few items. There's a lot of optional accessories in that particular kit of parts there. So that's got multiple projects in there. So I'm sure you'll enjoy it.
All right. And the other QRP Labs one, this was the transceiver kit. And this one went for $100 also to Antonis. So thanks. Looking forward to a big check in the mail for George.
Now you can make sure your radio works with your signal generator to test the radio.
Yep, there you go. All righty. And the very final one here, George, you can take this one.
Oh, go ahead and read the two winners.
All right, the top two winners were Jason, KM6KTK at 420, and Frank, AF0DR for 410. So this one was very heavily bid up to the last minute. There were bids coming in on this one. Made sure to shut off that timer right at the right spot. And congratulations, guys. Great value. And I'm really sure you guys are going to have a great time with this.
Yeah, that's really great. Thanks a lot to Digilent for donating both of those. That's really fantastic. Good deals on both of those, like you said, Marcel. So I'm sure those guys will enjoy it. There's some great videos from Digilent on YouTube about how to use these with the software. So I'm sure you'll all really enjoy that. Congratulations.
Absolutely. All right, it's all yours, George.
All right, so that pretty much wraps it up. So we can pull up everybody in the team here up on the final YouTube video. I want to wrap things up in a couple of minutes here. So first off, we really hope that everybody who attended this and watched the live stream enjoyed it. We had a ton of fun pulling this together. It was very different doing this online as opposed to doing it in person. So it was really great because we got a lot more people to attend and really reach out all across the country and internationally. So that was really awesome. We hope you learned something. We hope you got motivated to build something, and we hope you got motivated to go operate and get on the air. So that's really what this is all about. We would love to get feedback. If you have any tips and suggestions on how we could do a better job or what you liked, we'd love to hear from you. You can send an email to mycallsign@qsl.net. So that's kj6vu@qsl.net. So send any comments you have there, and we'll share it with the team and figure out what we want to be doing the next time to do better. If you would like to hang out with any of our Bayonet members, if you're in the Bay Area, there's no problem because there's plenty of repeaters, as you already heard about. If you're outside of the area, because of our digital repeaters and even our analog repeater, we do have multiple ways to connect. So our IRLP node's available for connection from an analog repeater with IRLP. If you're on digital, on Fusion, you can connect to the WW6BAY-room. And if you're on DMR, then you can always tune us in, like Marcel is waving his radio. You could tune us in on talk group 31075, which is also the hangout for the Workbench podcast folks as well. So if you want to just be part of our Bayonet community, you don't have to be in the Bay Area. Everybody's welcome. Would love to have you. So feel free to join us in any of those places and hang out. So I really, really want to say a big, big thank you to our speakers, because each of these speakers not only did a really great job delivering their content, they're really super knowledgeable. Ham radio is all about sharing, and it's all about helping each other out. And they're very generous with their time, because the videos that you saw took a lot of time to create the content and then record the videos and then say that wasn't good and re-record the video until they got it the way they wanted it. So everybody put in a lot of effort. So I really, really want to thank the speakers. So Marcel, Doug, Alan, Mike, John, Dennis, Mark, Rex, all you guys are awesome. Thank you so very much for being so willing. Frankly, the easiest thing to do in putting this event on was reaching out to our potential guest speakers, and they agreed. They signed up like immediately. So without them, we wouldn't have an event. So really, from all of us, we really appreciate it. Thank you. Also, obviously, we want to thank our sponsors, Flex Radio as our primary big sponsor. One thing that I didn't really talk about, and one of the reasons why they're the platinum sponsor for this is because we are working with Flex to figure out how we can get a remote station set up here in the Bay Area. So it's too early to spill the beans on exactly how we're going to do it and what it's going to look like, but stay tuned, and we'll have some news hopefully over the next couple of months on how we might be able to set up a remote station for people to use. And a lot of that is due to the really kind people at Flex bending over backwards to help us out there. Also, Digilent, obviously, for the great prizes, Elecraft and Pactena. Thank you guys so very much. And Rod, let me kick it back to you for a minute.
Yeah, I'd like to just acknowledge that in bringing this like motley crew together, it was all George. And I think, you know, for anybody that's been around Baynet for a while, it's always George, right? So I want to make sure that I acknowledge that, because there are very few times that I can say no to George when he asks.
That's
because
why I
it's
asked you.
usually something cool, something important, and quite doable. So yeah, I got to watch how I said that. Okay. But anyways, thank you, my friend. You do a great job for the organization. And I really appreciate it on behalf of everybody in the club and even your friends in the Great White North.
Yeah, thanks.
And I wanted to jump on the heels of that and say, you know, George knew Rod previously before COVID, but with COVID, clubs and, you know, borders and boundaries have all dropped down. And so huge appreciation to Rod and Vince, who aren't even located in the Baynet area. I mean, it may be the Hudson Bay net.
We're across a locked border, my friends.
Right. And Vince, who didn't have a lot of FaceTime today, but certainly did a fantastic job queuing up all the videos, keeping everybody behind the scenes on cue and on deck. Huge shout out to you, Vince, for your silent work today. Really appreciate it.
Hey, thanks, John. It's a great pleasure to be here. Happy to help out, and I'm excited to see how we all ended up today.
Well, you know, this is really, I think, what sets ham radio apart. One fella told me one time, he said, I'm into photography, woodworking, and ham radio. Nobody gave me a free camera and nobody gave me a free table saw, but plenty of people were happy to help me with free radios and antennas and get me going. And that's really true. We're really very lucky. And I think that, like you were saying, John, the community doesn't end at the edge of your city. And Rod's been a big inspiration for really reaching out and growing the community. And I want to thank you for that, and everybody else who chipped in. I didn't have to ask any of you twice. I mentioned it and you're like, I'm in. So without you, we wouldn't be here. There's just a huge amount of work that went into this program. So really thank you guys from the bottom of my heart, and from everybody else too. So I do
one more
mention,
chip in.
Yeah, go ahead, chip away.
Yeah, no, Vince, I wanted to call out a big thanks as well. Vince has been doing all the kind of AV and queuing up all the new presentations in the background today, which is really, really awesome. We did tons of tech rehearsals leading up to this to try to put on a clean event, and it really paid off, I think, today. So thanks for that. The other note, George, I don't know if you want to talk about the fundraising target now, or do you want to cover that later?
No, I was just going to touch on that now, Marcel.
Go for it, please.
Yeah. So this thank you really is to all of you that bought tickets and donated, because the only way we keep the radios on the air and in the repeater sites and fixed and all that is by your donations, and you're buying the drawing tickets. And our goal was $3,200 in order to hit all of our basic costs plus the project cost this year. And we did. So we made the number because of you. Thank you very much. And I hope you enjoyed getting some goodies out of it as well. But really, because of your generosity, we're able to do what we do. If not for that, then we wouldn't be here either. So to all of you who bought tickets, thank you from the bottom of our heart, and from all of the 400 plus people who use the Baynet system, both locally and remotely. It's enabled by you guys that donated. So thanks very much.
I don't think KQED ever says they hit their target, do they? So we're a little different.
Yeah,
we're a little short. We're about 10% short of our target.
Right,
your last
right,
matches
right.
right now, 2 for 1. We have a new donor that's going to double your match.
Exactly. Tote bags next year. All right. So last thing is all the videos that were presented today will be available on the YouTube channel for BayNet events. They should all be posted sometime later this week. All the presentations will be posted on the BayNet website under resources. And the audio from several of the presentations will also be in the Ham Radio Workbench audio feed. And I was about, as the wrap here, I was about to thank, you four guys, but we already just did that. So I don't think we need to do it again. But again, thank you, really, from the bottom of my heart. And from everybody else, thank you so much. Thanks, everybody, for joining us. 73s, and we'll catch you on the air. 73s from BayCon 2021.
7-3.
He's got 2.
Of course, I would expect nothing less.
And
And
we going to
one
chill
says
some more
Radio
signal
Shack
sticks
on
now
him
too?
too.
Mine's in the
Oh,
safety
wow.
deposit